module, which will be doing that transfer injection tomorrow. That one was built in Germany, but it was put together by many other countries as well. I always point out, I'm from Spain. We did the thermal control system. If that fails, I'm gonna be very disappointed in Spanish engineering. But yeah, let's see. I was pointing out as well that the tradition of having one of the astronauts as part of the closeout crew, it goes way back, right? You always want at least one of the folks that also put their blood and sweat and everything out there, as well as one of the folks that are also strapping themselves to rockets, right? Also accompany the ones that are actually getting in and going up into space. And so that's a really nice touch as well. You can see they are a very active rocket down there.
And also noting just now here at the press site, it is starting to drizzle a little bit, so there's a little bit of rain coming. But the big thing was just having no lightning in the area for tanking, which there wasn't, so they tanked the rocket. And of course, they are in replenish mode with all of the propellants, the liquid hydrogen and the liquid oxygen. And there is still time in the window for things to clear. As mentioned earlier, it's 3 hours still. So despite the wind, some clouds, and it raining a little bit here, it's not a concern right now.
I do like the two shots we've got here. One at the top, like inside the white room, and then the other one is the bottom of the rocket. Yeah. Stand by. We are going to work on getting some of those weather updates and that sort of stuff from Ryan here in just a bit. But the clock continues to count down, and we are approaching, it says L minus 3 hours and seven. We're approaching L minus 3 hours. Does anybody, either Sawyer or Alex, which one of y'all, do we want to talk about why it says L minus? I thought it was a rocket. I thought it was T minus. Who
Well,
wants
since you're
that?
laughing, Alex, you want to take it?
Okay, I can take that one. So yeah, the L minus clock is just a very convenient clock that counts down to the opening of the window, right? In reality, the clock that they use at NASA internally for their procedures is what is called the T minus clock. And now, in many other rockets, right, say Starship and Falcon 9, for example, those clocks are the same. They just don't have any holes. They don't have any differences in between those clocks. But in some other rockets, like the Atlas V from ULA, or even like Blue Origin also uses different L minus and T minus clocks. And of course, here with SLS, the T minus clock counts down with the procedures, with the different events that are happening during the countdown. So, for example, they have one hold before propellant load starts, and then another one after it ends, and then another one closer to the final portions of the count, basically at what will be L minus 40 minutes and T minus 10 minutes. So in that sort of gap, there's going to be like a 30-minute hold, planned hold, where the L minus clock will be minus 40 all the way down to L minus 10. Meanwhile, the T clock will actually be T minus 10 minutes in holding. And that sets them up, like, as I said, right? Each hold here goes with key items, key events on that countdown before propellant load, after propellant load, and right at the end of the countdown before they go into that terminal count, which is the most active part of the countdown before launch, of course. And so it's one of those things, as I usually say, it goes with the procedures, right? It's not like the L clock. As I said, it's a very convenient clock that just counts down to the opening of the window at 6:24 p.m. Eastern Time.
All right. watching all the different things going on here, but we're still waiting for them to finish closing that hatch. And I don't think they're quite. You can actually see the hatch open on the right-hand side. They're sort of like swung out towards the camera a little bit.
And this hatch closure is going to take a little while too, because it's not like you just close a door at home and that's it. Or, you go outside and there's two doors, some arenas that have the air in them have that airlock type thing. It's not that simple here. So these are pressure sealed hatches, especially the interior one. And that has to be a perfect seal because, again, it is the vacuum of space you are going out to. The last thing you want is even the tiniest of air leaks while you are 250,000 miles away from the Earth. So, that is why they are super careful. Even something as small as a human hair in the seal can be an issue. I believe it was Crew 6. They were starting to close the hatch and they weren't getting a good seal. So they reopened it, they checked it, and it was a human hair that legitimately was in the way that was causing them to get the exact perfect seal they needed. They removed the hair, closed it up, and that mission launched just fine. So that's why they're going to take a little bit of time with that. Then keep in mind, you now also have a second hatch, which is something we're not used to seeing. This second hatch as well, you have to work on the pressurization between the main capsule and then the gap in between the outer sort of hatch there, which this is all a shroud part of the launch abort system. So that'll jettison away about 5 minutes into flight. But you still need to be able to close it and have everything neutral kind of in between the two. So they have to do that, then they have to close it, then they have to lock it. And then if it's in the right spot, it's also locked so that if they have to open the Orion hatch from the inside, it will also open both hatches. All of these little things have to happen just right and exactly tight and in the right order to be able to safely allow for the crew to make it to space and be through. So that's why, even though the crew is in and they're there, we still probably won't see the actual hatch fully closed and sealed until probably close to 90 minutes until launch, if not a little bit either way, because at times when it came to propellant, they were well ahead of schedule. And then when it came to getting the crew to the pad, it was a little bit behind. But as we mentioned, they got plenty of time to make up. And with those holds built into the count, it's not something that they're super worried about. So, of course, hopefully we get to see that crew once they're in space in a little bit, and we'll see the White Room crew doing their thing. So, speaking of crew, we have another member who is joining our crew here for this launch stream. I believe we have Alice with us. Let me see if we can make sure we get her comms in there as we continue to watch them do the ice checks here. Make sure that there's no ice leaking out anywhere on the vehicle, because if there's a big splotch of ice outside the spray-on foam insulation, the Sophie, then that would indicate a leak, but doesn't look like there are any. So hopefully there are no leaks there, and hopefully I didn't leak the fact that we have Alice coming on. Sorry, Alice, do we actually have you now?
I'm sorry, all this excitement. I was sat watching and I had myself on mute, so I was listening into everything you've got going on. And what an exciting time to be joining in with the stream again. Obviously, this morning we were doing the stakeout, getting ready for the crew to come and join us. And now they're ready and strapped in and ready to be launched. But I believe we should really kind of check in at this point. It'd be a good time to us to get an idea of what's going on with the weather. Ryan, have you got any updates for us of how it's looking? Because we're looking favourable, I believe.
Well, that was the forecast at L-1, and I'm just going to bring up the weather radar very quickly because we have been seeing a slight increase here in the amount of rain showers popping up over the east coast of Florida. Of course, as I said, the moisture kind of forms clouds on the coast and then it's blowing towards the west coast of Florida this way, which is why we can see the rain moving in this direction, but it's literally forming out here on the coast of Florida. So this is something we're going to be keeping an eye on. You can see some bigger splotches of rain starting to form, but these are the pop-up storms. So the downside is that it's a storm. We obviously don't want a storm on launch day. The upside of a pop-up storm is that it pops up and then moves out of the way pretty swiftly, and we have a 2-hour window to play with, which is what that 80% favorability is for. So we're going to be keeping an eye on these. If the rain does hit our cameras, we will have to be bagging them up, but they are moving out of the way. Fingers crossed. We can see some clouds on Fleet Cam at Port Canaveral. Thanks to Rusty's for allowing us to host this camera. But yeah, fingers crossed they move out of the way in time for launch. These are pop-up storms after all, but we will be keeping an eye on the radar.
That weather looks a little bit more like what you and I used to back home in England rather than what we're used to over in Florida. What's going on over there, Sawyer? I'm not used to this kind of weather when we come out to the Cape.
Yeah, we're literally just putting a cover right now over the camera that I'm on because it is starting to rain here a little bit. But that's the thing about Florida. If you don't like the weather, wait 15 minutes. That's the joke. And in just a couple seconds, we'll have exactly 3 hours to wait. And there we go. Under 3 hours to go now. Chat, I can already see the threes. Everyone's excited for that. Yeah, so Mother Nature hopefully will get excited too and clear out for a little bit. And once that happens, we may still see some pop up clouds like Ryan was talking about. But at the moment, there's definitely a bunch of clouds in the area, but they are moving out of here fast. And that rain just came through really quickly and also kind of slowing down already. So, weather wise, the only thing I could say is it's Florida. And if you've ever been to Florida, you know exactly what I mean by that sentence.
And we still have 3 hours before they have that launch window opening and a 2 hour window for us to be able to perhaps move things if that weather is a problem. Isn't that right, Alex?
Yeah, and to be fair, this was already talked about yesterday with the launch weather officer at that press conference that we had a day basically yesterday, right? And so he said they were expecting probably some showers in the morning first, and then a bit of a gap, and then another one sort of around the afternoon time frame. Well, it's 3:24 p.m. now, 25, I guess. And so, yeah, it's afternoon time. It's what you would expect in Florida, right? And there's that onshore flow of that moisture, right? It's going east to west. And so there's going to be a point where all of that will get out of the way. And that'll hopefully be when the launch window opens and we don't get any of those rains, right? And so there's still 3 hours left to that opening of the window. And then again, another 2 hours after that for basically until 8:24 p.m. Eastern for them to take off. So plenty of time for that rain to just go away.
Go away. Exactly what we want to see. Now we're looking at
And
that countdown clock. Oh, go on ahead,
I was
Alex.
gonna mention because Philip made a really great point in the back channel that I'd rather be, worried about this weather and the rain and everything than having to worry about technical issues and this umbilical leak and this other thing and now helium flow stop or something like that, right? You don't want to be worried about that. You want to be worried about things that you cannot control, which is the weather yet. The weather,
Exactly.
we cannot do anything about it, right? So the only thing that we can do is just watch it, take a look at how things evolve, but you're gonna do much. Leaks and whatnot, you have to go out there, stop the count and things like that. We don't want that sort of stuff.
Absolutely not. But it is looking like we've got quite a crowd that's gathering over by the countdown clock at the moment. I understand there's somewhere in the region of 400,000 people expected to come out for this launch. Julia's updates earlier saying that it could possibly even be more. I know I've been looking at all of the Facebook groups that have been chatting about where's the best place to go and watch. A lot of people are thinking maybe they would just stay a bit further out away from the coastal areas, because obviously you can see this launch from a little bit further away, which is a great opportunity for lots of people to get involved in. We are waiting at the moment for all the hatches to close up. We had some images before of that closeout crew. Are we ahead of schedule right now? On schedule? Where do we think we're going to look to get to that 6:24 p.m. liftoff, guys? I'm going to put that one to Sawyer because you're really the one that's keeping an eye on things on the ground over there. Are there any updates for us?
Here, Alex, can you take that? I'm working on more astronaut stuff.
Ooh, how exciting.
Yeah, can you go ahead and repeat that, Alice? I'm really sorry. I was paying attention to other updates.
There's too much interesting things going on right now, which is
Yeah,
definitely
yeah.
not a bad thing, right? I'm just saying we're watching them close up right now with the hatches. We can see that closeout team on your screens. Are we on schedule right now, or are we a little bit off, do we think?
Yeah, so right now they're preparing for closing the hatches. Of course, the first one will be the Orion hatch for the crew module. That's the innermost one of the two. And then it'll be the launch abort hatch, the launch abort system hatch, which you can see there with a little window in the middle. And so those two hatches will be closed over the next hour or so. The last hatch, that launch abort system hatch closure, is expected to be closed around the L minus 1 hour and 40-minute mark. So this is still a good hour until we get to that point. So there's a lot of preparations here because there's also if you think about this, right, there's the crew capsule inside, there's a launch abort system outside. What's in the middle? Well, what's in the middle is a whole contraption that they need to use in order to be able to, you know, swiftly and without any weird things going on there, access the capsule, because there's a gap, of course, and so if you don't want to fall into that gap or anything like that in between both, there's this whole contraption that they use in order to be able to get inside without any worries about falling and whatnot. It also creates its own sort of bubble, its own environment as well, because that gap in between the launch abort system shroud and the crew capsule itself is normally neutralized with nitrogen. But if you think about it, having people in that sort of environment, it's not great, right? Nitrogen is inert. We can see they are part of that system that they use there to be able to do that. And so what they do is before the the closeout crew gets there, they switch over to air. Because if you only breathe nitrogen, you're not getting your oxygen.
Yes, ma'am. Verify left restraint indicator.
We're just going to jump in.
Position
There we
is
go.
arrow to arrow.
I see arrow to arrow.
Thank you.
We're going to wait for them to do another comms check, and then it won't happen. So, Alex, please carry on with your train of thought.
Yeah, so I was just pointing out that there's a lot of things that they need to take out once because they were closing the Orion hatch, the crew capsule hatch, but now they need to remove a lot of the other auxiliary hardware, if you want to call it like that, and then close the hatch on the launch abort system shroud. And so it takes a while. That's why they also board this early. We were talking about it was 4 hours when they were boarding the capsule, right? Why do they do that? Because there's a lot of things that they need to go through. There we can see that system, that closure of the Orion hatch.
I heard you, Ryan, mentioning earlier that you recognized a couple of these people.
Ryan Earth 1.
Go ahead.
Yes, sir. You are primed for hatch opening.
Integrity crew is primed for hatch opening.
Hatch opening at this point.
Hatch opening?
Maybe they're doing some
I
testing
think they
to see
mean
whether
prime for it, as in they would be the ones to open the hatch now if needed. Maybe.
we're all learning here as we go along with a lot of this. This is the first time for any of us to be watching humans get on board the SLS on their way to the moon. So it's very exciting. We're learning as we go, which is always fun. I was saying, Ryan, that we recognize a couple of the folks in this closeout crew. I believe number one is a member or a fan of NSF, but number two is one of the backup crew. Is that correct?
And WCC.
Just waiting for that message from Mission Control.
And also, yes, getting confirmation that is what they mean, is that they would be the primary ones to open the hatch because it's easier for them than it is for the closeout crew.
Are they going to say anything, or I don't want to talk over them? But yeah, that is correct. Number one is Taylor Hose. He is the lead closeout crew, or lead of the closeout crew, and we have number two, Andre Douglas, who is backup.
And of course, can't forget number one, Taylor Hose, who's the lead there of the closeout crew, wearing the number one, the guy in charge. And as I mentioned before, an NSF viewer, so thank you, Taylor. Had a flat tire to deal with on the way to work this morning, and talk about a rough day to have a flat tire. But then again, Orion doesn't have tires, so we have that going for us, which is nice.
There's always something to have to deal with. Can you imagine having the most stressful day of your work life and having a flat tire? Maybe that means that all of the bad...
Yes, of the many special guests we have with us.
They've obviously talking to a lot of people down at Banana Creek that are cutting into us. I was going to say, they're obviously hoping that all of the bad juju has happened before they even got to site today, because this is looking like a very positive move forward for most of the crew that are involved in this. We've got a lot going on, and I did want to mention before we get too into it, thank you so much to everybody that's coming into the chats. We will do our best to get through questions. Obviously, we're trying our best at the moment to cover exactly what we're seeing on the screen as much as we can, and we will get to them when we can as well for you. A reminder that I know Das was talking before about the merch that is available to members on our website. Go and check them out. This is really a historic day. And isn't it great to be able to have some merchandise available to you that you can have to remind you of this event and being part of this and being able to watch it for yourselves? Go check it out. I'm wearing an Artemis 2 shirt from our website right now. I know that Ryan and Alex have both got their patch t-shirts on as well, ready for today. It's a pretty big deal to all of us to be involved in this stream, and it's a very exciting one for us to be watching right now. And we keep seeing the venting images that keep coming up. There you go. Ryan's modeling for us perfectly. Alex is also primed and ready to go with his t-shirt. Look at those. Absolutely gorgeous. And I can assure you I've got a patch ready to go on its way to me to go on my board behind me. As you can tell, I'm a bit of a patch fan, to say the least. Why not? If you've got the opportunity to have a really cool patch, always add to your collection. It's always worth it. I'm telling you, go check out the shop right now. It's available to members already, and it will be available to the rest of you as soon as that hatch is fully sealed and ready to go. And we've been watching the videos of the SLS. You can see it there on screen. We keep seeing these venting images going on, and I keep seeing people saying, is that a leak? It's not, it's venting, but I'd love to be able to talk a little bit more about why it's venting. Alex, could you let us know what it is that they're doing right now with that?
Yeah, so every single vent that you see there, either from the engines or from the rocket itself on the tanks up there, though that is gaseous oxygen. Technically, what you're seeing is actually the moisture in the air getting so cold that it forms those clouds, right? But that's because they're venting oxygen, that it's very cold. It's gaseous oxygen. In the case of the engines, it's because they're doing what they call engine bleeds, right? And so the liquid oxygen is in those pumps and it's boiling off continuously, and so they're bleeding off, essentially releasing the excess oxygen that is in those pumps through those little lines on the side of the nozzles on the engines. And then up top you see the liquid oxygen tank on the core stage is also venting. You may see a little bit of venting as well from the entering cryogenic propulsion stage, the second stage of SLS as well. All of those vents, as I said, those are because of gaseous oxygen. The thing that you will not see being vented unless there's a major anomaly of sorts is the hydrogen. That one is instead reclaimed either by different lines that run through, for example, the main tail service mast umbilicals, or in the case, for example, of some of the umbilicals on the tower, those are also there to reclaim a bit of that hydrogen as well that boils off, and they just put it back on a flare stack. There's a flare stack out there. It's probably not very visible right now because it's daylight, but if it were nighttime, you will see that flare stack. People will probably be asking us, why is there a fire out there on the pad? Is that normal? Yes, there's a flare stack out there, just like you will see, for example, LNG refineries and things like that. You will see that sort of stuff where you burn off the really highly flammable substances, like in this case, hydrogen.
Excellent explanation there. Thank you for that, Alex. You know, one of the questions that have just come in the chat, people were asking about why they're filling the rocket ahead of the crew. They've said, isn't it dangerous? I would have thought it would be dangerous either way. You've got the crew waiting for it to be filled underneath them, which would obviously take a long period of time, or you sit and once it's fully fueled. Now, there is a purpose behind them refueling as early as they have. Ryan, could you talk to us a little bit about why they started to fill as early as they did in this countdown?
Yeah, so the reason they start fueling so early is because they need to make sure that everything is stable and ready to go before they can send crew out to the pad. It's a slightly different procedure than what we're used to with, say, Falcon 9 with SpaceX, where they will send the crew out to the rocket and then fuel the rocket. This way, NASA has always done it. They did it with Shuttle, Saturn V. They fuel the rocket, make sure everything is stable. We see the same with the Atlas V, and then they will send out the flight crew to the pad to board the rocket. Now, I wouldn't say there's necessarily one method which is better than the other, but it's just a different way of doing things. And this has worked for NASA over 135 shuttle missions, over a dozen Saturn launches before that, Gemini, Mercury. So if it ain't broke, don't fix it, you know. SpaceX obviously has decided to go a different direction, but both procedures work, which is why they start loading fuel on this rocket so far in advance, because they simply need the time to.
Absolutely. And it has been a long countdown today. We've been started at, well, I say we've been, it has started since 49 hours and 50 minutes ahead of what we're up to now. We're now only about 2 hours and 45 minutes away from that launch window opening. There is a 2-hour launch window, remember, today. So if there are any delays due to weather, for example, they'll be able to hold off for that time and be able to make it all the way up to 8:24. But so far, so good. It's looking really good right now, even though we are seeing quite the cloud coverage in that image right now. As Sawyer keeps reminding us, this is Florida. These things can change in just a case of a very short period of time. So we are keeping an eye on that and making sure that we keep you updated when we know more about it. We've been listening in a lot to what's going on with NASA. Obviously, we are not NASA ourselves. We are NSF. We are a bunch of space nerds that just want to get together and talk about this incredible opportunity to send humans back to the moon for the first time since 1972. And we appreciate the support you're giving us today. We have got people on the ground. We've got people behind the cameras. We've got people remotely working all of this to make sure that you guys are getting all the information to keep you updated with what's happening on the ground, which is very exciting to see. I keep seeing lots of updates happening on there. We're seeing venting going on right now for the SLS, and it's all looking very, very good right now. Now, the countdown clock has us with our next big check-in coming in at around 2 hours and 20 minutes. That's when the crew module hatch service panel install closeouts will hopefully conclude. Oh, look at that. We're getting some images from inside. I was going to ask you guys, obviously they've been in there now for 30 minutes maybe. Surely at this point, they've got to be, wondering what's happening outside, hoping for the best. Are they doing checks? Are they able to do checks for 3 hours, or do they have some rest time in this window, do you think? I'm going to throw that one out there to you, Alex. What do you think?
Yeah, they probably have a little bit of rest time there, but obviously one of the things that they can do, you can see all of those 3 panels, the multiple switches and everything. They can switch between different views of information that they want to check. And so I believe the one on the left, if I'm not mistaken, I'm going to go out on a limb and say that's probably the nav ball sort of thing, right, for them. And then you've got also what appears to be some kind of ascent profile there as well. So they probably are having all of this information in front of them, being able to check out how some of these things are going. Now, I will say, though, it's really much sort of quiet right now for their side of things, because for the next 2.5 hours, basically, everything's just going to be on the ground, right? What I mean is that everything is just going to be the closeout crew closing everything out, and then people at the Launch Control Center going through all of the data and confirming that everything is good to go. Things will get more active when we get to the final 10 minutes, where we're talking about, the propellant conditions and things like that, why they load the propellant before the crew isn't that dangerous. Well, one of the things that happens is that once the rocket is fully loaded, the tanks, for example, they are maintained at the same pressure, and it's a low pressure environment. You've got always the same temperature because the propellants are always boiling off. And little physics trick, if your thing is boiling off, it's not going up or down in temperature. It's always maintaining the temperature, right? And so there's no transients, as they are called. There are no changes in both pressure and temperature. So it's a very stable condition. And that's why they load the rocket first, and then they put the crew. Now, when do they get some more activity? When do those conditions change? During that terminal count. In those 10 final minutes, around 6 minutes before launch, they start the core stage tank pressurization. And so just a few seconds after that, about, if I'm not mistaken, 20 seconds after that, the launch abort, 40 seconds after that, sorry, the launch abort system now becomes available, right? And so that is when things are active on the rocket, when things actively change in terms of temperatures and pressures, and so that is when that really changes. But yeah, for the crew itself, they're just gonna be basically hanging around, looking at all the systems in those different views on their displays and things like that, and whatnot. So, but everything will be on the ground crew.
Speaking of the displays, I believe Sawyer's got some more information about what it is they're able to look at in the capsule.
Yeah, you were talking about those displays. This is a model that they have inside the the press room here. So you can see what these screens look like and all of the individual physical switches as well. So you can see a lot of touch screens, but still a lot more push buttons than, say, we're used to, say, with what we see with the Dragon capsule. So you can see things that they would have to physically flip and switch. And once they're in space, you can see they have sort of targets. They've got their nav balls. They've got all of their attitude indicators, altitude/distance indicators in this case. So if you were sitting in Orion looking up at that center thing, that's what you would see. And of course, you see some of those manual handles as well for when they do the rendezvous proximity ops to manually fly Dragon. So all of these switches that you see here, it's a lot less than the space shuttle, that's for sure. But this is a look at the console that they're using. Of course, just not with a Microsoft joystick, but with an actual one in the middle.
I was going to ask, do they have that Microsoft joystick on the machine, on the vehicle? You know, why not? It could be quite fun. We are still waiting for them to finalize all of those final closeouts for the hatch. You can see the closeout crew working diligently there. They are working around the clock. They've also been in quarantine ahead of this launch. Is that correct, Ryan?
Yes, everybody who will be directly interacting with the crew has been quarantining. So they might not necessarily have been quarantining in the exact same location, but they will have been making sure they haven't been, interacting with the outside world, so to speak, to make sure they don't pass on anything to the crew. Because, the absolute last thing anybody wants is for any crew member to come down with an illness when they are on the far side of the moon. So, yeah, that's a very important procedure to go with there. And even, say, leadership from other agencies when coming to visit the crew, they haven't been allowed to actually interact with the crew. For example, I believe it was the president of the Canadian Space Agency and the senior leadership official from the Royal Canadian Air Force. They visited the crew because, of course, Jeremy Hansen is a Canadian flying on board this mission, but they couldn't actually physically meet the crew. They had to do it through a window, and the crew were in a quarantined off room. So it's really important that those procedures are upkept to keep the crew safe when they're about to head into space.
Absolutely. For those of you who are just joining us, we are currently about 2 hours and 38 minutes away from the window opening, the opportunity for launch of the Artemis 2 mission from Kennedy Space Center in Florida. I feel like this is a really good time to start talking about what this mission is about and what we're going to be seeing them do over the next 10 days if launch all goes to plan, which is looking very likely it will do today. Alex, can you talk to us a little bit about the trajectory of what we're going to be seeing over the next 10 days of this mission?
Yeah, so the crew will be going out first to a 24-hour orbit, as it's called, because it's going to be basically looping around for about 24 hours around the Earth, I should say. Now, that means for at least the first flight day, there we can see that little trajectory graphic. Thanks, Ryan, because I know you did the one. And so they're going to be very close to Earth at the beginning for that first day. That is on purpose, because this is the first crewed flight of Orion. And so they need to test all of the systems. They did already an uncrewed test with Artemis 1, right? But first time with crew. So first time will be that 24-hour orbit. Then the service module will fire to do that translunar injection and go all the way out there to the moon. There'll be some correction maneuvers along the way that are planned. Maybe some of those might be not needed, basically. And so they're going to be doing that closest approach, that flyby of the moon, going around, being able to test Orion with crew in the lunar environment. That's very important, and doing some science as well with observations of the far side of the moon. And then they're going to be coming back using that moon flyby, that very useful gravity of the moon, basically. Some trajectory correction burns here and there. And then finally, close to the Earth, of course, they're going to separate from the European service module and enter Earth's atmosphere. And that'll be another very important step, of course, because they're going to be testing that heat shield, right? And hopefully this time around, it doesn't have any weird things going on with spallation and things like that they found out on Artemis 1. They modified the entry corridor this time around, the entry profile of Orion, so that it doesn't go through that kind of environment. So lots of different tests. As I said, they had that 24-hour Earth orbit. While they are in that orbit, right after they separate from ICPS, there's also an added bonus sort of test objective here, which is they're going to be turning around, they're going to be flying around that ICPS, that upper stage of SLS, and there's a few targets as well for the crew to target, basically. And so they're going to be using that to test also manual controls of Orion around a second target, around a second object, which will be very much needed when they have to dock to a lander in the future, hopefully on the next mission.
Yes, because we're going to be seeing different mission profiles going through with the Artemis program. Artemis 3 has changed from being a landing mission to Artemis 4, and next one will be more of a docking mission. I'm sure we'll be getting more on that when Max joins us later, who spoke to Jared Isaacman yesterday. If you haven't seen that interview, go and check it on our YouTube channel. You've still got 2 hours and 35 minutes until launch, so there is time to watch that and come back and watch this at the same time. If you're anything like the rest of us, I'm sure you've got multiple screens up at the moment anyway, watching all of the things that are going on right now. We are watching the SLS. We have got the crew inside the Orion capsule. We did have a question that came in on the chat about integrity. Why is it called integrity? I'm going to throw that one to Sawyer if you're able to chat right now, Sawyer.
Yeah, I mean, the crews get to name their vehicles. It's very rare to have a vehicle now that doesn't have a name. So obviously you had the space shuttles, Enterprise, Columbia, Discovery, Atlantis, of course, the best one, Endeavor and Challenger. So those got names. The Crew Dragons have names. You got Crew Dragon, Endeavor, Resilience, things like that. So why not name the Orion capsule as well? And so since this is the first crew flying in it, they got to name the capsule, and they chose Integrity, which, when you think about it, it makes sense. It's keeping all of humanity together and the integrity of human spaceflight continuing out to the moon. So I think it was a great choice for a name.
I agree. I think it's a really great one. I also love the fact that they've given a name to their zero-G indicator, RISE, paying homage to the Apollo missions as well. It's good that they've really thought these things through and how they've approached this about how they are representing all of humanity on this mission. Ryan, I know you've had the opportunity to speak to the team. What have you heard of from them, and what do you think the impression is that they've got about this mission?
I mean, they are very much communicators and they're very good at that, which I think is going to be really key for this mission, because one of the most exciting things is that it's all well and good being told about the far side of the moon or being told about features rather on the lunar surface. We can see that in satellite imagery, but it's something different entirely when somebody has actually been there and told you what it was like, what it felt like. I'm not sure if I want to know what it smelt like inside of Orion at that point of flight, but those senses will exist as well, and that's really, that's the special thing about it. Because if you have a friend that goes on holiday to a specific location, they can tell you like what the restaurants were like, what the hotels were like, what the weather was like, what the general vibe of that place was like. You can't do that on Google Street View. Other Street View services are available, right? You just cannot do that, but you can do that through somebody who has experienced that and can convey that experience, and that is what this crew is really good at doing.
Speaking of Street View, we've got Julia out on the road. She is there in Titusville. What's going on, Julia?
Hello again to those who are tuned in and our folks in the studio. I am Julia Bergeron, in case you didn't catch me earlier.
How are things going over there, Julia? Give us an update of what you're seeing on the roads.
I don't believe Julia can hear us right now.
Hello again. This is Julia Bergeron. I am live out on US 1 in Titusville, Florida. I am right across the street from Rotary Riverfront Park, located in the Dogs R Us parking lot, and there is a lot of traffic behind me. As I said earlier, what's going to happen as people start lining up for launch is that the folks who worked at 6 a.m., guess what? They're done with work, so they are now joining the crowds and trying to get their steak if they're not going to stay at home as a local. The kids, they're also out of school, so our traffic has definitely picked up. Most of what is behind me across the street, directly on the lagoon, that is taken, so there is increased sidewalk traffic, meaning most people are now parking on the street and walking.
That's the joy of live TV, everybody.
Oopsies.
Sometimes things don't go quite to plan. Julia's having a few communications problems because there are so many people gathered along the coastal area that are using up all the bandwidth of what's available to them. So we will try and get back to Julia and get an update from her shortly as soon as we can. For now, we are back to watching the SLS, which is what everybody is gathering in the Titusville and surrounding areas to watch. The countdown to launch is still looking really good. We are coming up to 2 hours and 30 minutes away from that opening of the launch window, which is very, very exciting. Now, this is one of my favorite angles, I think, of the SLS. I think you get a better perspective of just how large this vehicle is. Alex, how does it compare to other vehicles that we've used in the past?
Well, believe it or not, if you've seen, for example, Blue Origin's New Glenn, it's about the same height. So it's about 98 meters tall. The SLS rocket, the core stage is 8.4 meters. I don't know any of these in feet, so if you only work in Imperial, I'm really sorry, but these numbers I only know them off the top of my head in metric. And so the one of the things that is really important is that this is a big rocket. Of course, the Saturn V was bigger, and there's other rockets out there that are even bigger, like Starship, for example, 122 meters tall, 9 meters in diameter. But still, this is the biggest one, or at least the most powerful one that is carrying crew out there. So just saying, like it's not a small rocket, even though it can be bigger, and it was supposed to be bigger in later iterations. Now those have been cancelled, but it's still quite a big rocket, despite not being the biggest, I guess.
It's not always about being the biggest, I guess. Oh, look at that. We're getting a really great view right now from one of the closeout crew members that's looking to be part of that closing of the hatch. Now, it seems to be multiple hatches that we're seeing in this image here, Ryan. Can you tell us about what it is we're looking at?
Yep, so this camera is in the corner of the white room, which is at the end of the crew access arm. We're currently looking down towards the Orion hatch, which is the black kind of tiled looking hatch, which is, well, number 4, as we could see there, was working on closing and securing that hatch. That is one of 2 hatches that needs to be closed today, because of course Orion, the capsule, has its own hatch, but the launch abort shroud, which actually encases Orion during the first 5 minutes of flight, that of course has its own hatch, which is the one you can see there behind number 3, which is still open. So once the Orion hatch is closed up and sealed, they'll then be able to close up the launch abort system hatch, and that should be happening over the next 10 minutes or so. Crew module hatch service panels all sorted out is scheduled for in about 8 minutes time. So, but again, there's a reason this countdown is 49 hours long. It gives them wiggle room. So if something isn't happening bang on time, don't worry about it. There's still some wiggle room in here. And on top of that is a 2-hour launch window. So nothing of concern at this point.
No, at the moment, the only concern seems to be the weather. Sawyer, I know you were hiding from a little bit of a rainstorm that came over. How's it looking right now on the ground?
I mean, the rain has definitely stopped at the moment. It's still breezy here, that's for sure. But the rain has slowed down. The clouds are still kind of here, but they are pushing westward. So, Julia, apologies, but it looks like that's heading your way. But better for us here, closer to the launch site, with the winds moving west to east, blowing those troublesome clouds, we'll say, out of the way, especially given that this rocket will be going northeasterly. So, blowing those clouds away to the west is a good thing.
Absolutely. A big thank you to everybody that's coming in with your questions in the chat, and a big thank you to all the support that's coming in as well. We've had this $50 tip come in from Scott, who's asked a question. When Artemis 3's mission was changed, did the crew that was assigned get moved to Artemis 4 to save their training, or are they now going to miss landing on the moon? Was there an Artemis 3 crew that was announced before all of the change around, Alex? And if so, are they going to change?
Well, if there was any crew internally, there's certainly not one that we got to know publicly, right? You never know what sort of crews might be training internally inside NASA before any of this happens, of course. But definitely there was not a crew for Artemis 3 that was publicly announced or anything like that. So, from all that we know, there's no change there. Now, I would expect that because in about a year and a little bit, right, we should see that Artemis 3 launch happen. we will probably get some kind of crew selection in the next few months. I would not be surprised if before summer comes around, we will get that sort of, especially if Artemis 2 is already out the way, right? Like if Artemis 2 is already out the way, I think during the ignition event a couple of weeks ago, or rather last week, it's been a long while for my brain, but it was last week, and the sort of, suggested that some of the mission, because one of the things is that the actual mission profile and concept of operations, it's not being laid down just yet, right? It's not being laid out just yet, and so because of that, they still have to work through that, and that may be over the next couple of months. So I will suspect that perhaps that'll be when we will know the crew of Artemis 3. But no, there was no, at least again publicly, we didn't really hear anything about any sort of crew that have been selected or anything. So in that sense, there should be no change. I would not be surprised either if we get to know the Artemis 4 crew as well at some point later this year, because if you remember, this crew was selected or at least was announced 3 years ago this week. It was at the beginning of April 2023. And so that was 3 years ago. If you can imagine something like that for Artemis 3, 4, etc., we're bound to get some kind of crew announcements at some point. But
Yeah,
we'll see.
I expect so. A big thank you to Scott again for that tip. It's really great that you're able to support us here on NSF. We are just a bunch of space nerds that are trying to do our best to answer your questions and give you the best coverage and trying to make it as entertaining as possible. I was moaning earlier that the other streams were a little bit boring and a bit stale. But given how exciting today is, it shouldn't ever be boring or stale, because I don't know about the rest of the team here, but I am super excited and full of anticipation about what's going to happen. But for now, we're going to go back to the playback.
With all the excitement around crew flying to the moon on Artemis 2, some of you may be wondering, what about Artemis 1? Well, for those who don't know, or want a quick refresher, here's the mission that was key to this flight. Artemis 1 marked the return of NASA flying its own rocket and its own crew vehicle to space since the end of the Space Shuttle program in 2011. Built with some shuttle legacy hardware, the first Space Launch System rocket began to take shape inside the Vehicle Assembly Building at the Kennedy Space Center in Florida. It then rolled out to the pad, many times, while working out the growing pains of a new rocket and systems. There were leaks during testing, hurricanes, and other minor issues that plagued the vehicle during testing and during 2 launch attempts in August and September of 2022. Thankfully, there weren't any crew aboard to worry about. Well, living crew, that is. In place of real astronauts, there was a Moonikin named Captain Moonkin Campos to help test radiation exposure. In addition, 2 torsos named Helga and Zohar also took part in measuring how the body would be affected by radiation while flying through the Van Allen belts, as well as while staying in lunar orbit. Oh, and Snoopy and Shaun the Sheep were also along for the ride as zero-G indicators. The first launch of Orion took off in the early morning hours of November 16th from Launch Complex 39B, the same one being used for Artemis 2. After a near-perfect launch, the Orion capsule and European service module began their checkouts while still orbiting the Earth, including deploying the large solar panels. Then it was time for TLI, or Trans-Lunar Injection, sending Orion on its way to the moon, the first human-rated spacecraft to make that journey since 1972. After about 6 days of travel, Orion finally reached the moon. The spacecraft came within 130 kilometers or 80 miles of the lunar surface before eventually entering a distant retrograde orbit where it remained for 6 days. That saw the spacecraft do the complete opposite of that close flyby and get as far away as 64,000 kilometers or 40,000 miles from the moon's surface. On December 1st, Orion and the ESM left the moon's orbit, beginning a long journey home. The capsule splashed down in the Pacific Ocean near San Diego, California on December 11th, following a fiery re-entry. It was placed inside a Navy ship and returned to shore, where our own cameras were able to capture what Orion looked like after spending 25 days in space and traveling 2.1 million kilometers or 1.3 million miles. While Artemis 2 won't enter orbit around the moon, Artemis 1 helped NASA understand how their spacecraft, thrusters, and heat shield work, and gave them confidence to send these 4 humans back towards our own natural satellite.
from Sawyer, who was able to give us a bit of an idea of what was going on with the initial Artemis launch, Artemis 1. And of course, today we are looking at the Artemis 2 mission that's going to be taking off in a little over 2 hours and 21 minutes. And a big thank you to Sawyer, who's just taken a bit of a break. And I believe we're currently going to be joined very shortly by Max Evans, who spoke to Jared Isaacman last night and got a bit of an update of what's going on with the Artemis program after Artemis 2 and beyond, which is very exciting. We'll get to Max when he's already set up. So let's have a little bit of a catch up on where we are right now. Thank you so much for joining us here on the NSF countdown to the launch of the Artemis 2 mission. We are currently, as I mentioned before, 2 hours and 20 minutes away from the launch window opening at 6:24 p.m. local time in Florida. It is a 2-hour launch window, and we're very hopeful right now. It's all looking very positive that things are going to plan. Alex, the crew are on board. What do you think's going on right now?
Did we lose Alex?
Sorry, it took me a bit of a while there to unmute myself. Yeah, so right now, you mean like through their heads or things like that, through their minds?
Everything. I mean, what are they doing in that capsule?
Right now, it's mostly just waiting, right? As I said before, it's just down to the ground crews monitoring all of the systems and getting ready to close out all of the hatches. We saw the Orion hatch being closed out. The next thing will be the launch abort system hatch being closed out. There we can see that white room work. They need to remove, as I said before, there's this sort of contraption that is in between that gap from the shroud covering Orion to the Orion itself, and so they need to remove that contraption as well, that purge barrier, as it's called. And so they need to tear that down and being able to close the hatch of the abort system, the one that is open right now there on your view. And so that'll take a few more minutes. And by minutes, I mean count like maybe 20 to 40 more minutes, right? For that to happen. Per the timeline, it should be at L-1 hour and 40 minutes when that outer hatch should be closed. So still about 40 minutes from that point in the count. And so once that gets going, it's another basically 1.5 hours of just waiting for the people in the launch control center, in the launch control room, going through all of the data, right? They're going to be going through everything and making sure that all is ready to go for terminal count, those last 10 minutes, very active point in the count. That's when things will get more exciting for the crew at the very least. Of course, for the ground crews, as I said, they have a lot of things ahead for them.
It's looking like we're very much on track for things to go as planned for that 6:24 p.m. Launch window opening. It's been a lot of hurdles to get through this far, Ryan. Am I right that they've seemed to be very much on track for what they released to the public?
Yeah, exactly. We just crossed beyond 2 hours and 20 minutes, which is in the official countdown is when the crew module hatch is going to be closed up, and then the launch abort system hatch is scheduled to be closed up at 1 hour and 40 minutes. So we are within that window. Again, just because we're 3 odd minutes beyond that point of crew module hatch closure, and it's not entirely wrapped up yet. Again, don't worry about that. There's plenty of margin in the countdown here, and for the time being, we look to be bang on time. So 47 of this 49-hour countdown seems to have been happening right on schedule.
Which is definitely a very good sign for this launch of the Artemis 2 mission on the SLS. We're getting some views right now of the SLS itself, the big orange vehicle. We had a question come in earlier, which I thought was quite entertaining, that asked, why is it orange? Why did they paint it orange? I believe Max is just joining us on the stream. Do you want to answer that one, Max, in your very orange t-shirt?
I guess it fits the program quite well, doesn't it? So essentially what you are seeing is Sophie, or spray-on foam insulation, and its natural color is a lighter tan or a lighter beige, and it only gets more orange the longer it sits in the sun. And a prime example of that is how long the Artemis 1 stack was outside for in its time here on Earth, from first rolling out of the VAB in March of 2022. Oh my gosh, a long time ago, and launching in November. If you A/B compare the shade of orange on the core stage, it's a lot darker in November. So it's naturally a tan beige color. unpainted. And then obviously the longer it sits in the sun, the more it tans, as we like to say. It was only painted for the first 2 space shuttle missions, and it was painted white to aid in its thermal protection, but it was deemed unnecessary and to save a bit of weight. I think it was like 300 or 400 pounds. I think overall with the stack, it remained unpainted for the remainder of the shuttle program. So. Essentially, it is orange in its natural state, although, again, the longer it sits outside in the sun, the darker it gets.
It's getting a suntan. Why not? When you're in Florida, I feel like that's the thing to do. I just
Very
wanted
appropriate,
to,
yeah.
yeah, very appropriate. We've had so much support coming in on the chat, and we really appreciate it. It really does make a huge difference to us, and we know that it's able to help support the crew that are out there on the ground as well. I just want to go through the tips and say a big thank you to them. Patrick Bob, who gave us a $500 tip, is saying he's continuing support for the awesome pre-launch coverage and all the rest of the different live coverage. Patrick, thank you so much. What a massive amount of support you've just given us, and we really do appreciate having that kind of level of support from you. Alan Ivan has come in with a $20 or a £20 tip even that says, go Artemis 2, go. Alan, we really appreciate you and all your support. It's always great to see that coming in for all the team that's out there and for the team that's able to support remotely as well. Doug, who's got a tip for us for $10, who's asked, my son Will 6 is curious about what all the water that comes out of the launch is for. I'm going to throw that question over to Ryan. We do see a little bit of water coming out when we're doing the deluge, right?
Yes, so that is called the water deluge system. That is used to suppress the immense noise that comes from the base of the rocket here, because we have 4 RS-25 main engines on the orange core stage, 2 solid rocket boosters. Those are producing millions of pounds of thrust, millions of whatever unit you want to use of thrust. And if they didn't suppress all of the energy coming from those rocket engines, it could, well, it did, even with the suppression, almost destroy ML1 on Artemis 1, or destroy the mobile launcher. So that's basically used to protect core components of the mobile launcher, essentially to stop the launch pad shaking itself to bits, which is what that is used for. And they use, you'd imagine, to contain the forces of, or kind of distribute the forces from this immense rocket. They use a serious amount of water to do that. And you can see that huge water tower over to the right-hand side, next to SLS. Yeah, that's a lot of water they need to dissipate all of that energy.
Absolutely. And those tips keep coming in. A big thank you to Jason for his $20 tip. He says, thank you for taking the time to do what you do. We're here for you guys. You know, we are just a bunch of space nerds that want to make sure you guys are as up to date as possible with all the information going on and get a channel that are able to talk about the things that maybe other channels are not able to talk about. Joa has come in with a $100 tip. Go Artemis 2. I love how the hard science of space is not superstitious, but it's definitely a little stitious. I think it means like today is obviously April Fool's. We haven't really talked about it. You know, obviously the launch trajectory of what this mission is about wasn't going to pause just because today is April the 1st. But they seem to be going ahead with this on this day anyway. It's not a joke. We are really going to be getting to see a launch today to the moon for the first time since 1972 with humans on board, which is a very, very exciting thing. So a big thank you to Joa for your support. And those tips keep coming in. Wyoming Coast has come in with a $25 tip. It says, Wyoming Mission Control is go for launch Artemis 2. Currently low tide and light breeze. Godspeed, Artemis 2. And their crew, which is also very important. Max, you are on the ground. We've been hearing weather reports that have been a little bit concerning for a lot of people in the chat. What are we seeing right now?
So just judging off of what my Mark 1 eyeballs are seeing currently, so if I look off to my left, I'm actually seeing a lot of blue sky. But in typical Florida fashion, if I look off to my right, there is some pretty thick, dense rain clouds off to my right. But although, considering the wind direction right now, that looks to be moving inland and away from our current position. I'm trying to look around as best as I can, like right now, trying to gauge what the cloud cover is going to do. And it actually looks like it's going to start clearing up here a little bit. I know there were spots of rain in the area that were coming through off of the Atlantic Ocean for a bit. That might be the case over in Titusville still, with them being about 10 miles or so inland compared to our location here at the press site. And it's also a little bit windy. But of course, nothing that would be of major concern right now, as everything is still within range for the launch weather assets. So I would say things are currently looking. I would say things are still looking good. I would not be worried about. Yeah, I would not. I wouldn't worry about weather too much yet. I would worry about weather if it was looking like this around, like, I don't know, the 20-minute mark, and the clouds were coming this way. Although the way things are currently looking right now, again, taking one more look, it looks promising so far. I think it's fair to say.
Yeah, the sky's definitely looking pretty clear there. Might have just lost Alice there for a second, but yeah, as we approach 2 hours and 10 minutes in the countdown, wind is looking pretty breezy, but also not incredibly breezy. We can see the flags waving there on the left-hand side. So yeah, weather is continuing to look okay. Max, I don't know if you know how you're feeling the wind right now at the press site.
It's not awful, I do have to say. It's tolerable. If anything, it's pleasant, given the amount of sunshine that we've also gotten today, in addition to the clouds. Sorry if you hear a helicopter. We're about to be buzzed by one of the NASA Airbuses. So actually, right over our heads here, you can probably hear it in the microphone. Pause here for a bit while it goes past. Just a casual day at the Kennedy Space Center. Hey. Um, so no, it's not bad right now, Ryan. It's really not. If anything, again, it's refreshing. It keeps the temperature a little bit down, both on our skin and just with the air in general. So nothing of major concern yet. It's not like those previous missions that we had for Starlink, where it was howling a gale and the camera was shaking like absolute crazy. None of that concern right now so far. If anything, it's picturesque the way it is blowing the flag currently around. So it's not awful right now.
For your awareness, scrubber cycling is about to be restarted.
Integrity copies.
I don't want to talk over those comms. We'll see if what NASA is going to say there. Looks like nothing. It's always wonderful when they butt in and then don't follow up with anything. So as we continue to count down, there is of course a lot of stuff going on. We are expecting the launch abort system hatch to be closed over the next 28 minutes or so.
Go ahead.
Moon leak check complete. The cabin is going to be vented to flight pressure momentarily.
Integrity copies.
So there we go. It looks like NASA is saying that the crew cabin is being vented to flight pressure, which must mean it's sealed, because you can't do that if it wasn't sealed. And that is a brilliant step in the process of getting Orion ready for flight. We'll see if we get any more communications from NASA Mission Control on that one. But again, this is a really, really positive step. Max, this we had you right at the top of the stakeout stream a few hours ago, but since that point, we've been through the entire tanking procedure. We've seen them load liquid oxygen, liquid hydrogen on both stages. We've seen the crew go out to the pad. We've seen the crew get on the rocket. I mean, what's your take on this so far? Because Wet Dress 1 wasn't great. I think everybody will say that. Wet Dress 2, things went incredibly smoothly. This time around, it seems, at least in my opinion, to be like Wet Dress 2.
I'm almost hesitant to speak on it. I'll be completely honest with you, Ryan. It's amazing how fast the time has just eroded away here. It seems like the last time I checked the clock, we were at T-minus 10 hours or so, whenever it was I signed off from the tanking stream earlier. And now, of course, we're coming up on the T-minus 2 hour mark, which is when it's one of the milestones where things get or begin to feel real, I guess, to sound cliche there, if I may. It's the T-minus 2 hour marks, the 1 hour mark, and the half hour mark, and then every 10 minutes after that are when it gets when your heart rate raises considerably at each milestone, and we're coming up on one of those right now. Oh my word! Yeah, I'm almost hesitant to speak on how things are going.
Well, Megan, we were a little while ago talking to some students from around the globe.
Heard some comms there for a bit. Sorry, folks. Yeah, I almost don't want to speak on it for risk of jinxing it. So, because as we very well know, commentator's curse is very, very real, especially with Adrian from our loving colleague Adrian, who is unfortunately not on comms today, but we do miss him. Yeah, things are progressing well, but again, I don't want to jinx it, Ryan. I don't know about you, but I think being here just brings not bad juju, but certainly a lot more risk in what you say, maybe.
Hey team, can you hear me now? It's the joys of live television. I sometimes slip in and out, it seems to be. I don't know if you guys managed to talk about the super chat that was on there. We had a $500 tip from Patrick, who said,
Oh my
for the
gosh.
awesome NSF SLS coverage so far and the stakeout. Because, of course, we started this coverage from 7:24 a.m. local time this morning. So Ryan's been at this for many, many hours now. We thank you, Patrick, for your support. It really does make a huge difference to the team here. And that also gives me a chance to say a big thank you to Crafty Geek, that's also come in with a $500 tip. This goes out to all the photographers in the field, those manning cameras remotely, Kevin, Michael, Reed, and the rest of the production team, excited for the amazing potential of a daylight launch. Thank you, thank you, thank you is all I can say, Crafty Geek. It's always great to have that kind of support coming in on the chat. If you'd like to jump on and support us, we thoroughly appreciate it, and we'll make sure we reach out to you as well. Oh, and Crafty Geek added another $25 after the fact, because why not? It's always nice to have that. Thank you so much for your support. We are currently at coming up to 2 hours. Oh my goodness, getting very close now. Is it feeling real? I've got to ask you, Max, what does it feel like being there? Because you're right on the ground in the middle of the media centre. You're slightly remote from all the crowds that are going on, but you must have a real buzzing feeling of what the atmosphere is like on the ground there at Kennedy Space Center.
You know, that's actually a really good point that you brought up there, Alice. There is a bit of a disconnection of what we're feeling here on site versus what the public is setting up for outside the Space Center. And just speaking from here, the crowds are incredible now. There are cars lined up everywhere from as far as I can see. Tents lined up all the way down the lawn. Stages are up. People are starting to gather all the way on the press site lawn now, getting their tripods and stuff set up. Maybe get some more on-camera footage or on-camera takes. And speaking of their cameras before we cross this next milestone here, it's electric. It really is, and it's not something that we take lightly at all. I think, like I was saying earlier, there's no launch day quite like an Artemis launch day. And speaking from experience from Artemis 1, I'm almost rendered speechless by it, honestly. I'm struggling to figure out what to say to do justice what it feels like here right now. There are a number of very well-known personalities talking to millions of people. We are able to be here with a whole bunch of cameras, a whole bunch of microphones, and our entire field team here as well, and having some people in town watching on site. Love you, Gage and Julia. Yeah, I'm almost stuck in between trying to savor the experience and enjoy what this is, because this doesn't happen often at all. In best case scenario going forward, this happens once every 10 months, right? But the last time we had this was 3.5 years ago with Artemis 1 launching in November of 2022. It is now April of 2026. So it's been a while.
It has been a while
time since we've felt this. So forgive me if I'm rambling. I'm trying to do it justice. What it feels like being here, because there's also the intense history from all the previous missions that have flown from here, including the likes of every Apollo mission, every mission from Space Shuttle, Skylab. Everyone who was covering that as press was here at the press site, like exactly where we are now. So you feel that all on your shoulders, and for a mission of this magnitude and importance that's you certainly feel that, and that's something that I don't know if words can properly describe well enough, let alone over camera or in person. So, um, just happy to be here, really.
You did a very good job, Max. It does render you a little bit speechless about what a huge historic day this is for all of humanity, which does remind me, a big shout out to Patrick O'Mara, who's come in with $100 Canadian super chat, who says, shout out from Toronto, Canada, because of course, this is the first mission where we're going to see someone who's not an American go outside of low Earth orbit. I understand that there's somewhere in the region of 70 different nationalities represented just at the media site alone today, Max. Have you spoken to anybody from outside of the US and Canada while you've been there?
So I've actually talked to a couple of journalists in from Poland. They had a very long trip to get here. I've had a quick chat with some people who have been here from the UAE, but unfortunately, I haven't had much of a chance to talk to much else or anybody else really, apart from our SME interviews from the other day. It's unfortunate to say that, but there are you can just tell by looking around. There are people from far and wide, not just from across the states, but from across the world to cover this, and that is just the level of importance this mission is carrying. So, yeah, there are a number of nationalities. Hey, helicopter, nice. Yeah, there are a number of nationalities being repped here, and it is incredibly refreshing to see just that people still care, and that missions and missions of this sort and spaceflight in general has not lost touch with the public at all, at least in terms of going to the moon. And hopefully this can respark some interest from the next generation of engineers, media personnel, a whole bunch of other people, and that's overall the goal of the Artemis program, and hopefully others going forward. So, yeah, it is just a wonderful place to be.
Absolutely. I think we had a bit of a glitch on screen showing some of our merchandise. I apologize for that. We'll see what we can do to make sure we correct that as quickly as possible. It seems to have been a little bit better in the last couple of minutes. Captain Skyhawk has come in with a $50 super chat and a bit of a fun question I'm going to throw out there to you, Ryan. How much bigger would the vehicle need to be if it was going to go around Mars instead of the moon? It's kind of a difficult one to answer given the length of the duration to a flight to Mars, but could you guesstimate how much bigger a vehicle would need to be?
It all depends what you're going to be sending. If you're going to be sending a fully crewed Orion crew module, then you're going to need a much bigger second stage with the Delta V, the change in velocity that can actually support doing such a burn to get all the way out to Mars. But you'll be surprised to know it's not actually that big of a vehicle, much bigger, that you would need for that, because there isn't really, at least going into the future as we look at Mars, there isn't really going to be a direct to Mars vehicle. There is going to be in-orbit propellant transfer to refuel vehicles. So the traditional way that we think about designing rockets, that we need to put all of the fuel on it at liftoff and then send it as far as we can into the solar system, that won't apply anymore, because we'll be in a new age of on-orbit prop transfer, cryogenic prop transfer, which means that you can send up one spacecraft, say Starship or Blue Origin's cislunar transporter, and you can refill that spacecraft with propellant, and then it has a full tank and it can literally go as far as it can, and you no longer have to worry about expending all of your fuel at liftoff, because you can just top it back up with a depot or a propellant tanker or something like that. So you don't actually need a vehicle that much bigger anymore to be able to do, or at least in the near future, to be able to do missions like that, which is, that's pretty exciting, and one of the things that will make those vehicles really, really interesting to keep an eye on, as we do.
Absolutely, and a great question. Thank you for that and your super chat as well. We've just had a tip come in from Martin Russ. Big thank you to your $100 tip. Thanks a lot for doing this. I'm new to this channel and I like it a lot. Regards from Switzerland. We really appreciate it when we get new members that come on board, when we get new viewers coming in and sending us hints and tips and questions. Thank you, thank you, thank you. We wouldn't be able to do this without you, and we do appreciate it all. As I've mentioned a few times, we are NSF, not the NASA. We're just a bunch of fun space nerds that want to be able to bring you the coverage the best we can to talk about what's happening, what we can expect, and what we can see coming up in the next few hours, because we are getting very, very close. We actually just went under the 2-hour mark almost. It's like I blink and miss it and then it goes past. We are down to 1 hour and 56 minutes ahead of launch now, and we're watching the closeout crew right here. There seems to be a lot of questions coming in about the closeout crew. Ryan, could you answer the question about numbers for me? One of our audience members has asked, why has the closeout crew got numbers on their uniform?
It's essentially for easy identification, if that makes sense, because they've all got hats on, they've all got masks on. They're, you know, when many of the features you would use to identify a person are obscured for the fact that they're protecting the crew, because this is a quarantine environment. As we were talking about earlier, the crew have been in quarantine for 14 days. This is actually their third quarantine period for this mission, considering the multiple delays in the different launch windows from February to March, now April 1st. So, you know, if you can't see those features, it just helps to speed up that recognition of who somebody is. I mean, obviously this crew has been working together for so long at this point, they could probably already tell without needing the numbers, but it's just, it reaffirms what you already think. And that's, in highly critical environments like this, that's incredibly important, because you don't want to be spending 5 to 10 seconds in your brain trying to figure out who you're talking to or who you need to talk to. If you have the number, you can tell in a split second who you need to talk to or who is talking to you. And I'm sure that's useful for the astronauts as well, especially when they've got the helmets on, because that restricts their visibility a little bit. So it makes identification of each crew that crew member easier. And I suppose it also makes it easier for the folks back in launch control who will be looking at these very engineering cameras that we are looking at right now. I'm sure somebody in launch control is looking at this very live feed as we speak, as we watch it. So that's very useful. If you can't actually see the front of somebody's face, I know that Andre Douglas is standing in front of the camera right now because he's number 2.
Absolutely. We are currently at the moment looking at the crew module hatch service panel install closeouts, which we were expecting to be around L-140 to be concluded then. And then around that sort of time, we're going to be seeing the launch abort system hatch closure for flight. So we're looking at the moment at that closeout crew. They're doing all the extra checks and balances that they need to do ahead of those hatch closures that we're expecting in the coming 10 to 20 minutes, maybe a little bit longer. We do seem to be doing really well when it comes to the timeline right now, Max. Is the consensus on the ground that the things are going to go ahead and that the 6:24 p.m. launch window opening is a good chance that we could hit it on time?
Well, you know, it's funny you say that, Alice. I'm reading the back channel now, and thanks, Alicia. Apparently, Daryl on the NASA stream is briefing about a range issue and also related to the FTS, or the flight termination system. I haven't had comms of that. I haven't read anything about the sort yet, so I'm not entirely informed of what exactly is the nature of the problem there. But as far as timeline goes, they are still ahead of schedule, and they should be getting ready to close the launch abort system hatch, or that white cover there that goes over the Orion spacecraft, in about 13 or so minutes time. At least that is what the timeline says. So apparently Daryl said it's a pretty unique situation per Daryl. So I wonder, is it a boat, Ryan? Is it a boat? I hope it's not a boat.
I have no idea, but yeah, I'm not sure whether that pretty unique situation is relating to the range or to the flight termination system. Don't worry about anything. I'm sure we'll probably move on for a few minutes here, and then once we actually know what's going on, we can come back in and give you guys a proper, concise update. And so yeah, I think keep spirits up. Let's move on, and we can come back to that in a few minutes when we actually have the information.
Absolutely. We're working to get that update for you. We've had a couple of questions that have come in on the chat. Lorenzo's asking, could we get an explanation of how and why the Orion and lander work together in a mission? I'm going to throw that to you, Ryan, if possible.
That is a really good question. So the answer to this question changes almost based on the lander that is going to be used, and it also has recently changed because the Lunar Gateway space station is no more, as we have been talking about over the last week and a half or so. So essentially, the current plan for Artemis 4, and I have to stress current plan, because as we have seen over the last 10 days, this can change, you know, at a whim of whatever the administrator is going to do, and to try and expedite this process of returning us to the moon. But right now, the current plan with Artemis 4 is for Starship to dock with Orion in lunar orbit. So SLS will launch Orion to lunar orbit. Starship will launch the Starship Human Landing System to lunar orbit completely separately. They will then rendezvous and dock in lunar orbit. 2 crew members of Orion's 4 crew members will then transfer into the Starship Human Landing System lander, and they will then undock from Orion, descend to the lunar surface, stay on the surface for a little while, do some moonwalks, then reboard the ship spacecraft, fly back up into lunar orbit, rendezvous, dock, get back on board Orion, undock, and then Orion will head back to Earth. Now, I say current plan because right now NASA is essentially saying whichever lander is done first will be the lander that they use. So there is a possibility it could also be Blue Origin's Blue Moon Mark II lunar lander. Now, it's going to be a similar process without Gateway for that, but I'm not sure if there's been any specifics actually released on that process. But we have seen a video from Blue Origin of them testing the docking system. So we know they have a docking system in test to do that process. But in terms of Blue Moon, that's of course a Blue Origin vehicle, so that will be launched on New Glenn, which is their heavy lift rocket launching out of Complex 36 at the Cape. That will do a similar process. That will launch into Earth orbit, get refueled, of course, as with Starship. I forgot to mention that, but that would get refueled, and then it would essentially get kind of chugged along to the lunar environment, where it would then rendezvous with Orion and then do the mission profile, which I just outlined before. Beyond that, it gets very difficult because beyond Artemis 2, we don't exactly know what's happening right now. There's a new mission which has been inserted between this mission and the moon landing, but again, things can change as the administration works through their kind of expedited process, shall we say.
Absolutely. A big thank you to all the support that keeps coming in on the chat. Christian has given us a €30 super chat, who's just said, go SLS go. We're all keeping ourselves positive here right now, keeping the thoughts positive, along with Simon Austin, who's come in with a £10 super chat. He says, all positive thoughts, but how do we feel about the re-entry heat shield? Now, that's a really good question, given that what we experienced with Artemis 1. Max, do you want to take that one for us?
I mean, speaking of positive thoughts, I mean, NASA literally changed the reentry profile for Orion to accommodate for the heat shield issues that they came across during Artemis 1. So in Artemis 1, they had sort of a skip maneuver where it came in essentially twice into the atmosphere, whereas this time they're coming in a much steeper, more direct approach only once. So even though it is going to be experiencing higher temperatures, the amount of time that the heat shield is going to be experiencing said temperatures is shorter overall. So I don't think they would do that if they weren't confident that this change in flight profile was going to work. I mean, obviously what we saw with Artemis 1's heat shield was kind of alarming, but any spacecraft being or undergoing super high temperatures like you would get during atmospheric reentry for a prolonged period of time is not good. Even your best of heat shields would struggle for a long period of time, especially when you are traveling at the velocities needed to go and come back from the moon. Once, of course, Earth's gravity has you in its hands. So yeah, I mean they've changed up everything, and again, I don't think that they would do that unless they were confident that it was going to work. So, yep, I think we have Alex
Max.
from Alex.
Yeah, I was going to say,
Yep.
I'm jumping in
that,
because I think we're getting a bit of an update coming in. Alex, what are you able to share with us?
Yeah, it's a rather important update because they were talking about an issue on the range. So currently, the vehicle is that comms that we're getting?
Go ahead.
Of course.
All right, ready for another reading on the CBA pressure gauge if you're ready to go.
Yes, sir. It is 2,600 PSI.
Copy, 2,600. Very good.
Okay, there we go. Right as I give the update. So right now, the range is no-go for flight, and so everything else looks good. So they're still counting down, but the problem that the range has right now is the flight termination system of SLS. And so there are these different sets of charges, right, across the vehicle to be able to, in case of an emergency where it veers off course, the crew aboards, of course, they have the launch abort system, right? But the rocket itself has a flight termination system to be able to terminate the flight in case it veers off course. Now, that flight termination system is activated by a person on the ground, and so they need to be able to verify that there are signals that are sent to that flight termination system on the rocket. And right now, it seems like that is one of the issues that may be working on, that perhaps it is not actually working, right? That signal sent testing they've been working on, as some of the data that we were getting, or rather commentary that we were getting from NASA, is that they literally took shuttle equipment, flight termination system equipment from shuttle in the VAB, and they took that in order to be able to verify that such hardware was actually working from the range standpoint, right? The range needs to send that signal. Other rockets you may have seen, for example, Falcon 9 or Starship or even Electron from Rocket Lab. Those use automated flight termination systems. Now, we'll forget, of course, Firefly also now uses that as well on Alpha. And that means essentially the rocket itself blows itself up, basically, right? Whereas on these rockets, these more older rockets, I guess, those ones, they basically have a person on the ground doing that work. And unfortunately, it seems like they're working through that issue right now. They're trying to figure out how to solve it. As I said, they're still counting down, because you never know when that might resolve, right? When that issue might disappear and it will no longer be an issue, basically. And so you still have to count down and get ready for a potential flight whenever that issue clears. And we still have 1 hour and 44 minutes into the count. There's still another 2 hours in the window as well. So there's plenty of time, as I said, to be able to work through this issue. But currently, the range is no go.
Yeah, I want to reiterate that. Don't panic. We still have time for things to turn around. It looks like the closeout crew are continuing with what they're trying to do. It is a range issue that is going to hopefully get resolved either before the 1 hour and 44 minutes countdown concludes, which will give us the 6:24 p.m. Launch window when it opens, or hopefully before the end of that launch window, which will be at 8:24 p.m. local time. So we are just going to continue on as it should be, and say a big thank you to all the support that's coming on in the chat. Ando NZ has come in with a 25 New Zealand dollars super chat support. We really appreciate your support coming in for the stream today. Your money goes towards paying for all of this crew that's able to support the live coverage that you're seeing right here, right now. So a big thank you to you for that. We've got another one coming in from Alex Daniels, a $10 super chat, who's asked, will there be a live public broadcast of the mission similar to the radio coverage Jim Lovell's wife followed in Apollo 13? What's the best way to track the mission while it's in flight? Ryan, why don't you tell us about the coverage plan we have for the next 10 days?
Yeah, so the best way to track the entire mission is to, first of all, stay tuned to this stream until it ends. But then after launch, we will be launching a dedicated 24/7, technically 24/10, because it will last for 10 days, live stream of the entire mission. So we will have a live track of the Orion spacecraft when or if NASA's Deep Space Network is able to downlink live feeds. We will be showing that on stream. And then roughly every hour, we'll be coming live with commentary to give you an update on what's happening with the mission, what the crew have been up to, and maybe if we have the opportunity, even share some photos which are downlinked, which will be really cool. And we'll be doing, in addition to that 24/10 live stream tracking Orion as it travels through deep space, we'll be doing daily commentary shows as well, dedicated commentary shows in addition to that live stream. So we'll be giving you daily live updates, 24/10 coverage of everything this mission does. And then, of course, when it comes to re-entry and splashdown, we will be live for that as well. So NSF is the place to be for continuous coverage from, years before launch, if you count Space Coast Live, all the way through to re-entry. So yeah, I definitely recommend pressing that subscribe button if you haven't already.
Don't change the channel is what we should say. A big thank you to Craig Campbell, who's come in with a £9.99 super chat, who's saying he's really enjoying this stream. Thank you to the team. We thank you for watching and staying with us. Obviously, we wouldn't be able to do it without your support, so we really do appreciate it when it comes in. Glenn Bailey has come in with a $9.99 super chat, who said, "Let's go Artemis 2. I've been tracking the Artemis program since the rollout of Artemis 1. Haven't we all? Haven't we all been waiting for this day? It's been very, very exciting to see, and I feel like we're right there on the end. Even though currently the range is a no-go, we're still staying very positive because we're going to continue on, hope that they can rectify the issues before we have to deal with them. Philip has come in with a $5 tip saying, "Well done, guys. Hi from the UK." It's always nice to get support from people outside of the US. We forget sometimes that there is a lot of countries involved in this mission. I know Alex is normally the one beating the drum talking about how the Europeans are involved, but I know Max was saying earlier there's also 70 different countries represented in the media area. Max, what are you seeing over there in the media area right now?
Well, at the moment, I'm seeing a camera and a laptop, and Sawyer behind the camera, and many other tents and cameras off to my right and to my left. So I can't really say I see much beyond that currently. But from my time walking around earlier, it's tent and camera galore. The tent and cameras galore everywhere in stages. People are. It's becoming like a borderline ant colony right now with how many. Oh, that's in. So it's a borderline ant colony right now. Sorry, thank you.
I think someone's giving you the hint. Stay hydrated.
I know, all right. So yeah, it's becoming more and more like an ant colony the closer we get now to the opening of the window, which is now, oh crikey, just 1 hour and 40 minutes away. I don't know if I like that. It is, but also that the recently discovered issue with the FTS and the range is ever so presently on the mind now, and time is, I don't want to say time is running out to solve the issue, because they have a whole 2-hour window should they need it. I don't know, but I think at the moment people are still pretty buzzed and just hoping to see this thing off today, because I think as we get closer to the window opening, I think the weather is going to be more and more in our favor in terms of both cloud cover and weather conditions overall.
A lot of the crew is continuing on as if there isn't an issue with the range right now, as they should be. We are currently reaching that just gone past L minus 1 hour and 40 minutes. At this point, we are expecting the launch abort system hatch closure for the flight. So we are hopefully get an update on that in the next 10 minutes or so to see if they are going ahead with it. You can see that crew has been working diligently for quite some time now. It's been a while since the crew got over to the capsule and started to get into their seats and get ready, and the team has been working then to close the hatches, and there's multiple of them that we have to see closed to make sure that they are safe and ready to go. Ryan, I know you've done a great job of explaining it so far to all of us. Remind us again, what is it they're working on right now, and why has it taken so long to simply close a door?
Well, the easiest way to explain that is that it's not a door, it's a hatch, and there's a lot of things that need to be closed up. This is when you think about a pressurized vessel, you would want absolutely you would want the smoothest, most pressurizable shape possible, most containable shape possible to keep all of that pressure when you want a livable atmosphere in the vacuum of space. And then suddenly the engineers come along and say, hey, we want to put people inside. We need to cut a gaping hole in the side of this pressure vessel. Can we do that? And of course you have to, because the crew need to be able to get in and out. But then you suddenly have a huge hole in the side of your pressure vessel, which you need to be able to seal up for a 10-day period to keep the crew inside pressurized, which is what they have been spending the last, over an hour at this point doing. If they haven't done so already, I think they might have done, but if they haven't done so already, shortly they will be closing up the Orion crew module hatch. And this is the actual pressurized crew module that needs to be protected by that hatch. I heard them on the loops a little while ago now saying that they were pressurizing the crew module. So to pressurize the crew module, you need to have the hatch closed off and sealed. So that might have already been closed off a little while ago, but it's difficult to see from this camera angle. What we can see from this camera angle, however, is the launch abort system hatch. This is a second hatch on top of the Orion hatch. And this is actually launch abort system shroud. So if you have watched our live coverage of Crew Dragon launches before, you will know that spacecraft only has one hatch. And that's because the Crew Dragon has an integrated launch abort system. It has Super Draco thrusters built into the capsule itself, which, God forbid, ever needed, they will then ignite and pull the crew away to safety. For the likes of Orion, and as we saw with the Apollo capsule and the Mercury capsule as well, they use like a puller launch abort system. This is essentially, in layman's terms, is a pointy hat with solid rocket boosters on it, which is then attached to the top of the Orion spacecraft. Should anything go wrong, those SRBs will ignite and pull the crew capsule away to safety. But of course, this shrouds the crew capsule when it's on the ground. So again, the engineers, they said, we want to put humans on board. Can we cut a gaping hole in the side of your launch abort system? Which is what they've had to do here. And that hatch is the hatch for that launch abort system, which still needs to be closed up. But of course, they can only do that when they've already finished sorting out Orion, which is encased inside. So that's what we're waiting for. The schedule says that should be wrapped up at L-1 hour and 40 minutes. We are at L-1 hour and 35 minutes, but as I've been saying many times throughout today's stream, just because something doesn't happen right on time doesn't mean we're going to be seeing a delay today. There's a reason this countdown is 40 hours long. It's to give NASA plenty of margin to get these things sorted.
Absolutely. Lots of information coming in about what's happening right now, and it's all looking very positive. We are staying as positive as we possibly can. DJ Cone 799 has come in with a $49.99 super chat that says, Godspeed to the SLS crew. Also, the view of the techs in the tower reminds me of the test scene from the movie Contact. We do love a good sci-fi movie.
Yes. One of the best sci-fi movies ever, Contact is. Yeah, wonderful.
Yeah, one of my favorites personally, because I live in New Mexico and it's always very exciting to see the VLA.
My gosh. Yeah, that's a perfect connection, Alice. Seriously. That's awesome. I didn't know that, actually.
Yeah, so I'm actually just down the road from the NASA White Sands test facility that's obviously involved in a lot of the static testings of all of the missions for NASA since the Apollo era. I know a lot of our teams from this region have flown out to be part of the launch today, and I'm very excited to see little New Mexico represented as part of this mission today, which is always very, very exciting. So thank you again to DJ for your super chat support. We always really appreciate it when it comes in from the team. Keep your questions coming to everybody that's on here. If you don't know how to ask a question, a little reminder, all you have to do is go to the chat and tag us at NSF or at NASA Spaceflight, and I will do my best to get through those questions for you as quickly as possible while we have the opportunity to talk about it. We've got people coming into the chat here that are saying things like Stuart, who's just come in with a $14 super chat. He says, greetings from Ottawa, Canada. Old enough to remember watching Apollo 17. Now, of course, this is the first human mission to the moon since Apollo 17, which was in 1972. Another little New Mexico quirk for that one. It had Harrison Schmitt on board, who was from southern New Mexico. He's a local boy from Deming. I know my accent's always very confusing, but I've lived in New Mexico now for nearly 13 years. I'm very proud of my little home state and how much we've been involved in space. So thank you for talking about that and giving me an opportunity to give a little shout out to my local area, which is always very exciting. We are still waiting for an update on what's going on with the range right now. As you can see on the ticker, it says range currently no go due to an FTS issue. Ryan, could you update us on what that means?
Yeah, so there isn't really an update on the actual cause or the actual problem itself. It's a little bit vague, but the acronym's there. No go, we aren't going to be launching if this continues at the time of launch. However, there's 1.5 hours plus the 2-hour launch window to get this problem sorted, as it looks like the closeout crew are getting ready to close up that hatch shortly. And the FTS is the flight termination system. So even though this has a crew on board, there are still explosive charges installed on the core stage and on the solid rocket boosters. In the event that something were to go wrong with the vehicle, the launch abort system will pull the crew away to safety, and then they will trigger the flight termination system to terminate that rocket, blow it up essentially, to make sure that it doesn't fly into an area which is off limits. If it suddenly starts doing cartwheels and it flies towards Titusville, that's obviously not a great thing because you have 400,000 members of the public watching on, so you want to be able to terminate your rocket. Of course, we hope that doesn't happen today, but it is a mandated safety feature that has been on every rocket forever, so that's really important.
Yes, very important. Safety first. That's a really important part of all of this. We are getting a few little things coming in on the chat about that update, and we will continue to update you when we know what's going on. It's a lot of stay tuned right now. As you can see, the closeout crew are still continuing to work on closing out the hatch. To go to the rundown of what we're expecting at the moment, we are at T-minus 1 hour and 31 minutes.
L
And just
minus.
under
T-minus and L
L-minus.
minus, very different things.
See, you're right. Absolutely. L minus till the launch window opens. You're correct. Thank you for holding me to that one. We are expecting around this time to see the launch abort system hatch closure for flight. And we're hoping that's what their team are working on right now that you can see on screen. We've got a couple of different angles for you to see what they're doing. What is it you can see that they're removing right now? Ryan?
Looks like some paneling of sort, maybe. It's a little bit difficult to see, but the Orion hatch definitely seems closed. But it looks like maybe some paneling they use for accessing the hatch might be getting removed at this point. Of course, they don't want to. They don't want the astronauts to catch their very expensive and very important spacesuits on anything, and accidentally tear it or anything of the like. So it's probably my guess would be maybe protective covers or maybe something that's kind of used to seal the gap. Because remember, there's a gap between the crew access arm and the vehicle. The vehicle is constantly swaying. This vehicle is alive right now. It's fully fueled. It's gonna be making noises if you're at the pad. The closeout team will be able to hear that. So that could be in there. That could be some not a walkway, but you know what I mean, kind of to fill the gap. Potentially, I'm not 100% sure, but that could be what that's for.
I wonder if they've got a mind the gap sign as a Brit. You got to wonder if they.
Oh my gosh!
Yeah, when that crew arm retracts, there's going to be a pretty big gap.
Or a voiceover of someone saying "mind the gap" as they enter. That's what I would do. You've got to have some fun with this. These guys are working, but they are also going to have a lot of fun. They are making history today, and I feel like. I'm watching that. I'm getting that feeling from where I am. But Max, you're the one that's on the ground. Surely you must be getting the real buzz right now.
Certainly. I mean, more and more people are showing up and trying to get into their launch positions. I wonder how far spread the news is about the FTS issue, or people are just getting ready in the event that it is solved in time. That's beginning to take more and more of a focus on my attention at the moment right now, to be honest with you, just because I want to make sure that I have time to prep all of my other cameras in addition to all of those belonging to NSF, because obviously we want to create the best visuals possible for everybody. Yeah, I think I haven't walked around enough since the news has been a topic of conversation, so I can't really say whether or not the atmosphere around here is like worried. People are getting hesitant. Tough to say on that front right now, but it's nice that we still do have some clouds coming over the sun and giving us a bit of a break from the sun. It has been a very warm day despite the winds, and certainly my very pale skin has been paying for it. So
you've got the right gear for it, Max. Don't tell me you have.
No, but also with how windy it is, my hood is blown down all the time, and with how busy I've been, it hasn't really been on the mind so much to throw it back up right away. But anyway, I think once we make it another swap and bring Sawyer back on, I will I'll take another walk around and make a judgment as to how the atmosphere is now and to see who's talking about what. But I am really curious to see what this problem leads to, whether or not how much of the window we would need to eat into, if any. Still fingers crossed. I mean, we've pushed all the way to April. We've pushed all the way to April 1st with a beautiful daylight window, at least in the first hour or so, or here. And if it pushes past, like, I don't know, 8 p.m. or 7:45 p.m. or so, I'm going to be a little bit heartbroken just from a visual standpoint. But alas, that is not a priority. But I will certainly
photographer.
Yeah, I will certainly get back to you guys on that one.
Yeah, I've sent a few messages out to friends that are there, friends that are working on the ground as well, saying, any more details about this FTS issue? And we'll see if we can come back with anything. At the moment, it's a bit vague. The no-go doesn't necessarily mean that the mission stops right now. We still do have time. We are currently L minus 1 hour and 27 minutes. That means that we are an hour and 27 minutes before the launch window opens. Ryan, you corrected me earlier, the difference between the L minus and what we're normally used to seeing, the T minus. Do you want to explain to the audience what the difference is between them for today?
Absolutely. So L minus and T minus, although they might seem very similar, they might seem like the same thing, they're very different. Well, for some launch providers, they're the same thing. For some launch providers like NASA, they're not. And I can understand how that generates confusion. But in this scenario, they are two completely separate clocks. L minus, L stands for launch. That is counting down until the current predicted launch time, which for the time being, unless NASA says different, is the opening of the launch window, which is 1 hour, 26 minutes and 30 odd seconds away. The T minus clock, the T stands for terminal, and that is for the terminal count. And for NASA and, for example, United Launch Alliance flights, those countdowns include built-in holds. So NASA will purposefully pause the countdown clock to finish events, and then they will resume the countdown clock to continue working towards launch. And that's, again, something that's carried over from shuttle and something that's carried over from the earlier days of spaceflight. And it's something they're doing, again, with the Artemis program, with the system. So that's it's an interesting thing to keep an eye on. In terms of the actual built-in holes is what they're called that we've seen so far. One started at L minus 12 and a half hours. That was 2 hours and 45 minutes of built-in hold. The second started at L minus 5 hours and 10 minutes. That was a 40-minute built-in hold. And the final built-in hold will begin at L minus 40 minutes. This is a 30-minute hold, which will hold the count at T minus 10 minutes. And this T minus 10 minute threshold is essentially kind of the reset point. So this is the final 10 minutes of the countdown when all the things start happening. And this, especially if they have to hold for whatever reason beyond T minus 10 minutes, this is a really safe space that NASA can recycle the count back up to in order to make sure that both the vehicle, the spacecraft, and the ground systems are all happy. And it's a comfortable position to restart from. For example, they don't want to pause the countdown at T minus 40 seconds and then restart the countdown again from T minus 40 seconds, because there's some really critical things that can happen in that time period. So it's just, even though it's kind of difficult to wrap your head around at first, we're keeping things simple for you. The clock you see on your screen is the time until launch. If you don't want to worry about anything else, just look at that clock and you'll be sorted.
Absolutely. This is a very historic mission that we are witnessing. Not only are humans going back to the moon for the first time since 1972, as we were mentioning throughout the show, but the crew is also looking different. This is the first time we're going to see a woman as part of the crew that's going beyond low Earth orbit, and somebody of color. And that's a really exciting thing, Mark, for us all to be celebrating for humanity. Let's have a listen back to what the crew had to say about how historic this mission and what it means to them.
We do think about it a lot. We always say that, we are not doing this for the superlatives. We're doing this because it's a unique opportunity. We are going for all and by all. This is what NASA embodies. This is what the space program around the world embodies. And we are proud to be a part of that journey. I think what's neat to me about that question is each one of the four of us, we carry a whole lifetime of experiences and perspectives. And when you get us together and we're in a geology class looking at the moon, you really start to see those all come out. Like the way I was raised as a child is different than the way they were raised, the different influences on our lives, different mentors, different heroes, different interests. And all those differences start to come out in the way we view the science objectives of the mission, and they come out in the way we view the technical hardware. So honestly, for me, it's just an honor to get to watch the way everybody brings their unique perspectives.
I want to highlight, I guess, maybe one facet of this is the tension, I call it. I live in this, this dichotomy between happiness that a young woman can look at Christina and just physicalize her passion or her interest, or even if it's not something she wants to do, she can just be like girl power, and that's awesome. And that young brown boys and girls can look at me and go, hey, he looks like me and he's doing what? And that's great. I love that. But I also hope we are pushing the other direction, that one day we don't have to talk about these first, that one day this is just, and I listen to this, that this is the human history. It's about human history. It's the story of humanity, not Black history, not women's history, but that it becomes human history.
Everything I've heard from my crewmates really resonates. Thank you guys for those amazing words. Something to add is that although it is something to celebrate, a bunch of firsts. That's definitely not necessarily telling the whole story. And it's also not about celebrating any one individual. If there is something to celebrate, it's that are at a time when everyone who has a dream gets to work equally hard to achieve that dream. And we're at a time where we've recognized the importance of, if we are not going for all and by all, we aren't truly answering all of humanity's call to explore. That, to me, is what's worth celebrating.
There's so much here, and all of that really resonates deeply with me. Something maybe slightly different from my perspective is what you're seeing here is, yes, a Canadian is going to go into deep space. And that's an extraordinary thing because of the American space leadership that curated that. But I hope others outside of Canada feel part of this too, because this is just an acknowledgement of anybody who shows up and is able to contribute something meaningful to our future endeavors can be part of this mission. And so I hope the Commonwealth sees himself in this mission. I hope all the international partnerships see themselves flying on this mission, because they truly are. And it's just been an extraordinary journey for me. It's kind of broadened my perspectives as an astronaut too. I'm wearing a Canadian patch here that was designed by an Anishinaabe artist in Canada. And it just represents some of the beauty of Indigenous culture and their perspective on the moon and the 7 sacred laws, and just the richness of doing something together and how inviting that is. It's shocking to me, but pleasantly surprising how many people show up and are going on the mission with us. It's not just 3 Americans and a Canadian. It is people literally around the world, and it's a beautiful thing. And we're going to go do something very real, very challenging, and that's what will make it inspiring.
Absolutely great to hear from the crew as they are getting themselves ready to launch for the first human space flight to the moon since 1972. And Jeremy Hansen just made a really good point there, that it's not just about America and Canada on this mission. There are lots of others that are involved as well. A thank you to Gabriel 1985, who's come in on the super chat with 59.99 euros, coming in for that, saying a very good flight to the crew of the Artemis 2 rocket and NASA and the European service module. We do forget sometimes to remember that there are lots of countries that contributed to this mission. Ryan, I know as a European, you must be a little bit proud of that.
Yes, absolutely. And I believe that Sawyer will be talking to someone from the European Space Agency very shortly. But in the meantime, NASA has posted an update to their blog, providing us with information on what is actually happening with the range and with the flight termination system. Now, it appears to be one issue, if I'm understanding this correctly. There's not anything wrong with the range as you might think of it. There isn't a boat in the way, there isn't a plane in the way, there isn't somebody violating the range. The reason that the range is involved in this issue is because the Eastern Range, Space Launch Delta 45, the people from the United States Space Force who control the range and keep it safe, have communications issues with the flight termination system. They currently cannot communicate with the flight termination system on the Space Launch System. And unlike rockets like Falcon 9 and other commercial vehicles, SLS does not feature an automated flight termination system. In that case, a computer on board the rocket monitors its flight, and if it detects something out of bounds, it will terminate the flight, all contained inside a computer on board the rocket. The Space Launch System uses a manual flight termination system. This is quite literally somebody in mission control with a big red button. I don't know if it's a big red button, but let's imagine it's someone in mission control with a big red button. They're monitoring a map, and if SLS goes outside of the predefined hazard zones on that map, they press the big red button and blow up the rocket. Right now, that button cannot communicate with the flight termination system, if I'm reading this update correctly. Not all is bad though, because NASA has said in their blog update that engineers have devised a way to verify the system and are currently preparing to test this solution. So fingers crossed they can regain the communications between the Eastern Range and the flight termination system on the Space Launch System, because that's a pretty important system to make sure you can actually talk to and back from. And just for clarification, the FTS, it features independent power and independent communications, because of course if something goes wrong with the power or comms on the main launch vehicle, you need to be able to talk to the FTS even if the vehicle is offline. So that's an important distinction. Even though they can talk to the astronauts right now, that doesn't necessarily mean they can talk to the FTS.
You keep mentioning we do have time. We are looking at the clock right now. It is L minus 1 hour and 17 minutes. That's the countdown until the launch window opens, and that launch window is another 2 hours after that. So we are very optimistic. As you can see, the crew is there. It's in the capsule. Are we seeing the bottom of a pair of boots there in the top right-hand screen, Ryan?
We are looking at a camera which is positioned beneath the top row of astronauts and above the bottom row of astronauts. So if you think, there we go, big zoom in. Thank you very much, Kevin Michael Reid, producing the stream. So all 4 astronauts are currently lying on their back. As you can see, 2 astronauts, Reed Wiseman and Victor Glover, commander and pilot, are sitting above, from this perspective, on the right of Christina Cook and Jeremy Hansen, who are in the bottom 2 seats. Of course, right now, they're laying on their back. So technically, they're at the same altitude. But if you imagine with Orion tilted 90 degrees so that they would be sitting vertically, that's where the above and below comes from. Of course, by the time we get into space, there will be no up and down. And they'll stow away the chairs and they won't be needed. So, but just for some getting your bearings there, this is what we're currently looking down towards the ground right now. Hopefully that helps. But we can see, I believe this is the left-hand seat.
MS1, NTD, on Orion Earth 1.
We're getting some cross checks.
All right, we are ready for another reading if you are ready over there.
Yes, sir. CBA is steady at 2,600 PSI.
All right, copy that. And you know, the more times we ask you to do that, the closer we get to launch. So that's a good thing.
Copy.
Well, are they done? I was just going to briefly say, I believe that's the left-hand seat we are seeing in the top right of that left-hand view, if that makes sense. So if I'm correct, I believe those are the feet of Commander Reed Wiseman.
Who knows? But it's all looking very positive right now. As we mentioned before a couple of times, there was a publicly available countdown of what we were expecting at this point, as we are at that window of L minus 1 hour and 15 minutes. According to the rundown, we are expecting a launch director brief coming up at L minus 10 minutes. So that'll be talking about the rocket and thermal protection system scan results and the imagery console. So we will try our best to drop into that when we know a little bit more. I believe what we're looking at right now is still the launch abort system hatch closure for flight, which means they're a little bit behind schedule, but certainly not too much, which is a good sign. If you're tuning in right now, we are about an hour and 14 minutes away from the launch window.
The range, and the good news is the range is go. So we reported that they were working to verify their equipment regarding the FTS system, and they asked for a little of that verification work to be done by one of the FTS engineers here in the firing room. He went out to the VAB to get some legacy hardware to help out with it. But in the end, this is a fix that the range had come up with to get clearance, to clear the range rather, and to as well work the FTS system. And so now they are go. Again, the range is go. That is no longer a constraint. And so you combine that with the fact that the rocket and the ground systems here also working, no constraints. Clear board here is great news.
I think I'm ready to cry. We've just heard that the range is a go. This is exactly what we were hoping.
Yeah, I was just going to say, that was the voice of Daryl Nile. He's the public affairs officer embedded within launch control at the Kennedy Space Center. So essentially his job is to suck in all of the information being provided to him by the engineers and regurgitate that out into something the general public can understand. Maybe that is still a little bit rocket speak, but we can understand that. So the issue they have had has been resolved. The range, the people in charge of protecting the area around the Kennedy Space Center have verified they could talk to the FTS, which is great. And I absolutely love the line. They pulled out some legacy hardware from the vehicle assembly building. Legacy hardware, I mean, that's definitely something from the shuttle era there. I'm going to be very interested to tune into this post-launch press conference and see what on earth they had to do to resolve this problem, because that is That's I haven't heard that one before. That's a new one.
Well, they have got a lot of legacy hardware on this vehicle. Could you tell us a bit about how this kind of Frankenstein vehicle came together, Ryan?
Well, it all started back in the 1960s and the 1970s when the US government wanted to launch space shuttles out of Vandenberg into polar orbits to be able to deploy satellites into a polar orbit and then be able to land back again in Vandenberg quick enough that the Soviet Union couldn't detect that they just launched a satellite into polar orbit. And because of that, they needed to put delta wings on the space shuttle, which made it quite big and bulky. And because it was that big and bulky, they needed to make a launch vehicle with solid rocket boosters to launch it into that orbit. The space shuttle ended up never actually launching out of Vandenberg, following the unfortunate Challenger disaster, but NASA was stuck with that vehicle design ever since. And I'm going to very quickly wrap up here because the launch abort system hatch is being closed and I can continue afterwards. And doesn't look completely, there we go, it's continuing to close. Oh, looks like it's opening again. I really wish we had that other camera because they might have to give it a good shunt. But this is, it doesn't look completely closed yet, but this is great progress. Launch abort system hatch is closing.
That's the next big milestone we've been waiting for, and we will, of course, keep you updated as we know any more details about that. The closeout crew, as you can see there, all numbered in their white jumpsuits, are working to make sure that everything is going to plan at this stage. I had a question come in on the chat about how far behind they are.
Hey, Megan, I don't know if you heard that.
It doesn't seem to be that they're that far behind, is what I'm going to say. We've got time in the schedule to sort things out, so we're not worried. In fact, if anything, we are positively glowing how exciting it is that we've got things going the way it's supposed to. And I believe at this point we've got Das come back on. Hi, John. It's good to see you.
Did they close the hatch?
We don't know. It's really difficult to tell at this point. If I'm honest,
we can't see.
It's like just off frame. Oh no, they're pushing.
No, they're pushing.
They're pushing. We need another camera angle because we promised that we would make sure that everybody in the public knew how to go. I'm going to be on camera apparently. Show the hatch closing. Don't show me. Everybody was going to know how they could pick up the patches over here, which have been selling to members. Some quick updates like crazy, and the pins are now half gone. If you're a pin collector for like commander of mission pins, the little lapel pin sort of stuff, those are half gone already. But as of right now, you can click on the link. We'll spam the link into chat, and everybody watching the stream can grab a patch. Like that. Did I point the right way? I did. Good. Can grab a patch. We have limited quantities of those, and the pins are going quickly. In addition, we have those pin display tails. Yeah, there's other merch. That's cool. You get a onesie for your baby or whatever. Do we? I don't know if we actually have this, but in the shop we have our pin displays. They look like a Starship heat tile, and they are Starship related, but we have limited numbers of those. Those are 80% gone right now. And so if you're interested in getting all of the Starship pins, you can get the collector's pin bundle thing with the display tile. Everybody can get those now. And you can add your Artemis pin to it. And we're going to keep doing new pins. We're going to have Starship Flight 12 pins. That's why I can't show you this shirt I have over here, because it has the Starship Flight 12 patch on it. I was going to hold it up and be like, sun shirts, they're great. But anyways, folks, now everybody watching the stream can grab the patches. They can grab the pins. If you want one of the displays, you could do that too. There's even pin bundles. Maybe you don't need the display, but you want to buy all of this. It's like 14 pins from the Starship program all in one thing. You can do that. They're all available across the board. And as soon as I'm off camera here, I will make sure that the links get into chat so y'all can check it out. It's another good way to help us continue doing what we're doing here. But yes, see, closed. Official camera angle showing that it's closed, right? Can everybody confer?
This is wonderful. We have the hatch closure of the launch abort system. This is incredible.
Closed. Do they have to like wrench it down or anything? It's like physically, whatever. It's physically closed. We're not going to worry too much about that. Technically closed, if not secured. So here, continuing on, we are now rapidly approaching that T-1 hour. Alice is going to step away. Massive thanks to Alice for holding it down there. I'm going to hop back in and continue to chat with y'all and the rest of the crew. But yes, I can stay. Thank you for asking, Ryan.
I don't want to be left alone. We're an hour and 7 minutes until launch. You can't leave me unsupervised, Das. That's dangerous.
It's all you. It's all you. The show's all yours. Go ahead, Ryan.
Well, as we can see, the launch abort system hatch is closed.
That's what we were waiting on. We're doing the relay race here because we're going to be live for multiple hours after launch. I got some good news when I hopped back over here and was preparing to jump back in. I heard that range issue was cleared. Apparently, somebody booted up the old Commodore 64 that they used to check the shuttle hardware back in the day, and the glow tubes, not glow tubes, the glow plugs. The vacuum tubes were all working correctly, and the vacuum tubes lit up in the proper order and said that the FTS system was communicating with the moon rocket here. What a time to be alive.
Oh, camera's on the move. Oh, they just cut away. I want to see what they're pointing the camera at.
Did that was like the camera, and then you saw him having the camera in his hand, like going to, I bet you they're going around the seal. Like
yeah,
around
I think
the
he's
edge.
inspecting the seal. I want to see the seal.
Show us that.
That's a sentence. I want to see the seal inspection.
You can tell that we're not officially with NASA here because we're like, show us the live camera inspecting the seal, please. So Ryan, did I miss anything else? I was keeping up with current events, but I was mostly concerned about that hatch being closed.
Yeah, I mean, we have been monitoring all of that stuff over the past couple of hours or so. I'm going to be honest, this part of the countdown is kind of the most spread out because we have an event at 3 hours and 10 minutes, 2 hours and 20 minutes, and then 1 hour and 40 minutes. After this point, the events are either every 10 minutes, every minute, sometimes every second as we get towards T0. But here on NSF, we've been watching, we've been hanging out with you guys, we've been keeping an eye on everything, and we've been progressing towards this hatch closure. I'm going to be honest, this is a big sigh of relief because we heard that blip from the range. That's the only blip we've had so far. Well, I should say the only blip NASA's had so far. We've had a few blips, but moving on. And apart from the weather, that's the only other thing. They're keeping an eye on the weather and that range item. Everything else, can you believe it? We are at 1 hour and 5 minutes to go. They've had one technical blip. They've resolved it, and they're keeping an eye on the weather. I mean, this is going so smooth. I don't want to jinx it, but it's going so smooth. I'm honestly shockingly impressed.
Knock on wood. I don't know. Everybody watching chat right now, like find something to knock on. I usually try to knock on my head. I heard that. That was good.
That was me.
Nice. Well done, Ryan. Knock on wood, but it does seem like a super smooth count so far. That one hiccup with the range. Y'all said legacy. Can I say antiquated? I mean, is it flight proven?
I didn't say legacy. Daryl said legacy.
Legacy. Okay. We'll go with flight proven range hardware. But it was good to hear that got cleared up. And as the clock continues to tick down here, just about 4 minutes away from that T-1 hour mark. Remember, that's the beginning of the window. And they do have sorry, L minus. Yes, thank you. Correct. They do have that 2 hour window to work with now. I believe we're going to hop over to Sawyer, who's made another friend in the field. Let's see if Sawyer's coming back. We got you, Sawyer?
Yes, I hear you, Das. And of course, I am joined here by Philippe. Philippe, do you mind explaining your role with the European Space Agency and the ESM?
Yes, my name is Philippe. Hello, Sawyer. I'm the coordination manager for the European Service Module. So I'm in charge of the exchange of hardware and documentation between NASA and European Space Agency for the ESM, as well as I'm a member of the mission management team, which is the team of John Honeycutt, who is leading the mission.
So for people that don't know, I think people are surprised sometimes that Europe is going to the moon with this and the ESM in general. Can you talk about its significance during flight and in particular Artemis 2 and getting it out there?
So the European Space Module is a powerhouse of Orion. We provide the main propulsion during all the orbital phase till re-entry. We provide the life support consumables, water, nitrogen, oxygen. We provide the power. We have these very characteristic X-wing solar array wings, and we provide thermal control through the mission as well. So for this specific mission, the main role of the European Space Module, also in propulsion-wise, will be to deliver the translunar injection, the TLI, which will happen about 25 hours after launch. And we will deliver this maneuver, which will last, it's a boost for the main engine of the European Service Module for about 5 minutes.
That's amazing. And also, this is the first time that Orion is actually flying with that ECLIS, the life support system, on board. How have you been testing and preparing it, especially after what you've learned from Artemis 1?
On Artemis 1, we flew part of the environmental control life support. We flew some of the tanks, not the full set of tanks, but we flew gas tanks and water tanks. But of course, they were not connected to the life support of the crew module. Here, the system is complete. All the tanks, all the 4 oxygen and nitrogen tanks and the 4 water tanks are installed.
It's nice to finally see all of that flying it out there. And obviously, this is going to be crucial as we get to further missions and longer duration missions, things like that. So how is the ESM's role going forward as we move into the Artemis program, especially Artemis 4 and 5 heading out to the moon?
So the 3rd and 4th ESM 3 and 4 are about 5 miles from here in the ONC, in the Neil Armstrong building. And they will support the Artemis 3 mission, which is now Earth orbital mission. And they will support Artemis 4, which will be the first landing, whatever the lander is. And ESM 5 will be delivered, is currently in production in the Airbus facility in Bremen, in Germany, and will be delivered next year in KSC. And Artemis 6 is following closely because we are on a 1-year cadence, and ESM 6 will be delivered in 28.
So it'll be ready to meet that enhanced amount of flights that NASA is announcing.
Yes, we even will have to accelerate a bit because we were targeting a 1-year cadence, but now, as you know, the administrator is more keen on a 10-month cadence.
And as we are about 30 seconds away from the 1-hour mark, I do want to ask one personal question of your excitement level and your thoughts.
I'm very excited. Unfortunately, I'm old enough to remember Apollo 17 when I was a kid. And so we are back toward the moon. As a European, I'm very proud that European countries are part of this endeavor. And we hope that the ESM will deliver perfect performance.
Excited to see the burns, excited to see the life support system in space. Philippe, merci beaucoup.
Thank you very much.
Das, back to you.
Thank you, Sawyer. We are loving the spontaneous interviews out there. If you get any more of them, definitely let us know. Big thanks to Sawyer for setting those up. We literally just have a little spot, and some people come around, and we put a headset on them, and we're like, hey, tell us about how you're involved with a rocket. But we are now officially, as I click over here, under 1 hour away. My clock says 59 minutes and just about a half. But that puts us right underneath 1 hour. Again, that's targeting the beginning of the window. The closeout crew is a little bit behind schedule. We think that they're already supposed to be sort of like getting out of Dodge, and we do see this live feed from them up there, but we will see when they go down to their vehicles and evacuate the launch pad, leaving the only staff, the only crew there at the launch pad, the ones that are actually aboard the rocket, having been buttoned up into Orion on top of SLS by the closeout crew here. So let me do this. I'm going to say thanks to some folks who have been coming through. 33 Raptors Mimi gifted some Red Team membership, spreading the membership love with some other folks here. We've got that girl Hannah, 1236, said just bought the Artemis 2 patch. Also Flight 6 patch. The first catch happened on your birthday. Hey, that's pretty cool. Let's go SLS and NSF. Love from Great Britain. Chris W. Nice. Did a super chat. Ryan from the whole UK NSF team. Apparently they love you, Ryan.
Wonderful. I love everybody watching. And may I just say very quickly, I just got a notification on my watch from this little app called Next Spaceflight, which said 1 hour until Artemis 2. That felt surreal, so surreal. I screen captured it and I posted it on X. But that is absolutely bonkers. Next spaceflight just sent me a 1 hour notification for Artemis 2.
That is too cool. If you don't know, if you're watching Next Spaceflight, nextspaceflight.com is an app on iOS and Android and a website, and it'll do launch notifications. You can say, tell me every Starlink that launches from the Cape, and it'll pop up little notifications on your phone. Of course, you can filter it down to things that aren't the Starlinks. It has all sorts of like simulated mission information. You can see the launch trajectory. It is an app that we have... I guess we've created here at NSF. Yeah, it was created by a person who used to be here with NSF, and we continue to operate that app so all the space fans out there can make their phone go bing whenever they want to make sure that they don't miss a launch. So if you want, head on over and download Next Spaceflight. All right, and thank you for reminding me of that. I have my phone put away because I get too many messages, and yeah, I'm not going to read my phone right now. Continuing on, COL Mergs, Colonel Mergs, I'm going to guess. Great coverage as always. As excited watching this as I did watching all the Apollo launches. Mergs, that is saying an awful lot. If you caught all the Apollo launches in here today, maybe you're not watching the same way. Maybe it's not a 100-pound tube TV in the corner of a room with everybody sitting around on the ground. You might be watching on a mobile phone. A little handheld screen that has more processing power than we used to launch the original rockets. You may be on a huge TV on your wall or however you're watching. We appreciate you checking in with us. Got a lot of Pad Rap members and stuff like that. Cuckoo Jew is one of them. See Sauter's in there as well. Pick 'em with Dan and Dave. Not sure what that is, but welcome to the club. We've got a $50 super chat from NH Light. Thankful for NSF and love my fellow space nerds. We've got Goblin, who is a Pad Rat member. Justin Moore says, thanks to the NSF team and safe journey to Team Artemis. Steve Kyle's go for launch. Ralph Pedraza, hope I got the rolling R there correctly, became a Cap Cub member in Chubbs Fishing TV. Says it's 5 a.m. where I'm from. I'm still up for this. We appreciate you joining Chubbs. I'm not going to read them all. There's no way that I can keep all of them going, but I'll catch some of them on occasion. And also, apparently there are some people who love pins because those collector's pins for Artemis 2 are rapidly selling out in the store. We only made so many of them, and when they're gone, well, we'll see. It's going to take us a very long time to get more of them. We'll have to play that by ear, but they continue to sell right now over in the shop. How are we doing update-wise, Ryan? Everything's still looking good. Have you gotten any new information?
I haven't gotten any new information in text form, but in visual form, we can see the closeout crew are attaching. They're not attaching to a zip line, but they are harnessing themselves up to the White Room because they are preparing to essentially separate away from the Orion crew module, and that will create a gap. And of course, they need safety equipment to ensure nobody falls through that gap, which is why they've all been hoisted up. The full crew access arm retract isn't until T-8 minutes, so we're still... I was about to say we've got a long while yet, but we're at 54 minutes. I mean, this is starting to become real here. So we're about 45 minutes away from that. But this is just initially for that initial retract and separation. This is to make sure nobody falls through the gap.
The time is going to evaporate. Like when you get into these, we're under an hour now. Every time you look at the clock, you'll be like, another 5 minutes? What do you mean it's 40 minutes? What do you mean it's 35 minutes? From this, you can see what they're doing here. They're starting to lean over and undo that seal. Remember when we were talking about the plane boarding? Have you ever been boarding a plane and when you step across from the little jet bridge into the plane, there's that little gap and you're deathly afraid that you're going to drop your phone or your passport or something like that down in the little gap? Is that just me? I look at that gap every time and I'm like, is everything secure? Here, they are going to intentionally make a much larger gap, not between the jet bridge and the plane, but between the crew access arm, I guess we'll just call it what it is, and the rocket itself. So you can actually see the daylight in that one shot now. That's why they've put on their retention harnesses, because that whole thing is going to fold back here shortly. Daylight
and
gap's
they're going to
get
have
a little
to
bit bigger.
Not only that, they're also going to have to look down and check to make sure that everything is sealed and in place and everything looks good. So once they remove that sort of covering there and it gets pulled back, they are going to intentionally be looking down all the way from the top of the rocket straight down.
So there you can actually see more and more daylight forming, and they're down working on the bottom now. But that whole thing's going to swing away, isn't it, Sawyer? When I say swing away, it's going to sort of
Exactly.
fall away and then swing away, right?
Well, yeah, it'll back up a bit there. It'll kind of slowly work its way back and then lock itself into place. That is part of the terminal count. So once we get under T minus 10 minutes / L minus 10 minutes when they merge to go, and that will swing back. But in the event of an emergency or they need to get the crew out of the capsule quickly, it can swing back in a matter of seconds.
I'm looking at the NASA feeds. I don't think they're giving us a feed that really illustrates like a top-down view or something. But if they give us one of these feeds, seeing that sort of open up, that gap, it's really going to drive it home that the top of the tower where the crew were accessing that rocket so they could board Artemis, board Orion here, is going to start to separate. And that means the rocket is not quite on its own yet, but it's one more step in the process of getting this thing ready for flight. All right. I think we've got another update here. Did we get Alex back? I think we did get Alex back, didn't we? In just a second, we'll have Alex back. All right. We will get a mission update, a current status update from Alex in just a minute here. Yeah.
Yeah, you can see that we need to teach them how to expose their cameras a little bit better. But yeah, the gap is there, and there you can see a little better on the right side. But the crew will be looking over. There it is. Look at that. You can
There
see
you
the
go.
pad area below, and there goes the protective swing gate that they kind of had up against it. And now you will see them do the work to pull that sort of board in between the two away.
Yep, like a little ramp thing.
Yep.
That is
Yeah,
grass in the background, isn't it? That is the ground by the launch pad.
Yes, it is. And then they're going to move that out away.
Yep,
Get
that's
that
like
locked
folding
into its
in.
place. Yep.
Yep.
And Alex, I know we were talking about that update. I think we have you back now.
Yeah, I was trying to finish listening to the update. So I have a good news and a piece of bad news. I'm going to go to the good news first. Weather has improved to 90% go. So that's good. It was 80% before. The bad piece of news is they're tracking an issue with the battery temperatures on the launch board system, at least one of the battery temperature sensors. And so one of the things that is going on is that they're trying to look at that. And one of the problems is right now it is not an issue, like it doesn't preclude them to continue counting down the clock, right? The problem is if they get to terminal count and the ground launch sequencer hands over control to the onboard computer, right, on SLS, right? SLS computer will see that temperature sensor and say, nope, I'm not going. That could be an issue there, right? And so that is one of the things that they're trying to look at. We have no more data, no more information about the specifics of this issue with the launch abort system temperature, battery temperature. And the status and things like that, but they're working on it. And just like we saw before with the flight termination system issues, well, these things can be resolved, right? Unless it's something that is actually physical, something that they actually need to go to the pad, and therefore, maybe we have like an Artemis 1 version of Red Team going to the pad. I see that unlikely because this is the launch abort system side of things, right? But if there were any sort of issue that is physical and they're able to go to the pad, that will probably delay things, right, into the window. We have a 2-hour window, still 48 minutes to go until that opening of the window, so definitely lots of options at place. But they need to work on it, right? This is the problem with engineering. You gotta work the problem first, and then you figure out how to move on from there. We'll cross that bridge when we get to it, right? It's that sort of saying. I butcher the same, but you know what I mean.
Is that trending in a direction, Alex? I mean, is that the sort of thing where, guys, it's just so weird? Like a battery heats up when you charge it, right? I guess a battery could heat up if you discharge it, you put it under load or something. But any more information on that?
Unfortunately, no. As I said, the only thing that we know is that there's an issue, right, with that temperature sensor on the launch abort on one of the launch abort system batteries, and it's just one of them. So this is the thing, right? It could be that just that sensor in particular is wrong, and maybe others are actually right? That happens all the time. You have multiple sensors on the same place. One of them is telling you that something is going wrong. Do you trust the one that is telling you that something is going wrong, or you trust the ones that are telling you they are right? Maybe the ones that are telling you they are right are wrong, right? That's the problem. That as an engineering team, you have to work through all of this. You have to actually find what is going on, whether it's just a sensor issue or there's an actual problem with the battery temperatures, and then how to move on from there. As I said, there's no actual details of what is going on exactly with that sensor, right? With that temperature reading on the launch abort system battery. But again, as I said, one of the problems will be, yes, they can probably go into terminal count. Yes, probably the ground launch sequencer can say, I'm not seeing this, right? Like what is usually called masking the temperature reading. The problem will be the automated launch sequencer on SLS when they do that handover at T-minus 33 to T-minus 30 seconds, that 3-second handover. When that handover happens, the automated launch sequencer, it basically goes through every sensor, every reading and everything, and it tells whether every parameter is good to go, right? And it's automated. There's no manual inputs or anything like that. So you don't really cannot stop that. That's the problem. And so it's one of those things that maybe it will not be a problem to go into terminal count, but maybe the automated launch sequencer will.
Those couple of
suppressed
overvolt messages, we're going to go ahead and clear those off your screen.
We see them and we copy.
All right. And we're still working here, trying to get through everything. So we're getting close, and then trying to talk that other issue that we just picked up a little bit ago. But I think work-wise, we're doing really well.
Sounds good, NTD. We're doing great on board.
Glad to hear it.
All right. So you can hear they're continuing to work on the preparations. I think this is a cool shot, like having the astronauts on the one side, and we'll get another shot there in a little bit on the other side, but just being able to see those screens with the astronauts ready to go, that is too cool. For me, that sort of drives it home, that this isn't just a rocket with another batch of Starlinks on it or something like that, or even, a test flight. Oh, we just hope this thing doesn't blow up and destroy the pad. This is a real mission with humans on board, and you can see them sitting there on the left-hand side. That is what's been driving it home for me. Ryan, how you doing?
Bit of disbelief because for years at this point, like Artemis, just very quickly, Artemis 2 was November 2022. I joined NSF in January 2023. Like my entire time at the company so far, we have been waiting for Artemis 2, just waiting. Oh, it's going to be in a couple years. It's years down the line. It's not anytime soon, and suddenly it's 44 minutes away, and it's felt far away for so long that it's surprising that it's suddenly 44 minutes away. Like, we are 44 minutes away from this launch window opening. We have crew in the vehicle is closed out, the crew access arm is prepped, the launch teams are prepped. We are getting ready to go. We are here. It has arrived. We are here.
Yeah. They keep saying we are going. And it's like, you're going in a couple years. You're going in a couple years. Like, we are going right now. That's where we're at in the count. The clock is continuing to tick down just under 40, actually under 45 minutes now. Like you said, everything was sort of like marketing slogans and hoopla and PowerPoints and, and then the rocket rolls out. Okay, that's exciting, cool. And then we get people on board, but that's what is happening today. I continue to have everybody, let's think some positive thoughts for battery temperatures or whatever else, maybe range monitoring equipment, whatever else might be happening, because an awful lot of stuff is coming together here. And this mission is currently, Looking pretty good. The clock continues to tick. We will see. Really quickly, I'm going to hop over and say thanks to just a few more people because I love to see these popping over in the super chats. Michael Fussel, hope I said your last name correctly. Me and my son Connor are watching our first lunar launch together. You say an important word in there. Your first lunar launch together. Michael, I appreciate you tuning in. Give a high five to your son Connor if you're out there and we see this thing launch. I guess a high five and a hug would be good, but hopefully we see lots more lunar launchers in the future. I appreciate you tagging in and letting us know. If you're watching with your family, let us know that as well. It's always something that's cool to hear. Patrick Bob, how you doing, dude? Did another 50 Red Team gifted memberships. Patrick Bob, one of the huge supporters of the channel here, making it so we can keep doing what we're doing. We appreciate you, Patrick. 50 gifted memberships. Stuart Little, nice, did a little bit of a super chat. We've got Hallow Jack doing some super chats as well. Here we've got Nick Tonks Astrophotography did a super chat and says, watching with my family on our vacation. Can you shout out to the Tonks family? Thanks, NSF. Great coverage as always. You didn't have to ask me. I would have just said it. Continuing. That is. Folks, I can't read them all. I will continue to check in on occasion. I especially love the ones that say that you are watching with your friends or your family. You're sharing this. You've dragged somebody in front of the screen so that they know that we're going back to the moon. Maybe they didn't know or they didn't care. But if you're watching, we do appreciate it. In fact, I think we've got a bit of a video here to play. Apparently, y'all aren't the only ones who are excited about this. Let's roll the tape.
Artemis 2 is more than a mission to the moon and back. It's more than a mission that has to happen before we send people to the surface of the moon. It is the next step that gets humanity to Mars.
For decades now, literally thousands upon thousands have risen to that challenge.
One of the questions we get all the time is, are you excited? Absolutely. We are going to launch on top of the most powerful rocket NASA's ever made. And we're going to ride that rocket for 8 minutes into Earth orbit.
Human spaceflight is like a relay race. And that baton has been passed generation to generation. Mercury, Gemini, Apollo, Skylab, Apollo-Soyuz, the Shuttle, Mir, International Space Station, commercial crew, and now the Artemis missions.
We are bringing together the world. We are bringing together an amazing workforce, and they are bringing together an amazing vehicle. And at the end of all that, when you squeeze it all down, it created magic.
We are going to the moon together. Let's go.
How'd y'all like that? That was actually the trailer for the live stream here. Ryan, who put that together?
That
no, we may
would
not
be
have Ryan,
yours
right?
truly.
We do have Ryan right now. Did you make that hype video?
Yep. It took me an embarrassingly long amount of time to find some good music for that. Trust me, I was literally searching for weeks, but I found the right track eventually.
Outstanding. Well, the clock is here. The L- clock is still going, coming up rapidly on 30 minutes, still around 38 minutes, but you can see the rocket there on the left-hand side. All those other views, the close-up engineering cameras, it looks like we still have the crew access camera there in the middle. What might be happening is we might be able to see that swing away. We'll see if NASA gives us that camera at that time. But all over the Space Coast, folks are piling up. You see that top window there. That looks like a view from Jetty Park, if I'm not mistaken. Yeah,
Yep.
That is our Cape Cam at Jetty Park. Oh, all right. Sawyer, I just heard your voice over there. Are you still back at the press site?
I'm still here.
How are things shaping up over there? Are people starting to they start to migrate towards the edge? There's that rope to make sure the alligators don't eat them.
I may or may not have a camera already set up by said rope, but I've asked Max, who takes photos of the gators, to make sure they're friendly today. People are starting to make their way over here, especially by the countdown clock. There is a large group that's getting ready to gather here. That's when you know it's really starting to get real and starting to feel real. I mean, we are at T-minus 10 minutes and holding. We are in the planned hold, and this is the last planned hold before entering the terminal count. That is... I mean, I'm nervous but excited, full of anticipation, and the vibe here has definitely shifted. It's more towards, oh my gosh, this is really happening, as opposed to earlier where it was the hype around it. It's not hype now, it's we are ready.
Yeah. That's where it gets a little bit confusing. The L clock continues to count, but like Sawyer was just saying, the T clock is in a planned hold. It's like rocket accounting, rocket math. How do you actually count these things down? But the clock is continuing to tick down towards the beginning of that window.
Yeah, so for those who don't know, the L- clock will not stop. So the one you see in the top left of your screen, as long as they're proceeding on time, it won't stop. So hopefully that keeps counting. And as you pointed out, with the T-minus 10-minute hold, that one is planned in the hold. And the nice thing is, once they give the go to continue the hold, T-minus and L- clocks will merge.
Sawyer, is that what happens? Like, is the L- clock going to continue counting down? And when L- says L- 10 minutes, should the T- clock start up again and then they both match? Or are there more wacky holds? Or
no, that's it. So if all goes well and they give the go to continue into the terminal count, as soon as that clock hits L- 10 minutes, the T- 10 minute clock will also begin. So at L- 9 minutes 59 seconds, it will be T- 9 minutes 59 seconds and counting.
Excellent. It's rocket math. You thought rocket science was hard. Rocket countdown clocks are even harder. In any event, folks, if you're just joining us, the rocket on the screen is SLS. It is the rocket for Artemis 2. Why is this such a big deal? Because on top of that rocket right now, up in the little white part, the pointy bit at the top, there are 4 human beings on this rocket. They're not just going up and down for a joyride. They're not going to the International Space Station. They are going into Earth orbit. And if everything checks out, they will end up doing a loop around the moon. The first time we've done this in quite some time, over 50 years since we've had anybody out that far, setting firsts left and right. But we are continuing to count down, now less than 35 minutes away from that scheduled liftoff. Like we said, people all over the Space Coast are lining up to see this rocket. I'm curious. Here it goes. Mods know what's going to happen. I want to know in the chat right now, where are y'all watching from? As we come up on T-minus 30 minutes, mods, just let it go. Tell me in the chat where you are watching 4 human beings on top of this moon rocket standing by for their launch. There is no way that I can read that because that is a lot of text going by. I see Sweden, I see Canada, I see Georgia, Evansville, Indiana, Germany, Philippines, Leicester, that was in the UK, Southwest UK, Adelaide, South Australia, on the other side of the world. We got a Germany in there, lots of UKs in there. Chile, Ireland, Costa Rica, KSC, nice. You can check in. Baton Rouge, Louisiana, Saskatchewan, Canada, Oregon. I can't read them all. It's just as they go by. Folks all over the world, even if you can't be there at the Cape, at the Space Coast, we appreciate you joining us here today. That's what we do. We are NSF, NASASpaceflight.com. We've been around for over 20 years, but you might have been able to figure it out yourself. We're not officially NASA. We're not reading a script or have and now we're going to talk. No, we're space nerds who reach critical mass. We had so many different skill sets to come together. People who love doing video, people who love doing photos, folks that write, folks that just hang out, folks that operate cameras. This is what we do. We hang out, we tell it to you like it is, and we have a fine old time here watching rockets launch. So if you haven't yet, and you want to find your way back to hang out with us in the future, there's a little button on YouTube. You know how to do that. Like and subscribe or whatever. Just come on back. Everybody is welcome to hang out with us anytime we are covering stuff. Last year, we did more live streams than days in the year, more than one live stream per day last year, because we cover basically everything that happens. So in any event, that's who we are. That's what we are doing. And you can always keep up with what's going on by being a part of the community around here. In fact, you know something, maybe you're not always on YouTube, and maybe you're on Facebook, or maybe you're on Instagram, or maybe you're on wherever, right? Every social media network, we are basically all over the place. If you just look for NASA Spaceflight, nasaspaceflight.com, you can find us basically wherever you want. And we post stuff on a daily basis pretty much everywhere. So in any event, we've got that out of the way so everybody knows who we are. Y'all keep on chatting over there, and the clock continues to tick. Now L minus, I gotta say it, L minus 32 minutes. We need to make the L in the interface that I'm reading like bold, so I know that it's an L.
Das, I think it's already bold.
What? No, that's like the most anemic L I've ever seen. It's like tiny.
Oh, that one. Okay, yeah, that one's a bit thin. I'll be honest. Yeah, sorry.
It looks like a screen element to me, so I just default into saying T minus, and I'm always wrong. In any event, there are super chats coming in. There are people joining the membership program. There are people doing tips at tips.nasaspaceflight.com. The merch, I think some of the merch is almost sold out. I'm going to have to check in with the shop team to see if there are pins left. But you don't have to do any of that stuff. If you're able to support, if you want to get a shirt or something like that, you can check out the shop. But every single person here joining us in the live stream is welcome to just hang out. Heck, send a link to your mom. Be like, Mom, do you know they're launching a moon rocket today? Send them a link to the show. Hopefully, if your mom comes over here and starts listening, she thinks it's interesting and not boring at all, or whoever you share it with. But for now, I'm going to hop back over and check back in for a status update. Any new information in the background? I guess I could just ask out loud. I've been running my mouth for 2 minutes.
Nothing yet.
Okay. I believe we did see earlier,
yet.
though, that weather
Just
improved
waiting.
to 90%.
Well, yeah, that was a really nice piece of news earlier. But yeah, we're just waiting to see what is going on with that launch abort system battery temperature reading. Yeah, other than that, officially, we were talking about earlier the L minus clock. You were talking about that bold L that you're gonna need, right? For that.
You should flash. Put a blink tag on it.
Exactly.
Y'all laugh. Do you know what I'm talking about?
I do.
Not really.
Sawyer, you're old enough to know what I mean, right?
Yeah, I get it.
Chat, okay, back me up. Does anybody in chat get the joke there? Hopefully not. I grew up in the .com. Anyways, carry on, Alex. I apologize.
Yeah, so the L minus clock, the T minus clock, two different clocks, right? The L minus clock is just basically as if you were to look at your watch and you said, how long is it until 6:24 p.m. Eastern, right? That's basically what it's counting down to for, right now. But the T minus clock is the one that they use internally for their own systems and for their own procedures. And that one is currently in a planned hold, right? That started actually about 10 minutes ago. It runs for about 30 minutes. And you can imagine that, that hold happened at L minus 40, right? At L minus 40, the T minus clock entered a 30-minute hold at T minus 10. If you do your math, that means at L minus 10 minutes, T minus 10 minutes is also the same, right? So both clocks are the same. However, it's not like just everything will continue on, right? It's not like the clock will just be, the hold will be released and it'll just continue counting. No. So it'll only be continuing to count if the launch director gives her go for launch. And so that'll be the next major step in the countdown. But again, they're working on that issue. I'm listening here to see if we can get any updates from the from NASA PAO, the public affairs officer, and so this is one of the important things that I'm keeping my ear on and see if we can get some kind of data on how they're going with that update, with that excuse me, that not update, with the work on the launch abort system battery temperature. They have a 2-hour window, so they can hold at T minus 10 minutes for as long as they want throughout that 2-hour window. So we'll see what happens.
Or if they can go out there with a little fan and like wave at the battery to cool it down or something, like an ice pack or something to put on it. I don't think that's allowed.
Put a bunch of liquid oxygen on top. See that?
Yeah, I mean, they're venting that liquid oxygen right now, so you just plop some of that on top and, Bob's your uncle.
I guess, do we know if it is out of range high or out of range low? Like, is the battery too cold or is the battery too hot? It changes what you need to dump on it. Like, you don't want to put liquid
that's
oxygen
a great
on
question.
it if it's too cold, right?
Did they just say out of range or temperature?
Yeah, I think they just said out of range.
Yeah, just out of range. Jeez, well, it's tougher to say.
All right. I am hopeful this is the last time we have to ask for this pressure reading, but looking for the next one that we can get here, please.
Yes, sir. CBA steady 2,600 PSI.
That is very good news. All right, and we are working towards getting a solution on our issue. I think we're there and working through that. So the rest of the work's about done here at the pad, and our closeout crew has departed. So the rest of it's just getting ready to go. So good luck. Godspeed to all of you.
Copies all, Jeff.
Yep.
Thank you, sir.
That sounded very positive. It said they said they were working through that issue, but it sounded like they were close or they had it. Did Mel the only one that heard that?
That's exactly what I heard. So unless we're all hearing things and hallucinating, I think this big, beautiful orange rocket is ready to go. Almost.
We are manifesting a positivity for the launch. I do love, like, here when we have this upwards looking shot, look at the skies. Sawyer, like with the old Mark 1 eyeballs out there, is the sky that blue and clear right now?
It absolutely is. There's a few little puffy clouds way off in the distance, which are out of the way of where this is going. But otherwise, you look directly overhead all the way southeast, pretty much all of northeast, which is the kind of inclination or direction this will be going. It is blue skies. I expect amazing visuals for today's launch if it goes. I mean, this is perfect weather. Perfect.
That is fantastic. You know something? Little puffy clouds like that, like, we don't mind the puffy clouds. They give it a sense of scale as the rocket goes past a cloud. If it's just perfectly blue sky, it's sort of hard to tell how fast that thing's going. But dang, if it goes past a cloud, you're like, man, that thing is really moving. So it is looking absolutely beautiful out there. There's our live camera over from the Titusville side of things, and you can see more and more people stacking up over there as the clock continues to count down. Folks, it's 25 minutes. I'm going to say thanks to some folks real quick. Seth McGill, hello from Oklahoma, says that. Wilbo, good to see you as well. Gearbox Scott joined the membership program. Mark Stang actually joined the membership program as well. Here's one. SPS Music, so excited to see the rocket that I helped build at MAF, about to hopefully launch. Hopefully was in parentheses there. Something I touched is going to be flying to space. Shout out to the folks at MAF who helped make this happen. Can anybody help me out? Am I supposed to say MAF or MAF, like VAB?
I just say Mashoud, makes it easier. Just go with the name.
Just go with Mashoud. I don't
I've
know.
heard the astronauts say math, so that must be the correct one.
That's like you say Vab, and you're like, Vab, really? Who are you?
They also say Mashu instead of Mashoud, so,
You're right.
Hey,
sorry,
SPS
I'm not Nolans. I said it wrong.
SPS Music, thank you so much for the message and the support over there. Just continuing to say thanks to a lot of people joining the membership program. I did get one from Annette Bideford here. Says, just so everyone knows the truth, my son did not have to drag me into watching. We were on this at the start of the morning. Love NSF and my son Steve. Go Artemis 2. Go, go, go. And we got 3 thumbs up after that. Annette Bideford, we are always happy to see you here in the chat, watching with the family, and it's a long-time huge supporter of what we do. One of the reasons we can keep showing up and doing these things, but it is fantastic to see a message from you over in the chat. I know it's not the first one, but I wanted to make sure I got back to that one. Here's one more. Tracy Williams says, keeping a family tradition going. I watched Apollo missions with my dad. We watched many shuttle launches together as well. We were blessed to be able to tour JPL and then NASA. He was with CDC. Tracy, thank you so much for joining. I love the messages that are like watching with my friends, watching with my family, all of those sorts of things. Apparently, Kyle Swigert is watching from 34,000 feet thanks to Starlink. Thanks for the coverage, NSF. Somebody is aboard a plane that has a Starlink on it. But folks, the clock continues to tick. I'm not going to spend all of our time reading this, except for this one from Horacio. 99 curly L's saying, why is it orange? I'm so excited watching with an orange dog from East London. Does anybody want to catch that real quick? Hey, Ryan, you're from that side of the pond. Give him a home accent and tell him why it's orange real quick.
The rocket is orange because that is the, how should I say, natural born colour, helpful zoom in here, of the insulation foam around the core stage. So the core stage propellants inside, they're cryogenic. They are hundreds of degrees below zero, whether you measure in Celsius or Fahrenheit, hundreds of degrees below, which means they need to be insulated from the very warm, very humid Floridian air. And to do that on the Space Launch System, they spray on foam around the core stage, around those fuel tanks, in order to insulate it to stop them boiling off, or not stop, but prevent boil off as much as possible. And when in the sun, that foam actually tans. It literally tans and it turns orange. I guess it's going a little bit brown at this point, but it was almost yellow. If you go after launch, of course, go back and watch our rollout stream from January, the conical structure there, the conical orange structure, that was yellow. It tans in the sun.
Yeah, it does. It comes out sort of like a light yellow color, and the more UV hits it, the more orange it gets. So that is the answer as to why it's orange. Plus, we all like orange. Orange rocket, good, right? Continuing on, Sawyer, did you have a bit of an update for us? Something to
Yes,
mention?
per the Artemis blog at this point, they mentioned the crew leaving the pad and that everything is into the Launch Control Center. They did mention, I want to quote from this, engineers investigated a sensor on the Launch Abort System's attitude control motor controller battery that showed a higher temperature than would be expected. It is believed to be an instrumentation issue and will not affect today's launch. Weather continues to cooperate and has now been upgraded to 90% go for launch.
No kidding.
TDR entity.
Go ahead.
Stand by.
All right, Reed, we can go ahead and configure for terminal count at this time. Need team over to your channel here in just a minute.
Integrity copies.
Continuing on, we just heard a call out that they're configuring for terminal count. I think
And
we
just
should
saw the
probably
closeout
run
crew,
down.
by the way, coming back, just really quick.
Is that
We
that
did
was
see
the closeout crew van?
That was them on their
Nice.
way back. So going with the blog post there as we get close to the terminal count.
Thank you. All right, so stuff is going to start happening very quickly here, and I think we need to set some expectations, make sure that everybody sort of has a basic rundown of what's going to happen. So, Alex, I think you can talk us through what we expect as the clock continues to tick, right?
Yeah, so we are under 20 minutes, hopefully, if they're still targeting the opening of the window. So right now, we are basically approaching the point where Charlie Blackwell Thompson,
ahead.
the launch director... Oh. Hartley's racing, by the way.
No kidding.
She will poll operators for going for the terminal count and launch. And when that happens, of course, the flight crew will be told to get their visors down. And then at T-minus 10 minutes, in L-minus 10 minutes, I should say, both clocks will be synced, basically synchronized, and the T-clock will resume counting, and they'll call out GLS go for terminal count. You will hear GLS all the time during that terminal count. When it says GLS, the person that's going to be calling out, that is the ground launch sequencer. That is the ground computers that are sort of sequencing basically the whole and choreographing that whole 10-minute, mostly 10-minute countdown for the GLS for the ground launch sequencer. And so crew access arm will retract about 8 minutes before launch. Then at 6 minutes, we're going to have three events basically at the same time, the GLS, the ground launch sequencer, will give the go for core stage tank pressurization. We'll get the Orion ascent pyros,
Okay.
pyrotechnics,
Copy
and
all.
everything aren't. Oh,
And let's see. I see GLS. Can you help us with that, please?
hey, see? You just said GLS. So yeah, 6 minutes.
Gen 001.
There we go. They're still talking. I don't know when to go. 6 minutes. Tank pressurization for the core stage. Orion ascent pyros and Orion set to internal power. Just right after that, the liquid hydrogen replenishment will end on the core stage. The launch abort system will become available at T-minus 5 minutes and 20 seconds. At T-minus 4 minutes, 40 seconds, the high flow bleed check will also be activated for the hydrogen side of the engines. And then we're going to get the go for core stage APU start. That's the auxiliary power unit. And after that, that'll be at T-minus 4 minutes, by the way. And after that, we will probably see, hopefully if we get those views, the engines doing a gimbal check, as it's called. And so they'll be moving in a pre-planned pattern to make sure that all of the moving systems, all of the gimbal works on those engines. Then they'll terminate replenishment on the ICPS, the upper stage. Liquid oxygen replenishment will end at T-minus 3.5 minutes. T-minus 3 minutes, 10 seconds. GLS will be go for purge sequence 4. That is when they switch to helium purge on the high pressure oxidizer turbo pump seal. And I believe now Daryl is giving an update, if I'm not mistaken.
So there are
Standing
two
by.
batteries on the LAS. The LAS, of course, and with the help of my 2-year-old son's model rocket, Daniel said I could use this, so it's okay. The LAS is right here. It's the tower above Orion. Orion capsule's inside of here. It's used to pull Orion off the rocket in case the rocket is something's going on with the rocket, either on the pad or in flight. 2 batteries are bad. Well, I'm sorry. One of the 2 batteries reported an out-of-family temperature, and it was very much out of family. And so they checked their data going back into the vehicle assembly building where they recharged the batteries and worked on them. And they have good, solid data, they reported, that tells them that this is an instrumentation failure, that there's something wrong with the sensor. And so they took it before the mission management team, which has to accept the risk, any changes to launch commit criteria, which this would be one, and they all fully accepted it. So now we are clear as far as that constraint is concerned. And one quick thing as we count down now, we are getting into the final minutes before liftoff. There's a 2-hour window. We haven't quite set the T0 yet, but this is a list of the cutouts. There are 150 cutouts that are included for this 2-hour launch window. And that's important. They're in very small print. That's important because there's basically 16 minutes inside this window that they cannot launch. And these are because of small things flying in orbit. There's a lot more things in orbit than there were back in Artemis 1 when we had 35 to 40 cutouts. For that reason, because of these 156 cutouts, they're going to be managing the launch window as we go forward. So they may have to wait out one of these cutouts. They range in time between 2 seconds to 23 seconds, but you'll hear the NASA test director talk through that. We're getting ready to merge that loop from NASA test director Jeff Spaulding.
I think here Daryl's talking about cutouts, but we really need to explain what that means, right? All the satellites in space. You've heard lots of Starlinks are up there. You've heard all these communication satellites, weather satellites, all sorts of stuff. There's debris as well. We should talk about the debris. When he's talking about the cutouts, he's talking about literally holes in space that they can launch through. And so it's not just, we have the entire 2-hour window, we can go whenever. They have to shoot for a hole. You can't launch if there's a Starlink satellite flying right where you're going to be flying. If there's a piece of debris that's been tracked since the 60s because it's a Soviet stage that is up there from being put something in orbit. They have to look for all of these. They call it COLA, right? The collision on launch avoidance is what I've always heard, but it's shooting for holes in space, trying to find a hole that you can launch through, because just because you have a 2-hour window does not mean that the skies are clear that entire 2 hours. So that is what Daryl was just talking about. They have not quite set the T0 yet, which sounds like they may be hunting for a T0 a little bit into the window. That's not a bad thing, but also giving us that update on the battery temperatures. Let's talk about that for just a second. On the rocket, thousands and thousands of sensors. So we have so many different things reading battery temperatures, pressures, levels, forces, all these different things. And the computers are sitting there watching all of those sensors. But sometimes a sensor can go bad, right? In some cases, you may have 3 sensors that are all measuring the same thing, or you may have 3 sensors that are measuring similar things at slightly different points in the tank or the rocket or whatever. And it is possible, if you get a bad result from one of those sensors.
OTC Runner is one.
Stand by, we may have a poll here.
Yes, sir. Reconfigure ARS primary loop ISO valves.
Copy, that's in work.
And CDR OTC Runner is one.
Go.
ARS loop ISO valves are being closed at this time.
Integrity copies.
NGDLP.
Go.
Yes, I had a discussion with Sea Ice and with MER Manager regarding the observation that Sea Ice had a few minutes ago. They were able to confirm with BCI photos that the condition that they observed has been there since 2025. MER Manager has had a chance to review the findings, and they do not have any constraints from either a Sea Ice or MER Manager perspective.
Okay. Copy all. And Launch Director, NTD, you copy?
Yes, sir. I copy. That's good news.
OTC.
OTC.
ARS primary loop isolation valve configuration is complete.
Copy.
And CGLS NTD, cancel pending, please.
GLS copies, and that's complete.
All right, and for all personnel, we got a little bit more work to do before we pick up the clock, and we're about a little over a minute from getting to T-minus 10 minutes, but we've canceled the resume time there, and then we'll pick it up after we get through all of our work and anything else that we need to do to get through the remainder of count. So we'll continue working that to get to our T0 today. So when we get to about 50 seconds from now, we'll extend that hold.
CVSE OTC. CVSE 400-290, looking to verify that we are configured for ascent.
Yep, give me about 2 more minutes. I'm going to start CMA2 streaming.
Copy.
NTD COSE hold requested.
Copy that.
I have an LCC violation of O-CT-004, S-band transponder anomaly. This was a transient LCC violation, so transponder 1 had a demodulated SNR estimate that went down to 2 dBm when it should have been between 10 and 13. It is now back up to 12, but we did lose that for just a moment. It does not appear that we lost our bit sync or carrier lock, which would be indicative that we lost our lock with the vehicle. So at this point, recommendation would still be go. However, we do have a pre-planned contingency procedure if we want to look at that. But again, this is transient, so we're back in a nominal range.
All right, let's see, LPE NTD.
Yeah, we're not seeing that hit. So I guess the question for COSE, was that less than 3 samples? Is that below our persistence?
Stand by, let me look. It did look like it did persist for several seconds on mine, but let me take a look at the number of samples.
Could I get a repeat on the affected LCC, please?
Yes, ma'am, that's going to be O-CT-004.
Thank you.
I'll see if we can hop in real quick. I don't know if they'll keep talking there, but let's translate some of what you just heard. You can see the clock is T minus 10 minutes, actually T and L minus 10 minutes there, but you heard that they had a little bit more work to do and they were going to cancel that resume. What they were talking about there was exactly what we see on the screen now. The clock has sort of
taking a look
stopped.
at the data right here. Looks like that was a single sample.
Yeah, copy that. RFTS does report that they also lost lock for about 5 seconds. So I would love to ask KUS and see if they also lost lock with the vehicle for any extended amount of period.
And COSE, while we're doing that, these are 1/10 hertz measurements, correct? So we would have had to lose it for over 10 seconds to get a second sample?
Yes, sir, that's correct. It is 1/10 hertz.
Yeah, so from our perspective, the allowance is effectively up to 30 seconds, up to 3 samples based on the 1/10 hertz. This is not an LCC violation, I believe.
Yes, sir, I would agree with that at this point. Copy that.
We're checking with KUS on 232. I don't think they have 212 access. We're trying to verify, but it sounds like they have a loss of lock as well. About 2 seconds.
Okay. And I guess for both KUS and COSE, do we have lock now?
That's affirmed. We do have lock for COSE.
They're talking about
Yeah,
a
so from the
brief
integration
data
console
dropout.
perspective, we did have a temporary loss there within the allowable, and per the requirement, let's go.
And this is Houston Flight. We have lock and we have good telemetry here in GSE.
And KUS is reported to they have good lock now. So with all of that, OSC, then are we in a go configuration per your LCC?
Yes, sir. Recommendation would be go.
Okay. LP, you concur with that?
Yes, sir. LP concurs go.
And Launch Director?
Yes, sir. Launch Director concurs go.
All right, and I'm going to go ahead and just verify everybody has everything else complete, Launch Director, and if we do, we'll be ready to pick up the poll at that time, unless there's something else that you're aware of.
No, sir. Let's verify all our work is complete, and I would like one last check of our constraints list.
All right, let's see. OTC, are you still waiting for ComConfig, or are you complete?
That is
with
affirmed,
everything?
sir.
Okay, is that your only open item?
Yeah, OTC, this is CVSC. That 400 step 290 is complete.
Copy. Okay, so OTC, you're complete with all of your work?
That's affirmed.
All right, copy that. STC?
STC is complete.
And GTC?
GTC is complete.
Okay, excellent. All right, and LPE, just want to verify we have no open constraints at this time.
No open constraints. We have a clear board, sir.
Okay, tracking the same here. And Launch Director, with that, we are clear and ready to pick up the launch readiness poll with your go.
All right, sir. I am go for the poll.
All right. And for all personnel, this is the NTD conducting the Artemis II launch readiness check. Verify ready to resume count and go for launch. OTC.
GTC is go.
STC.
STC is go.
GTC.
C's go.
MCO.
TO's go.
Safety Console.
Safety Console is go.
LPE.
LPE's go.
RTD.
RTD's go.
Houston Flight.
Houston Flight is go.
ROC.
ROC is go.
And CDR.
Cruise go.
Copy that. Thank you, Reed. And Launch Director, NTD, our launch team is ready to proceed at this time.
All right, NTD, I copy all. At this time, I'll perform my poll. Attention on the net. This is the Launch Director performing the final poll for launch. Verify no constraints and go for launch. EGS, Program Chief Engineer.
Artemis Chief Engineers are go.
Copy, thank you. EGS, Chief Safety Officer.
The Artemis CSOs are go.
Copy, thank you. Range Weather.
Launch weather is go.
Thank you, LWO. And Artemis MMT Chair.
MMT's go.
Thank you, John. And Integrity Launch Director.
Good to hear your voice, Charlie. PLT.
Thank you, Charlie. This is Victor. We are going for our families.
MS1.
This is Christina. We are going for our teammates.
MS2. This is Jeremy. We are going for all humanity. All right, Charlie, your Artemis II crew is go for launch. Full Send.
I copy that. Reed, Victor, Christina, and Jeremy, on this historic mission, you take with you the heart of this Artemis team, the daring spirit of the American people and our partners across the globe, and the hopes and dreams of a new generation. Good luck. Godspeed, Artemis 2. Let's go. And NTD Launch Director.
Go ahead, Launch Director.
Yes, sir. You have a go to proceed with countdown.
Copy that. I'll put it in work. CDR, NTD.
Go.
Trigger your visors and initiate short purge per your EPROC 10.1.1, steps 8 and 9.
10.1.1, 8 and 9 going to work.
Copy. CVSE, NTD. Start and verify recordings of our Orion cameras.
Copy and work.
Thank you. RSR, NTD.
RSR.
All right, perform the booster ignition SNA arm rotation. Enable at this time, please.
RSR in work. Booster ignition SNA arm rotation enable complete.
Copy that, thank you.
Integrity crew, close and lock visors.
I don't even want to talk. That's exactly what you wanted to hear right there. We're going to get that clock coming back up. It should begin to count. But across the board, you heard the launch director and the rest of the teams of folks that are managing these preparations say that they are go. So what's happening now is they were finalizing that checklist. We're going to get that exact T0. We're going to have that come up here on the countdown. But when it does, we should expect to be minutes away from the launch of Artemis 2. If you're just joining us, it's a big orange rocket. Why is this
and
so
ECL
important?
NTD will be waiting for your verification on the short purge.
ECL copies.
And for all personnel, once we get that short purge verification, we'll verify that we are clear to go, and then we'll proceed with the terminal count.
I'm waiting for that terminal count. Why is it so important? Because in the white part of the rocket, the cone part up there at the top, there are 4 human beings. And they are going not just into low Earth orbit. If everything goes to plan, they will be on their way around the moon.
About a minute.
Copy.
I have to say, hearing the words from the crew there in the go, no go poll, that flicked something in my brain, and my heart is absolutely racing.
Here at the press site, there was an audible cheer. There were people clapping. There was a woot, especially when he said full send. Commander Reed Weissman there.
Outstanding. Sawyer, are you going to go start to get cameras set up as soon as that clock starts to count?
As soon as we enter the terminal count, yes, I will head over to my cameras. I will report back shortly after launch to provide the atmosphere here, the vibe, and the feeling. But right now, people are moving into position. Everyone's heading closer to the rocket. You can see the smiles now. At the same time, you can also see everyone's getting down to business. This is, the serious moment here. So this is a wild environment. The energy here is electric, and hopefully the same wherever everybody else in the world is watching.
Short purge initiations verified.
All right, copy that, and we're verifying our constraints.
On our end, the voice of Sawyer Rosenstein there at the press site, just over, what are we, 2.5 miles away from the launch pad, Sawyer?
All right,
yeah, a little
we're
over
clear
2
from
miles.
Cutouts. And with that, we're going to resume the clock momentarily.
Oh boy.
And CGLS,
Here we go.
You can resume the clock on your mark.
GLS copies. 3, 2, 1, mark. GLS mainline has been initiated.
T-minus 10 minutes and counting.
We are
T-minus 10
counting.
minutes of counting. We're going to reset our clock so that it matches, folks. It's going to take us just a second. But there is that clock counting at the press site. The American
like
flag
they
and the
may-
Artemis flag. Go ahead.
It's like only 10 minutes into the window. Of the 2-hour window, they may only use like the first 10.
We'll take it.
6:35 p.m.
Just a couple things that they were closing out there at the end.
Okay, well, I guess we should be talking about what we're going to see, right? Because we are
Well,
one
we're gonna
minute
have
now to crew access arm retraction.
Sawyer Rosenstein, the voice you heard, checking in from the press site
And
with
Houston
Sawyer.
flight
Sawyer's
and
gonna
rock. Our
hop
new
off.
T0 is 223512.
Houston flight copy.
Wow, yeah.
223512.
There you
See
go,
you in a
Alex.
second.
22:35:12. Yeah. Now under 9 minutes. You doing okay, Alex?
Whew, I am. I don't know. I'm crying a little bit here because it's quite a really high heart rate moment, I guess. But yeah, we're getting ready. 8.5 minutes to go. Should be keeping an eye on that crew access on retraction in less than half a minute.
Good deal. We'll see if we can see that when it retracts away. Ryan, how you doing?
I am absolutely pumped for this thing. As I said earlier, we've waited so long for this moment, and it is 8 minutes away.
GLS is go for crew access arm retract.
There's the call out. And
Watch
there's
the
the
arm
arm.
swing. Yep. So that room at the end is where we saw them boarding the rocket, and now that arm, the entire room, it's like a building on a stick, is getting out of the way so the rocket can lift off. Crew are all buttoned up in the top of the rocket. We saw all those hatches get closed, suit leak checks performed, everything closed out as 4 human beings are standing by ready to ride this rocket. Coming up on 7 minutes now.
Up next at 6 minutes, core stage tank pressurization will be initiated. Orion will go into internal power, and the ascent pyrotechnics will be armed.
Won't be much
Very shortly.
visual there, right? We're not going to see anything
Yeah.
like the crew arm retracting like we did.
We may see, though, since you said visually, that vent at the top of SLS core stage might actually disappear as we go further into the terminal count, because that is venting out pressure, right? And they're now about to pressurize the tanks on the core stage, and so you don't want to vent, right? You don't want to release that pressure. You actually want to keep it. And so that vent might go away. Not immediately, it's not right in the moment, but further down. And we have their D getting ready to track.
Got that robotic tracking mount there with, I think, like 3 or 4 cameras strapped to it. D is going to track the launch with a joystick there, like playing a video game. But the
148
clock
BPM for me right now. I just got an alert.
148, and I was okay. We should
We're
hear
gonna
the
put
call
you
out
telemetry
soon.
Go for
on the
core stage
screen.
tank pressurization.
There it is.
All right, let's see.
And now this is a very important moment because from here on, if they were to hold, they only have 3 minutes. Okay? So, and
All
the
right, I
further
think-
we go down into the terminal count, the fewer options they have to hold and things like that. But
Yep, coming up on 5 minutes. I believe Alice has rejoined us here. Alice, do we have you back in comms?
I hope so. This is really exciting. I mean, my heart's fluttering. I can't imagine what the team are like on the ground. Getting this close to be able to see this finally
GLS
light.
verifies
Oh my
last
goodness.
capability available.
Oh,
And CDR, do you copy?
there we go. Launch abort system. Launch abort system is now available if needed. Next
definitely
call
a
out should
positive
be
GLS is go for FTS arm.
that one.
It's arming that flight termination system.
Yep.
FTS.
Gosh, we've been watching this
GLS is
countdown
go for LH2 high flow bleed check.
for so long, and now all of a sudden we're down to just 4 minutes left.
Yep.
Yeah. That call out was to prepare the engines, getting them further chilled down for the liquid hydrogen side of things. Coming up in 20 seconds, we'll hear the go for core stage APU start. That's the auxiliary power unit that powers the things like the gimbal system on the engines, on the main engines of the core stage. Hopefully we get a view of those engines undergoing a gimbal test about a minute after that.
GLS is go for core stage APU start.
There it is.
Now under 4 minutes.
Yeah. And we may see those jets on the engine section of the core stage for that APU, those auxiliary power units. There we go, the engines. And the whining, the usual cha-chung, cha-chung, cha-chung that they do. Yeah. Next should be GLS go for purge sequence 4. It's one of their purge sequences for their engines. Very long to explain. We have only 3 minutes.
GLS is go for purge sequence 4.
There we go.
There it was.
Boy.
Going like clockwork.
Yeah.
We're starting to bring
Next
up those
to-
pad mics so y'all can hear the sounds of the pad here too.
Yep. Next to big items will be the upper stage. The ICPS will enter internal power at T-minus 2 minutes, 20 seconds. And then 20 seconds later at T-minus 2 minutes, the SRBs, those solar rocket boosters on the side of the vehicle, will also switch to internal power. And then the core stage will follow at T-minus 1 minute and 30 seconds.
At 2.5 minutes, here it comes.
Yeah.
I believe it's at 2 minutes and 2 seconds that the ICPS switches to internal battery power, so that's the next
The engine-
that we're expecting.
The engines are moving.
They were gimbling, yeah.
They're doing like a TVC check.
They're dancing.
You can just see the shadow change a little bit down there.
GLS is go for upper stage to internal power.
Oh my goodness. How are you
That's
guys
like
feeling
Under
right
2
now?
minutes. Yeah.
I can't imagine what everybody there on the ground is feeling right now, because this is exciting just to watch on the screens.
GLS is go for core stage to internal power.
Here we go then, everybody.
1 minute.
60 seconds away. T-minus 50. T-minus 40 seconds.
GLS is go for ALS.
The vehicle is now in control of the countdown.
25. 20.
Expect the hydrogen burn-offs to
15.
ignite momentarily. Here we
10.
go.
GLS is go for core stage engines.
There go the Rofies. Here comes the deluge. Ignition of the RS-25s. Ignition of the boosters and liftoff. Artemis 2 is off and away! Let's go to the moon!
Houston, integrity, good roll pitch.
Roger, roll pitch. Integrity, AMT high.
AMT high.
If you can hear me over the rumble, we're 60 seconds into flight of Artemis 2, humanity's return to the moon for the first time since 1972. We are under the thrust of 39,000 kilonewtons out of the twin SRBs and 4 RS-25s. We're through max Q 10 seconds ago. Continuing to pitch down range. Beautiful ascent from the Space Launch System. Next up, we will have SRB separation 2 minutes and 8 seconds into flight. Approximately 30 seconds away, those twin SRBs will use up all their propellant and fall away from the SLS stack. "20 seconds away from SRB burnout and jettison. Gorgeous ascent downrange from the tracking cameras. 2 minutes into flight right now. And we've got burnout. And that looks like SRB jet. The boosters are separated. The core stage is flying on its own. Once producing 80% of the thrust at liftoff, those boosters are spent.
Integrity, guidance converged, performance nominal, upper stage RCS ready.
Copy all, Stan.
Was that an onboard view?
That was an onboard view.
I saw one of the strakes on the core stage.
SM priming complete.
Next up, we will have the launch abort system jettison at T plus 3 minutes and 18 seconds into flight. That's just over 20 seconds away from now. The launch tower will jettison and make way for the rest of the flight.
Yep, right before that, the service module panels will jettison. It's a 3-piece panel that protects the service module on Orion, and they will separate before that jettison. Oh my goodness, look at that.
There they go.
Look at that.
There's
Look at that.
the panel separation.
And there goes the launch abort
There it
motor.
goes.
Oh my goodness. Now the crew has a clear view out of the windows of Earth as they propel themselves all the way to orbit. Oh my goodness.
And we could hear Reed Wiseman,
Copy,
commander there,
Desmond.
confirming good separation.
8 plus 02.
As the crowds watch on from Florida, the next step in flight is going to be the
Houston has
course
you loud and
and
clear
engine
on
cutoff.
Tigris at the Carmen line.
Past the Carmen
There's
line
the Carmen
now.
line.
Outstanding, Stan. We have the same.
Once again, for 3 of them, one of them for the first time, Jeremy Hansen now in space. I would say there's probably another call out about 5 minutes into flight. That's when one of the abort modes will be 3-engine press. We're probably going to hear some of that. There's being some of those call-outs as well during ascent. Those are normal, basically informing the crew from here on. This will be, if something were to go wrong, right, that will be the option to abort. But again, everything continues to go well. Amazing, gorgeous launch views of SLS during daylight, and it continues to go.
This is spectacular.
This beautiful clean plume here, like this is where, for all of its leaky problems, the hydrogen
onboards
shines. It's making water behind the
Integrity,
rocket.
GPS processing.
All right.
Outstanding,
we just
Stan.
ignore
We see the same, and we have a beautiful moonrise. We're headed right at it.
Yeah, that's true.
I was about to say, can we just acknowledge they were basically on time? We were, what, 11 minutes after the launch window opened?
Yeah.
That's
Oh, yeah.
pretty impressive.
Yeah, that's on time.
And on the first launch window that they have actually attempted, right? Because they've done wet dress rehearsals and things like that. But now they are actually...
Integrity, 3 engine press.
That's the abort call out. If, for whatever reason, they lost one of the engines, they will be able to continue the mission.
That's why they said 3 engine press there. Like they can press
Exactly.
to orbit with 3 engines. They don't need that 4th engine because there's enough.
I believe it's
thrust.
all the way actually to the moon. Like the complete mission will still be able to be done.
Once you get to orbit, you're halfway to anywhere. So,
but yeah, boy, one of the other
It is
things I don't know
still-
if it's still visible.
you can still see it. It's still going down range on these long range cameras.
I don't know if
Go
they
ahead,
may
Alex.
call this out.
Integrity, looking good at 6 minutes.
There we go.
Yeah, we are 2 minutes from core stage Miko.
Yep. Before that, the core stage engines should throttle down to limit G's, because even though it didn't produce a lot of thrust on the ground, now the core stage is basically drained a lot of that propellant. It's already used a lot of that propellant, so now the acceleration is going up. So we're gonna
Integrity,
limit those G's.
expect nominal shutdown.
There we go.
Integrity copies, nominal shutdown.
Oh, from the launch control room.
That's from
Finally.
LCC.
Wow.
Be Charlie in the bottom, probably.
It looks like it.
That
doesn't
looks like
it?
Charlie.
In that position, yeah.
She's got to be excited. I mean, they've all got to be. Can you imagine having
Oh,
worked
yeah.
on this for as long as they have? What an achievement this is just to get this far.
There's the plume.
From Port
That's-
Canaveral.
I was going to say that's from the port down the road.
Those SRBs, they leave that sort of pillar of smoke, and then once they separate and you have this is the orange part of the rocket right now. What's burning is that central stage with the hydrogen and oxygen. And the hydrogen oxygen leaves a really clean plume behind it, whereas those SRBs leave a pillar of smoke that you ride into space.
Another point here, mode 4 abort once around, maybe? They're not calling it.
Integrity, AOA open.
There we go. Okay, so now they could be able to abort once around, basically all the way around the Earth and come back to the Pacific Ocean on the West Coast if this were to again, but it's continuing. It's going. It's still 20 seconds to Miko, main engine cut off.
Yep. Well, almost 10 seconds now.
10 seconds, yeah.
Almost 10
It took him
now,
10,
yeah,
seconds,
'cause I took-
10 seconds to say that. It's an Alex answer.
I'm also very nervous, so I cannot word right now.
Here we
I don't
go.
blame you. The chat behind the scenes, I was going to say there's some great images coming in we can't wait to share with you all.
No exhaust now.
Looks like Miko to me.
I don't know if we got that diff there, like...
Whoa! Stage separation!
Stage separation from the core
Integrity,
stage.
nominal Miko, core stage separated.
NASA's animation a little bit behind schedule here, but here it
For the
goes. It's
live
catching
feed.
up.
Oh my god.
And that was
NASA, go back to the live view, like...
And that was Capcom Stanley Love at Houston, and now is getting lost now over the horizon, I think, right?
Yeah, this looks like it's from the aerial imaging platform.
WB-57, yeah.
Yeah.
So right now, the vehicle is going to be in a planned 2,222 by 27 kilometer orbit. That's what the core stage just inserted Orion and the upper stage into, and that's so that the core stage will re-enter over the ocean when it comes back around in its orbit. So they're not, unlike a Falcon 9 launch, which you might be used to.
Integrity Houston, looking ahead to PRM numbers so far per the pad.
Not sure if there'll be a callback.
Numbers for the pad.
There we go. But unlike a Falcon 9 you might be used to, they don't need to light the upper stage right away. So they're actually going to be coasting with the upper stage for a little while now, and the perigee raise maneuver will be 49 minutes into flight. So this is absolutely nominal. We are not expecting the upper stage engine to be ignited right now.
Oh boy. Okay.
I'm being wowed at the moment. I don't know if you guys are looking at the chat, but I've seen a few photographs that have come in from our team on the ground. Jerry shared a couple of launch that are just absolutely mind-blowing. I can't wait for all the audience to be able to see those and purchase those as a memento of this historic day.
Now, it's very important to stress here that the mission is nowhere near done. We're just 10 minutes into a 10-day mission, okay?
Integrity, good. Neds deploy.
Absolutely. We're expecting the ICPS to do more work in about 49 minutes after launch.
And good, Neds.
Yeah, okay, so that call-out was the nozzle deployment on the RL-10 engine. So the upper stage has an RL-10 engine, and its nozzle extends
And
after
Integrity
separation.
Houston for PWD setup. Just a reminder, halfway open on the secondary.
And so, yeah, they were just informing the crew
We
that
copy that.
it got
Kinda halfway open.
extended.
I'm surprised by the realistic lighting choice here on the rendering. Like,
yeah, right?
It's a little tough to see, honestly. I guess the lights on the other side.
They can light this however they like, but they decide to light it realistically when it goes into the evening, which we can't see from the onboard cameras, which the animation is meant to replace. Okay.
Can y'all see? Does it even? Is it showing the nozzle extension on the animation?
Can't really tell. It's very dark.
I can't tell. It's very dark.
I think so. I can see a light grey line, and it looks further like the nozzle has been extended in the animation.
They should have done this with IR or something so we could see what's happening in the animation. You know something? I'm okay with it because there are 4 human beings in a spacecraft that is set up. It is capable of taking them around the moon. So I guess we'll let the animation slide.
I still cannot believe that this thing launched on the first launch attempt.
Within like 10, 11 minutes of the beginning of the window? That's a
Yeah,
little
right?
nuts. It's like the universe
Especially compare
aligning.
after Artemis 1. Do you remember how many attempts we went through with that?
I try to forget.
I'm sure Jared will be super happy because he's been talking about, keeping competencies. I don't even remember the whole, spiel.
Can I just say, in his interview with us, Jared Isaacman said he was going to be accelerating the schedule, that we should expect to see the next core stage in the next 3.5 weeks. By accelerating the schedule, he has turned God knows how many launch attempts for Artemis 1 into 10 minutes into the first attempt.
Power back in auto.
Copy C3 Aux, and we're 2 minutes to maneuver.
Folks, there's all sorts of shots. All of our photographers, videographers that are out there at the Cape are currently taking the shots off their cards, the SD cards, and sending them to us. So in a little bit here, we'll have an awful lot of, can I say freaking fantastic? I can say that, right?
You can.
You could say that.
All right, we're going to have a lot of freaking fantastic shots to show y'all in just a few minutes. Still listening in to the capsule, but the capsule's coasting right now, isn't it?
Beautiful, beautiful. One thing I will also say, I will be honest, I didn't really understand the daylight launch hype before the launch. Now I've seen the photos, I apologize, and I 100% understand the daylight launch hype. The evening lighting, the, cloudy but pretty blue skies in Florida, absolutely spectacular.
Especially with the SRBs. I mean, the pillar of smoke that goes behind the SRBs, you know that thing launched. Like, if you didn't, you probably heard. I bet you everybody heard it.
I bet they
but
felt
you look,
it.
Yeah. And it just, it lingers. They sort of drift, and you can see the winds blowing them, but the SRBs don't play around.
I see Sawyer's
the
getting
only
back
one?
on comms. I was going to say, we should ask him how did he feel it? Sawyer, are you back on comms yet?
Probably pushed him backwards
I'm
a little
something.
bit.
I'm here or something.
Okay, you got to share with us. How did it feel on the ground?
That was unreal. The volume, it just keeps getting louder and louder. Like, you think it's going to stop, but it doesn't. and then you get the reverberation off of all of the buildings, all of the huts, all of the cars, everything in the area. So as soon as it hits you from the front, it bounces off the buildings and hits you from behind. So you are getting bombarded in all directions with sound. This is one that you see, that you hear, and that you feel. This is one of those punchy ones where you feel the vibration, and it unlike Shuttle where it goes for maybe 10 or 15 seconds of the punchy stuff, we're talking like 25, 30 seconds of the real punch. And then of course the sound keeps going, and I had to stop at one point and just look up. There was this tiny little dot that was going by, and I was talking with somebody next to me, and it's like there are people in that little dot. As just watching it go by had people going to the moon. I may or may not have had to wipe tears from my eyes. I'll never forget that for the rest of my life. I can tell you that.
Oh,
I don't think you were alone, Sawyer. Yeah.
No, I think we were all teary, and we weren't even the ones there feeling it. I remember the first time seeing my first orbital human launch. Oh my gosh, the feeling that moment when you realise there's humans on that spaceship, it's overwhelming. So the fact that we're sending humans back to the moon for the first time since 1972, wow, what an incredible thing we've just been privileged enough to be able to
Sawyer,
witness.
I'm gonna ask you a thing that you're probably very familiar.
Uh-huh.
Did you hear the VAV squeal?
You couldn't hear anything if you wanted to hear anything. It may have squealed, but it is so unbelievably loud that there was no chance in heck that I could hear specifically a VAV squeal. All you heard was...
Yeah, I don't know if it... You know, I'm asking these because I don't know if it's like it was on our audio. I was also trying to listen into the NASA update, so it might have been a bit of a mix here by audio. But you know, when this launched and I started hearing the rumble in our feed, I could also hear one thing, the people cheering, and that was exciting me. It was like that is cool because people are seeing other people heading out to the moon and cheering and yelling, and I was like, that's our VAV squeal. It's the people squeal.
The moment that it got to like 30, you could hear someone shout 1 minute, and then it got quiet. And then you get 30 seconds, and it was still pretty quiet. Then at 10, you heard there was a group by the countdown clock that was counting loud. You couldn't miss
And
it.
Integrity Houston, cross tie is on board per the ETSI-DEM.
We copy Houston. Thank you.
So, I mean, you heard the countdown. It echoed, it reverberated, and the cheer that erupted when it lifted off. Of course, I'm hearing camera clicks, but you couldn't miss it. And then, of course, very shortly after the cheers, you hear the low rumble. Like, okay, it's coming. But then as soon as that rumble picks up, it gets so unbelievably loud. And this was the same that I had at Artemis 1. It's the same thing here. You go, oh, it got to the level of Shuttle. I don't know how it can get any louder. And it does. Somehow it does.
Just over 18 minutes since Artemis 2 SLS has pushed 4 human beings out into space. The beginning of their journey, not the end of their journey, the beginning of their journey, because they still have a very long road to go all the way around the moon.
Any
Now,
words on that momentary prop caution?
I'll listen in.
And read no action, we're looking at it.
Yeah, now they are maneuvering for the attitude for solar array deployment, because they need to point those solar arrays once they deploy and point them to the sun, obviously, to recharge batteries and keep Orion powered.
I think here we're waiting for it to come out from behind the shadow of the Earth so we can see something in the rendering.
Yeah.
I'm still wowed by all these images that are coming into the chat behind screens. I cannot wait to be able to share them with the audience right now because they are blowing my mind. The team on the ground have done an amazing job.
Yeah, absolutely.
Because Philip actually... Philip corrected me that they are right now in the dark. That's true. But they are orienting right now the stack. They're using the RCS thrusters on the ICPS on the upper stage. They're still both connected, and there's still 2 more burns from that upper stage to perform. But yeah. There's the very useful timeline from our producers.
So, Alex, I mean, they were launching towards the east and over on this side of the Atlantic.
Yeah, Integrity Houston, update on TDRS handover for your pad.
Ooh, TDRS handover. That means they're going to the Deep Space Network.
Give us just
No, they're
1
changing
minute.
satellites, I think.
Ah.
Yeah, probably.
Dan, you can read it like it's ready to copy.
Roger. TDRS handover east to west expected 1 second earlier at 5:1 minutes 26 seconds.
There we go.
All right, Stan, we copy 1 second earlier for 5126 TDRS east to west, and saws are starting to deploy. Thermal knives are firing.
We concur. Thanks for the report.
Is that a little glow in the animation there?
It looks
I
like
think
it, doesn't it?
I think NASA's animation has got a little bit confused here because it thinks they're in the perigee
Yeah.
raise burn, which is not scheduled
Yeah.
until T plus 49 minutes into flight. We should have just got the Orion solar array deploy. I wonder if somebody has accidentally advanced the animation 2 stops forward when it should have just been 1 stop. NASA TV, you might want to pump that one back just a little bit.
Have a look. Like,
Yeah.
turn the engine back off. And again, that's just the animation there. The call-outs that are coming down for the vehicle are the important things.
Yep. And that call out was very important because, you know, what I told to Al is that there's multiple TDRS satellites, right? The telemetry data relay satellite system, or tracking
Yep.
and data relay satellite system, right? And there are multiple of these, and they are right now orbiting around the Earth, and so they're moving to the east. And there's going to be a point where they're no longer going to be in view of one of the satellites, but there's going to be another one to pick it up, right? And so they need to do that handover between satellites. And so that one, I think they said 51 minutes into the mission, if I'm not mistaken. And that one is very important because the perigee raise maneuver is at 49 minutes 50 seconds at least per the latest.
And Integrity, for
numbers.
prop messages, we see 2 temperature measurements right near the line. It's that momentary message you saw earlier. We're going to suppress those. It's CM helium heater 2 T1 and heater 1 T1. They're going suppressed.
All right.
Integrity, thank you. We see the same.
But yeah, that handover could happen during that next burn, the perigee race maneuver burn. So it's very important for them to know that sort of stuff, you know?
Yeah. Just going to keep listening in here as they get more call-outs. It sounded like there were 2 readings that were near the line, but they said they're just going to suppress those, which basically means like hitting snooze on your alarm. Something was sort of near an alarm, and if they suppress it, they're not too terribly concerned about it right now. We'll see if we get more call-outs on that. But again, the thousands of sensors that are watching all of the different things. You heard a discussion there of a temporary prop alarm, be propellant, it sounded like, but it was just temporary. And then we heard the discussion about the 2 readings that were near the line and the decision to suppress those, which is basically just turn off the alarm. Of course, they'll continue watching them, but
I was just going to say, before we get the images come up, guys,
Houston
there are
Integrity,
some
we
on
are happy to
Twitter.
report that Jeremy has the O2 sensors on.
Copy O2 sensors.
I shouldn't really call it that. X. So if you want to go and check out some of the images that were taken by the team before we get them up on screen, go check out the social media pages of NSF. They are being shared right now and they are incredible. And of course, you can purchase the images from the team as well.
Integrity Houston, we see 4 saws deployed and latched, ready for ATO preferred.
There we go.
Yeah, we're
Those are
almost
the
there
solar
in the
panels.
procedure stand, and we see the same thing.
Yeah, again, NASA acronyms,
Question
right?
mark.
They call them
Yeah.
SAWs,
And Attorney
solar array
Houston,
wing.
we are seeing a 7-second miscompare between the MET on Orion and ICPS. We'd like you to read us the MET from your center status bar and for the ICPS on StackSum.
The reason why
Interesting.
I chuckled at that, it's because it
And we see
reminded me of the Starliner
absolutely
OFT1
precise
issue.
alignment. MET
where
25, 14, 15, 16, precisely aligned with ICPS MET.
Copy. Thank you for that. We'll investigate a ground issue.
And Houston integrity, ATO preferred set.
Copy. ATO preferred.
Was that ATO, Alex?
Yeah.
Did I hear that correctly?
Yeah. Sorry, sometimes I don't know which one is talking right now. Because I have two different feeds right now that I'm listening to, and there's a third feed as well, so excuse me if I talk over them. It's not on purpose. And
Okay.
yeah, what I was trying to say is that I chuckle a little. It's only 7 seconds, so I'm sure they can troubleshoot that. There's plenty of time, but you know,
It's not like
Starliner's
18 hours or anything.
exactly. Starliner's orbital flight test 1 back in December 2019. They had like an 11-hour delay between what the rocket mission elapsed time was and the Starliner mission elapsed time. That was way worse, of course. This is only 7 seconds, so I don't think it's a big issue, to be fair, but it reminded me of that. Good news, though. The solar arrays are deployed and latched, so that's good. And there's still, 20 more minutes until the perigee race maneuver? Yeah.
Yeah, we're expecting that at plus 49 minutes, correct?
Yeah. Oh boy. Less BPMs, but still quite a lot to go in this mission.
I'm really curious if I've brought up the Artemis website, right? That live animation you can see, and I really wonder if it's going to burst into daylight when it comes out from behind the planet.
I wonder if they didn't, like the code behind the animation didn't consider for going back to a previous event, because they did reset back to solar array wings open, which triggered the solar array animation, but the engine is still burning in the animation, and it definitely isn't burning right now in real life.
I don't think it's supposed to be doing. That's just that's an animation problem. That's not the engine's actually burning.
NASA, if you want any help, I think Ryan is just now volunteering to help you.
I'll do you a thing in KSP. It'll look great.
Yeah, just throttle down the engine so it stops. But that is the spacecraft as it will go all the way around the moon, isn't it?
Well, not the entire spacecraft. The ICPS will return to Earth. It will be the Orion service module, the European service module, I should say, being a European. That is what will conduct the translunar ejection burn, and then that spacecraft will go around the moon. But this spacecraft, at least, is going to be in a highly elliptical Earth orbit, which is, still going to be pretty spectacular. And when they separate, we're going to have those proximity operations. The crew is essentially going to pretend the upper stage is a lander and pretend to dock to it, essentially, and operate around it, testing Orion's controls. And that'll be Reed Wiseman and Victor Glover are going to swap seats, and it'll be Victor Glover, I believe, at the controls of Orion.
Integrity for GNC, we're taking channel 1 to unfiltered and to BFS.
Okay, Stan, we're watching. Go ahead.
Sorry, I was listening into another update as well. Yeah, I was gonna say, speaking of KSPs, we were talking about the animation. Provided that those numbers on the lower right are correct, right? One of the things that people might be wondering, if you're very new, because this mission is historic, right? So you might not know what is going on. Why is it that, for example, the speed, the velocity is going down while the distance from Earth is going up and things like that? That's just orbital mechanics, right? Same deal that when you throw up something into the air, you throw a ball or something like that, whatever kind of favorite sport that you like that uses balls, baseball or something like that. I don't know. Whatever you might use,
Ball
right?
arc.
When
That's
it is
fine.
right there at the top of its arc, it usually does this sort of arch trajectory, right? Right at the top of that arch, it's basically at the minimum sort of that speed, and then it comes back down and it picks up speed. The same deal happens with Orion and ICPS. This spacecraft, right? It doesn't change just because it went up in a rocket. Gravity works the same, right? So the further out that you go, the slower you go. And so it's losing speed, it's trading that for altitude, and so it's going to go up. The orbit, as Ryan was saying, it goes up to 2,222 kilometers. In miles, the burn for the perigee race maneuver, if I'm not mistaken, should be, let me look, because I had it in kilometers, and miles should be, oh my goodness, I had the the number here. It
It's all
was
good.
1,200,
Alex.
I think. But yeah.
Yeah. Like what's going on is we had a bunch of energy in the rocket, but the
Exactly.
energy was stored in the form of fuel, right? It was chemical energy. It was stored in the hydrogen, it's stored in the SRBs, the chemicals that make up the SRBs. And what we did is we released all of that energy. We turned that chemical, the potential energy that was stored in the rocket's fuel, we turned it into kinetic energy, right? And we accelerated that rocket. We accelerated all the pieces of it. Then we started dropping pieces. The SRBs were out of fuel, so we got rid of them. Don't carry them anymore. The core stage burned and converted all that chemical energy into kinetic energy, pushing the rocket faster and faster. And then when it was done, it dropped away. And we ended up with the top part of the rocket that has the crew in it. But we took all of that fuel energy and turned it into motion energy, right? Potential versus kinetic. And now what's happening? It's converting back a little bit. The higher it goes, it's taking that kinetic energy we dumped into that vehicle and it's turning back into potential energy. Here, not in the form of chemicals, right? But in the form of altitude, in the form of sort of gravitationally stored energy. The rocket's not gaining or losing energy right now. It's just trading height for speed. And the higher it goes in that elliptical orbit, the more energy is traded into altitude instead of speed. And Alex, like you were saying, if nothing happened, if they didn't do anything, when it got to the top, it would reach the highest point in its trajectory and it would start to come back down to the Earth again, right? Towards the Earth. And there, the equation would flip. It would start trading that potential energy that it's stored in the form of altitude, height above the planet. It would convert that back into kinetic energy, the energy of speed. Right? But while it's in space, unless you turn on an engine or dip into the atmosphere, the orbit has a fixed amount of energy and it's just constantly trading the energy back and forth between speed and altitude. It's going to be doing that the entire time as it goes around the moon. The only time it changes is when they turn on engines of some sort and they take more of that stored energy, the chemical energy, and they put it into the rocket as motion. So that's what we're talking about right there.
That may be in chat and they know everything, right? They know all of this. Look at the historic mission, right? Like we're explaining this because you may see the numbers and you may not know. And so now you know that it's completely normal for that to happen.
Good deal. I think now we have got some of the photos from the crew that we can show. We'll leave the animation to do its thing.
Oh, look, we've got a couple on there.
Let's see here. Do we have information in order whose shot each thing is?
I see that bottom one on the right is coming in from Wade.
Oh, yeah.
This one's Julia's. Great image from Titusville.
Yeah, with the crowd in the front there. Thank you. Did people step into the road, it looked like? Is that what I was seeing there?
There's Sawyer's one that's come in. Man of many tricks, who's able to commentate, run over, take a picture, come back to commentate. Sorry, you're amazing.
Thank you. Here's another one.
And this is another of his. Yeah.
That's a cool one.
The amount of detail, because you said it, Alex, that you didn't or was you or Ryan who said you didn't understand the daylight hype until you saw it. This was the daylight hype.
I believe this is Jerry's picture we're seeing right now.
Yeah. Sawyer, I have a question for you. I don't know if you can answer this. Maybe you were...
By the way, this one...
This is the shot. This is the shot.
This Max Evans cooked.
Yes,
of course.
I did say to Max, I was like, I want a signed copy of this one. I don't just want a copy, I want it signed because, oh my goodness, what an amazing shot. And then Gage put this one as well of all the crowds watching. I think
is
it's great.
Gage in a Gage picture?
In frame?
Yeah.
How did he do that? Gage is in the picture watching. There's like an NSF flag on one side and then Gage on the other side and then the plume of the rocket in the background. What witchcraft
one more
is
that I'm
this?
exporting right now. Sorry, Kevin. I'm sending you more stuff even.
More and more coming in. I love it.
Oh, we've got some more of these here.
Enter Houston updated PRM numbers when you're ready to copy.
Ooh, that's important.
All right, Houston, we are ready to copy.
TIG is 2 seconds earlier at 4 minutes, 4:08 seconds. TIGO unchanged at 2:06 seconds.
49:48, TIGO 26.
I think they're jotting these down.
I am.
Like, are they making notes? You're jotting them down.
At the very least.
Aboard the spacecraft.
Either Fisher Space Pens or on the tablets, which they have their iPhones with them. This is the first NASA mission that wasn't on Crew Dragon that has iPhones.
They have to keep them in airplane mode? Or space plane mode?
Space
or
mode. Well,
whatever. Space mode?
Sorry, space or cell phones. They didn't say what brand, even though a certain someone slipped and said that it absolutely was Apple iPhones.
Oh, jeez.
Can I just point something out with this particular photo, which is now available as a print at shop.nasaspaceflight.com? This is from Max. This is incredible. Max has done many of these flag shots before with a Falcon 9 rising in the background. The difference with this, except from the fact that it's SLS and it's like 39,000 kilonewtons of thrust and, you know, stupendous numbers, you can see the plume through the flag in daylight. That is how bright the exhaust of this rocket is. You can see it through a flag in daylight. And the sun is shining on that flag, you can see. That's just incredible.
I got to get to that. I got to bring that up in the shop so I can see it. Oh,
yeah, it also helps that it's right at sunset. And again, because the sun is setting in the west here and we're looking to the east, you get the lighting directly on the rocket. That also illuminates the flag.
Houston, for Optimus on the PCD, we have time update instructions when you're ready.
They got to jot down some more space notes real quick.
Space notes.
While they're doing that, can we just mention they've gone beyond that 1,000-mile mark? Isn't that further than anyone's gone since Apollo 17?
We copy. Hands are pretty busy at this time. I think we will call you back when we're ready for that.
All right, that one is not urgent. 2 minutes to maneuver to PRM attitude.
We are watching and concurred. 90 seconds-ish, maybe.
More photos here. I will just say that that is correct. We are now beyond 1,800 kilometers, which means a few minutes ago we crossed the threshold set by Polaris Dawn. Artemis 2 has officially set the record for the furthest a toilet has ever been from planet Earth.
Yay! But yeah,
a proper toilet.
Yeah, not bags. This is a 30-second streak shot, by the way. Sometimes we call these lightsabers, but it's probably a little too wide to be considered one of those. But you, of course, get the streak. But the SRBs, boy, are they dirty, and you see it with that kind of plume coming off the side there.
Is that the motion of the... Because I see that the streak is sort of on one side, right?
Yep.
Is that because the plume is drifting in the wind, or is that because of the pitch maneuver that's occurring?
I mean, the wind is pretty strong, so I wouldn't be surprised if part of it was that. Well, not strong, but was pushing the plume. It could be that.
Sure.
I'm sure part of it is also the rotation of it. But yeah, it's the cool separation on this one. You don't get to see that often.
No kidding. That's a cool idea. Who would have thought to do a streak shot of an SRB during the day?
Houston, MCC polls go for PRM, pending attitude and saws.
There we go.
Translate, Alex.
Hey, we copy. MCCs
Waiting.
go.
Hang on.
Yeah.
Maneuver starting.
So I heard an attitude change, which means the spacecraft will basically turn around, right?
The visualization
Rotate, maybe?
person. Anyways, yeah, so they're now rotating to the correct attitude for the perigee race maneuver. So basically, right now, their lowest point in their orbit is just 27 kilometers. And if you do a little math, that's inside the atmosphere, right? So they're going to be doing a very short burn, just 2 minutes and 6 seconds long, of that RL-10 engine on the ICPS on that upper stage, in order to be able to bring that up to about 185 kilometers in altitude. So it's going to be very subtle, very short burn to bring back up that lowest point in the orbit. And it's totally on purpose. Like, it's not that something malfunction or anything. That is done on purpose, because before any of this, there was a huge core stage, that orange thing that was behind that that upper stage and the Orion spacecraft. And that one, if they did not do this, will just be basically just space junk in orbit, right? So you need to put that in a certain orbit such that the lowest point is within the atmosphere and be able to dispose of that core stage in a very clean way. Basically not putting it in orbit, unlike the Chinese. Anyways.
Nice.
Yeah, Long March 5B, we know. Oh, and that's right. Yeah, the solar array wings will also tilt. They might have actually already tilt.
I believe they are tilted. It's so difficult to see from this animation.
Yeah.
I believe they are
to...
pointing forwards.
Yeah. They are in motion now, apparently. It's what I'm hearing from their updates. And so that's very important, because they do that so that during the burn, there's loads, right? There's a force going through the spacecraft, and also the inertia of the wings themselves and everything of those solar array wings, and so it's very important to keep them in a certain position. Also, the expansion of the plume of the RL-10, it's in near perfect vacuum, basically, up there in space. And so that
sort of goes in all directions, right?
Exactly.
Even though you have a nozzle to push most of it backwards away from the rocket, it wants to go in all directions, so you sort of minimize the impact, right?
Yep, that is correct. So they're tilted forward. Should be about 7 minutes to go for that perigee race maneuver.
Looking at Johnson here, aren't we?
Yep.
Squinting
Mission
down,
Control,
but
Houston.
that wall of patches. Yeah. Go ahead.
Yeah. Control, booster. Looking at all the different, because they have their own sort of little panels there indicating, or plaques, I guess, indicating which position is which.
We've got a flyover camera with a screen behind them. Is that a screen, or is that actually in the open over there?
Yeah, that's literally out there.
Yeah.
Okay, it looked like a screen for a second, but
I think it looks
NASA?
like a screen because they're in a tent and it makes everything else dark.
We have another person here from NSF under a tent out there in the field, an actual person.
Who? I don't know who you're talking about here. I want to meet
Right,
them.
Sawyer?
I want to meet them. Maybe they know some astronauts
Yeah.
or something.
Sawyer, they have a cooler tent than you do.
Yeah.
The tent looks more expensive than ours.
Yeah, there we go. That's better. Put the
That's
camera
what
lens
I do that stuff.
Focus
Push it
on
over
the
there.
camera. Focus on me. I'm kidding. But this is to hear these grown adults, act like little kids and see the giddiness in them is, I mean, it's so cool. That shared moment with everyone of, yeah, we just did that. We as humanity just did that. Oh, I can't. It's too exciting.
Sounds like there's some people in the background talking about how amazing it was.
That was Dr. Cyan Proctor, who we had earlier.
Oh, nice. Okay. She was hanging out next to y'all over there.
Integrity Houston, we see Orion in attitude and SAW in position for PRM.
We see the same on board. Looking good, Stan.
More good call outs here. Again, we're going to stay live for another 2 hours plus 2 hours and 15 minutes or more here. There's still a lot going on in the mission. We still have more shots. At some point, we're going to have some replays for you as well. But we're hanging out. Like, this is not the end of the show right now. So all the folks who have been here with us, we will continue to listen in to the updates. But also, if you've been supporting what we've done, apparently a lot of people like pins because the pins evaporated whenever we allowed them to be bought by the public. The members bought about half the pins we had produced. We didn't know how many to get. And the members made half of them disappear before the public could even touch them. And as soon as we let the public get them, in a matter of minutes, they were gone. The original set that we had ordered, that we had produced, were gone. So we made the decision. There's so many people who want to commemorate this, and there were so many people interested in the pins. We made the decision to open the orders back up, even though we had sold out of stock. We put it on the screen. It said it was a pre-order for the people who ordered once we were out of the initial stock. But we're going to go back to the pin company and we're going to get more pins made because we didn't want to tell people, hey, sorry, you weren't fast enough. You didn't get a commemorative SLS, Artemis 2, etc., pin. Now, we do still have plenty of patches. We're used to people liking the patches and buying lots of the Starship patches when we do those. So if you want to get a Artemis and Artemis 2 patch, those are still available. They're still in stock and shipping right now, but they are rapidly disappearing. I just want to say that real quick. If you went over to the shop, you did see the first pins that were ordered. If you ordered when it said that they were not pre-order, we do have those first pins in stock, and we'll get those out to you as soon as we can. But we didn't want to turn away some hundreds of people. So we swapped it back over. We're going to get back in touch with the company. We're going to get some more pins expedited so everybody who wanted a pin can have a pin. And for the patches are selling out, but we still have patches in stock because this thing went. It actually launched. And I imagine some folks will want to commemorate that by having a piece of memorabilia here from us. Now, if patches and pins aren't your thing, or maybe they are, a lot of these images we've been showing you, like the flag shot and the liftoff shots, we are working as fast as we can to put those into the shop. So you saw a couple of those. You saw the liftoff shot there as well. But that is another fantastic way to support what we do. On those, the photographer that took the shot actually gets part of that. You help them get some basically funding for cameras and stuff so they can extend their capabilities. So if you want to pick up one of those prints, we're still putting more and more prints in the shop. Some of them are up there already, and of course those are created on demand. Those are going to be in stock. You can get them whenever you want. Of course, we have all the other stuff, the t-shirts, the patches, the mugs and stuff like that you can grab as well. But the sun shirts. Did anyone even see the SLS sun shirt that's like the Sophie orange in the middle and then the arms are SRPs? I don't think that anybody really pointed out that that's what that sun shirt was. So In any event, we do appreciate y'all. I don't want to say it too much, but that is why we're able to bring you this coverage. That's why we're able to do what we do, because y'all keep showing up and you like having cool stuff to put on your walls. You want like a assembly, like how to put together SLS. Well, now we're going to have to make one of these that's like how SLS disassembles itself while it launches. Like the parts come off of it as it sends the astronauts on their way around the moon. What's up, Alex? We're
Seems
missing
like the raise burn has occurred, I believe, is what Alex was trying to say.
Correct.
Burn seems to have been completed. That's what we like to hear.
Right. Chat, can y'all hear Alex right now? I think what's going on is like everybody has glommed onto the internet and is doing a bunch of uploading. So if y'all can hear Alex, let us know. If you didn't hear Alex and you heard Sawyer repeat what Alex
if you
had
can
said.
relay that the
Do we have Alex back now?
PRG raise maneuver is done.
Okay, now, starting now, did y'all hear Alex? And now people are saying, now it's back and forth because there's like some cross in people's delay. So I think we've got some people saying Alex is back.
Milan, no, we will not let you go.
man.
Let him go.
Okay. Alex, you're allowed to talk again.
But yeah, PRG race maneuver is done.
That's what all the hoopla was
All
about.
of that, just for that. All of that for that.
We needed Alex to say that.
I'm listening. I'm still listening into updates.
Oh.
Yeah, sometimes I stop because I'm still listening to updates, so I'm sorry. But yeah, PRG race maneuver complete.
Of course, that's not the only burn that they're going to be doing. The next burn is the apogee raise maneuver, the other side of the orbit, and that will be happening in just under 1 hour's time. And that will push Orion and the ICPS into the super elliptical orbit. That's not a real term, but I just made that up. But that'll be a 70,000 by 0 kilometer orbit, which is incredibly elliptical. And after that, they will separate from the ICPS and do their proximity operations.
Now, we're saying what that is, but what does that actually mean? I mean, raising the perigee is an important thing here, isn't it?
Mm-hmm. Yep, so to try and explain it in the simplest terms possible, an orbit is essentially a loop around a planetary body, or a loop around a thing. So the orbit around the Earth is their loop around Earth. And, you know, the orbits, no matter how hard you try, they're very rarely perfectly circular. They're going to be an elliptical shape, and you're going to have a part that's closer to Earth and a part that's further away from Earth. The side of the orbit, the point of the orbit which is closest to Earth, that's called the periapsis. For Earth, it's perigee. For the Loon, it's periloon, and for the Sun, it's perihelion. There are many different suffixes you can add to that word, but the lowest point is the periapsis. The highest point is the apoapsis, and when we talk about the Earth, we say perigee and apogee because G is the moon. Someone in language decided hundreds of years ago. So that's what we're referring to, the lowest part of the orbit and the highest part of the orbit. Before the perigee raise maneuver, the lowest part of the orbit was within the atmosphere, which meant that if they didn't do that, Orion would re-enter this orbit. But now they've raised the perigee so that the Orion spacecraft will not re-enter on this orbit. When they raise the apogee, that will send the highest part of the orbit even further into space than it is already. Right now, it's over 2,200 kilometers. They're going to raise that to 70,000 kilometers. So that is, 35 times further away from the planet than they were before, at their highest point. Looks like we're getting a live view from inside the Mission Control Center in Johnson in Houston, because, of course, at the point of liftoff, control is handed over from the Launch Control Center in Kennedy to Mission Control in Houston, as has been done many times throughout the Shuttle and Apollo era. I always love it when they go through the launch and it's like, Houston now controlling. Sounds so cool.
I like all
Yeah.
the little numbers and everything on those screens because there's things, for example, eclipse start. That is when the next.
Integrity Houston on TDRS West. White
When the next.
Sorry, I was-
receiving data.
Don't leave us hanging.
Houston is not troubleshooting.
Sorry, more updates.
You can listen. I don't know if anybody else, but I was following on with the NASA real time mission website, and it seems like it's crashed. Like I'm not
That
getting.
was Capcom Stan Lowe, SN team here in Mission Control Houston. We changed over to point to one of the tracking and data relay satellites at the expected time.
That's the handover we talked about earlier. But yeah. I was looking at all of the little numbers and everything, and like, for example, there's a countdown there to the apogee race burn, the mission elapsed time, and also the map. You can see that the perigee race burn that we were talking about earlier, that one happened over the Indian Ocean east of Madagascar. It's a place that if you followed Starship might be very familiar to you.
I will just say, instead of the animation, I do wish NASA could also just show us the map. That would be nice.
Yes, please.
But, we'll make do with having to...
all of that.
Yes, exactly. I guess for now, we'll make do with squinting at the mission control camera, but it would be nice to see the map, alongside the animation, so we can have both.
It's like we're getting our live telemetry updates by squinting down to 2010 and reading the mission control screens.
Yeah, exactly. We've got some wonderful patches on the wall, though, if you look in the top left.
Yeah, the mission logos, the mission designs, emblems, whatever. They're patches, but they're big like printouts on the wall.
Yeah.
Hey guys, you want some insight here from the field team? I got someone with me.
Sure.
Yes.
I mean, go ahead, I guess.
Yeah, go for it.
Hi, DOS. Hello, everybody. Happy post-launch. Happy Artemis 2 launch.
It's
oh my
maxed.
goodness.
How you
Hello,
doing, dude?
DOS. Oh, dude. I'm still pinching myself. Like, you could not ask for better conditions to launch a rocket in from Florida.
Yeah.
Like, that was a treat beyond anything. Like, dude, for opening of the window, first attempt, and they're off to the moon. Well, not yet.
Yeah. Well,
not yet.
They're in the orbit that, if all goes well, will eventually let them go to the moon.
Correct.
Or about to be.
Yes,
Yeah.
they're about to be.
That was.
I don't know. This is like you've sort of left your driveway, but you're still in your neighborhood, and you're not on the freeway yet, right? You're not like going to Dallas or whatever.
DOS,
You're still in
I
your
swear.
neighborhood, but soon you'll be on the freeway to Dallas.
I swear to God, DOS.
They're still
My
circling
gosh,
the block right now.
Oh my God.
It's a good analogy.
It is a good analogy. Yes.
Yeah.
And,
Chat,
and they'll
back
be
me
there
up. That's a
until
good
about T plus, what is it, 1 day and...
About a day and a half.
A day and a half? Okay.
Ish, yeah. I know someone has the actual timeline up. We're kind of still just
Yeah.
recovering.
Dude. Yeah, and I had to go pick up cameras at the pad.
Oh my gosh.
At 8:30.
No kidding.
Some of them, right?
Some of them, yeah. We're picking up outside the gates first, and then we're going inside the pad tomorrow.
Oh, you hear that?
So-
You hear the pictures that are going to be coming?
Yeah.
Wow.
Hey, do you have to handle your camera with gloves because of the SRBs, or is that just an Atlas thing?
Well, it's an Atlas thing a lot because of just the proximity your cameras are in
Close.
towards the flame trench. I don't think that's going to be an issue at 39B. I think we're going to be far enough away.
Probably you're just far enough away that you don't get the spicy residue that makes your fingers tingle when you pick up the cameras.
Fingles.
Yes, your fingers tinger. Exactly.
It's a thing.
It's true, though. For those who don't know, the SRVs, especially the GEM 63s and 63XLs, which they use over at Vulcan and Atlas, they are very, again, they will make your fingers tingle if you touch them because they're so caustic. But you have to rinse your tripods afterwards, or else it will continue to linger.
Correct.
So hopefully we don't have that here. Again, I never got to set remotes during shuttle, so I couldn't answer on that one. but
I think it was dependent on like wind direction and how close your cameras were to the pad, but they weren't that close
Right.
to be in danger. I don't think, but I could be wrong. We'll find out tomorrow.
Yeah, exactly. Speaking of direction,
One
that
way to find
lighting
out.
direction, Max, was. We were just talking about that right before. We're like, hey, let's both hop on. That lighting was beyond perfect.
That reminded me of Starship Flight 6, which was the first afternoon window, and New Glenn Flight 2.
Yes. Although this was even better, I think, than New Glenn 2. The sun was a little bit lower, which just...
Without a doubt.
Yeah.
And no atmospheric distortion whatsoever. It was wonderful.
Yeah, yesterday I was taking photos beforehand, and I'm like, oh, God, the heat haze is terrible on this. And then today I'm looking at the photos like, oh, my gosh, you can read the logos on it.
I saw some of Dee's slow-mo footage from the rig, and I don't know if we've shown it yet or not. I've been so busy trying to get photos done.
We're working on it.
Yeah, it's friggin' I'm trying not to use a bad word there. It's friggin' spectacular.
Yeah, we try and stay family friendly here, but my gosh, it is hard when you get something that exciting happening. And I mean, you've seen hundreds of launches at least here?
I'm over 300 now.
Yeah. How does I want to know how that compares.
On the spot, like right after it happened, golly.
That's the perfect time to ask. I'm sure you'll reflect later on, but while it's still fresh.
Top 10 for sure.
Nice.
Although it almost went too perfect in the fact that, like, oh my God, it went at the opening of the window on the first try. It's like, that's not supposed to happen.
No, within 10 or 15 minutes of the window, try one. All the naysayers, all the Ryan Webbers out there who are saying it wouldn't go on the first try.
Yeah. Hey, folks, there's a little bit of breaking information here that we need to pass along. We were doing a little bit of a handover there, but Alex, can you fill us in on the comms hiccup that's happening right now?
Yeah, they're getting some downlink they're getting data obviously from the spacecraft, but they're having a comms issue, a communications issue with the crew, where they cannot get downlink communications. They're sort of communicating with the crew in the blind, as they call it. They think it is a ground issue with the hardware. They did that handover, right, that we were talking about earlier to the other satellite. And so, yeah, they sort of were not able to lock in with that comms network. But yeah, they're restarting the hardware, probably the usual. See, they have video. Look at that.
Oh.
See?
Look at that.
So they have data, they have video, of course. But yeah, it's just communication side of things, like, talky talk, basically. So they think that the crew can hear them, right? When they sort of give them different call outs and things like that. They usually say in the blind.
Yep.
But yeah.
So when you say in the blind, that means that like the ground is sending messages to the spacecraft, but they're just not getting their response back from the spacecraft. They're getting other telemetry. They're just not getting the voice comms, right?
They regain
Where do
comms.
we go, Alex?
There we go.
Okay.
Yeah, they have now communications.
All right, we are still trying to understand whether the automated swap to S-band string 2 recovered comm for us or what was going on the ground. We gave you calls about an ARB TIG and an Oxone inlet filter. Did you copy them?
Copied all.
There we go. Yeah, they had two different callouts to the crew in the blind, as they called them, sort of expecting them to receive them, but not getting an okay from the crew back, right? Because they had that comms issue, but they thought, again, that the crew will be hearing the ground, but the ground will not be able to hear the crew. So they send those call-outs to them, and the crew reports that, yes, they heard those, and they copy. And so, yeah, a little hiccup, but hey, it happens.
Gotcha. All right. So sounds like that was solved. It sounded like they literally turned it off and turned it on again, and it came back. But I believe we have yet another member of our team. Somebody you haven't heard from yet on the show today. Chris Bergen. Do we have Chris on comms right now?
I am. So that happened, didn't it? I told you,
so
Alex,
that
didn't
happened.
it? Alex, I was telling our team that they're all going,
Yeah,
Chris,
yeah.
I don't think this is going to launch first time. I'm going, Everybody, just calm down a second and listen to my experience with Space Shuttle. Never a scrub. Always launches without issue time. Just trust the process. It'll launch first time. And they'll go, Chris, I'm not too sure. I'll go, you'll see. And I was right.
Right,
No,
Chris, right.
You know what? I'll be honest, chat. No, I've got to be honest with chat. Chat, I was saying there is no chance this is launching first time because it's a crew launch. It's a very important launch. Anything even slightly wrong, they're not going to take any chances, as they didn't. The fact that it all went so smoothly is absolutely baffling. Everything went really well. Even the issues in the countdown were minor. There was no sign of any tankage leakage. The LH2 behaved itself, the seals behaved itself, and the TSMUs. And that's without a wet dress rehearsal. We're all saying, well, not all, but some of us, including myself, were saying once they rolled back out from the VAB for the launch attempt, I would have expected at least an integrity test, just to test the seals after a rollout 3 miles down a crawlaway. They didn't do it, didn't feel the need to do it. That's why they work for NASA. They know what they're doing. And look what's happened. We've had this amazing launch. It doesn't feel real to me still. It's weird. I've been doing all these clips on X and whatever. It doesn't feel real yet. Yeah, it's surreal. I'm not going to be the most articulate person in the world right now, but that was brilliant.
Did you expect that to be a thing? I mean, the count seems smooth. There were a couple little issues, but they worked right through the issues and they just went. Was that super surprising to you?
Very. I've how many have I watched? I've lost track. I can't tell you exactly how many shuttle launches I've watched, but I mean, if I'm going back to just watching as a fan, literally, I've watched tens and tens and tens of shuttle launches. I've seen many scrubs. STS-93, everyone goes on about the Yank-Schubert concur. STS-93 had a scrub where they aborted at T-minus 7 seconds. There's things like that happen quite a lot with the Space Shuttle program. There's many missions where they took 5 attempts to launch, and this is a vehicle they've got a lot of experience with. So again, the second flight of a brand new vehicle with that hardware, that does not equate to me as a first time launch. It could not compute in my head. This would be launching first time. So all praise to the teams. They've found an issue during the wet dress rehearsal. They've fixed it. They're taking it back out, and the 101 other things that could have gone wrong didn't go wrong. It's incredible, really.
101. It's like 1,001 with rockets sometimes, but seems like they've got it. They had it sort of dialed in. Everything that popped up, they worked right through it. We heard about the battery issue. We heard about the range issue. We heard about the fuel pressure issues after launch. We had that prop call out. But they just come up to a hiccup and they address it and they decide if they can go forward. And today, every single thing, they were able to proceed, huh?
They did.
I also noted that the Launch Control Center had a much calmer call-outs. It's kind of strange to say, but there's many a time I've heard, like STS-93, hold, give hold. It was kind of like you could feel the stress in their voices, and they were talking through the issues, and you could hear the stress. It was all professional, but still some stress in their voices. When they were working through that issue before they went to the go for terminal count, it was all nice and calm. It was like, yeah, this seems like we got good comms now. Are we go for launch now? NTD, yes, we'll go for launch now. Yeah, it was a lot calmer, and that's professionalism again. But also, it gives you a lot of confidence that whatever they were working through was not a big showstopper. It was just something they wanted to clear before they gave Charlie Blackwell Thompson the NTD poll, which was the poll before the actual go for launch, for her to give the actual permission to come out of the terminal count.
It almost sounded to me sometimes like I don't want to say surprised, but that's the best word I have. Like whoever was saying the thing was like, all right, well, I guess we're going. Like everything was just getting worked out. And it wasn't like there were no ums or ahs or, well, I don't know, we're going to have to discuss that and we'll come. There wasn't any of that sort of hesitation. They understood what was happening. And if they didn't, they got the data and they looked through it and they made a call and they kept going. There wasn't a lot of wishy-washiness, was there?
No, it just felt spot on. And that's part of the surrealism of this all, is that it went so smoothly. Because if they wanted to do like a CGI version of this launch, that's how it would have been. If they wanted to basically do like a movie where they could make it up as they go along and just say, this is what we think is a perfect launch, they could have done it like this. There was none of the unsuspecting things that you normally get with this kind of launch. Yeah, I'm just watching that
Chris,
as well.
we're rolling replays here.
Oh my gosh!
Wow.
Yeah.
So the camera. Yeah, this one. This one's
camera.
absolutely nuts.
With the sun.
Also, the moonrise as well, right?
Yeah, the moon is
On the top
rising.
left.
The moon's rising, yeah.
Oh my god! Look
Whoa,
at
right
that!
through the sun.
That's so close.
So this was actually one of the spots that you could have put remote cameras. I didn't this time. I thought it was not a good angle, but
Except
dude,
for the whole sun.
Yeah,
Ooh,
right.
from
Yeah,
the tower.
right.
Look
Oh,
at this.
yeah, oh yeah, it'll shake. Look at that! Look at that vibration! Oh my gosh!
The
rocket's
passing
flying
shot
by.
is
That's so cool.
This is, if you're new to the
Oh,
show,
this
this
is
is part where knock the camera down. This is the part where we all giggle like schoolgirls while we watch these replays over and over again. Feel free to join us.
I took a photo of it earlier. Hopefully we get to see it in one of the replays. I don't know if you noticed, but the slide wire basket's activated.
Yeah.
So there's
Oh, here's
shots
the-
of just the rocket going off with the
Dude.
slide wires sliding. Oh, this one.
And this is the benefit of
Photo
launching
cam.
in the daytime. You actually can expose for all these elements properly, and it looks
And-
absolutely insane.
Wait for the boom.
Oh,
Boom!
There.
Oh!
look at that.
And then there
They
goes
like
the
those
camera.
arrows.
And the camera died.
Whoa! You can see
Reno.
the sparklers.
That's so cool.
Are those cracks in the lens
Yeah,
now?
that looks like it.
Yeah.
That's awesome.
I
my
can
God.
give a bit of an L2 pimp here because we've got what's
Oh
called
my-
the QVIS videos, the collection of QVIS videos from the
Ah,
Space Shuttle program.
QVIS.
We've got like 5 of them.
Yeah.
They're like 2-hour long tapes of about 30 to
Oh, here we
40
go.
camera angles, engineering cameras. And
Watch
they're
by the
absolutely
top of the
amazing
rocket.
to see.
Yeah, the slide wire baskets came down. It was kind of funny.
Yeah, right near where the crew capsule is there.
It's one of our shots from the press site, right?
Yeah.
And
I do wonder. Hang on.
There they go.
Can we rewind
There they go.
there?
What do they do? They're
Did
going.
you notice?
we are going. And
And they're in
slide
the-
wire basket said
They're
it
in
too.
the little hole.
Did you notice that they came off at T0 at the same
Yes.
time as the
Yep.
umbilicals?
Yep.
I think that might have been planned.
Maybe.
Oh, to try and prevent them from getting
I
damaged?
mean, but also at T0, the bang of the solids lighting could have shaken them enough to set them loose.
Normally
I'll
it
have
takes
to
a good
ask if that's in-
smack against
Yeah.
it with your hand to set it running.
That, Chris, look at that replay.
Oh my gosh.
It looks like a shuttle launching.
Yeah.
I have to ask
The
Sawyer.
AB roof.
Sawyer, you
Yeah.
gave some great words earlier after the launch, and I really enjoyed it, what you were talking about. I have to ask you, how much more noise and vibration did you feel compared to a space shuttle launch? Because there is more power involved here.
Much more. I mean, you get the 4 RS-25s, the 5-segment boosters. You really felt the punch on this one. And like I was saying earlier, the big thing with this is you get the loudness of the SRBs and the rumble to begin with. Then with all of the buildings that are behind where we were, you had it bouncing off behind you and then hitting you in the back. So you're getting vibrations constantly from all angles all around you. It is a sensory overload in the best way possible. And like I mentioned, somehow it got to the shuttle level loudness and kept going.
Nice.
Can I say something controversial?
11. Probably.
Oh,
I wasn't overwhelmed by the noise.
really?
Mm-mm.
Mm.
Like,
Wow, there goes
I'm not
the
saying it was
Starship
quiet. I'm not saying it was quiet by any means, but I wasn't shaken the way I thought I might be. But also, that could have just been me drowning in my own focus, looking at my camera, making sure it didn't leave frame. So,
Yeah, I mean, I
Yeah.
had sweat rolling into my eyes tracking it, but I mean, I get it. Artemis 1, I think, was a little bit louder because of just how moist the air was.
Oh, yeah,
It was
100%.
so humid, so that
100%.
one packed more of the physical punch, but I still felt this was an auditory. I mean, especially when you compare it to other things that launch from the Cape. I can't compare it to Starship, but compared
Yeah.
to other things that launch from the Cape, it blows it out of the water.
and you know what? If we go back to another pad replay, there wasn't much of an overpressure.
No, you're
No,
right.
there wasn't an overpressure.
Like the shockwave that comes
Yeah.
from the pad,
Uh-huh.
what you're talking about?
Like the one we saw
Yeah.
on Artemis 1, right?
Yep,
'Cause you could
and
see-
and many missions with shuttle. There wasn't that big old shockwave.
The one that destroyed the elevators on Mobile Launcher for
Correct.
Flight 1.
Yep.
Max, same question then, because you can do that comparison with Starship versus SLS. I know the difference in distances involved here, but just a comparison because we were talking 33 liquid engines and we're talking 4 big, powerful RS-25s and 2 solids. But how would you compare the two?
Well, I've always said Starship, for some reason, crackles like big solid rocket boosters, like SLS, and I couldn't figure out if that was just me getting in my own head. Was I exaggerating? And that the first characteristic that came into my head when the sound of the solids hit the press site, it sounded and felt like Starship. It literally had the same amount of crackle, maybe a bit higher pitched here. Starship is very low pitched for what it is, but Starship, oh my gosh.
Yeah,
it's really at the risk of sounding like super cliche. Starship still takes the cake here, but that's not to say SLS is a slouch by any means necessary. Not. It's just not. It was. You still felt that just as much as you heard it today, though. That was remarkable, and I think I was listening to Jerry's audio before coming over here and hopping on with Sawyer, and the mic picked it up very well.
I'd say you could tell the different ages. You could tell who's the shuttle guy and who is the newer guy.
The newer guy.
Well,
the newer guy.
Newer space. I'm old, is what I'm saying. I'm very old. I was here for shuttle.
The newer guy, folks.
You're old. Good grief.
My name's Sawyer. I was credentialed for STS 135. Nah.
I wasn't. Actually, one thing that I did, I noticed that the plume looked very similar to the one from shuttle. And there's a photo of me with the shuttle launching, and I dad and sure. And you could see the plume rising behind me from where the shuttle was. Took the exact same photo. So I have a comparison of years with the plume.
Nice.
It's
gosh.
surreal.
So RS-25s, boom, there's the solids. There wasn't an overpressure.
No.
Or minimal if there was.
Oh my god, that's so gorgeous, dude.
And
do
for
you think
people
there
who are
wasn't
wondering
an
what we're talking about
overpressure?
here.
Yeah.
People wondering what we're talking
you wanna
about
talk
here.
about
I wish just look back on many shuttle launch replays. You will see what a real kind of like shockwave leaving the mobile launch deck, and it just comes away.
Yep.
Real ignition or SIB ignition. Yeah, it's something you see every single time. You don't see it there.
No, you don't.
That's crazy.
Maybe this might be
Not at
too
all.
much asking. Can
And
we prepare that from Artemis 1 from our coverage? Because I remember we saw it. Like the overpressure was
100%.
visible in our stream.
Yep.
It was unmissable. Yeah.
I wonder if it's like the atmospheric conditions, because y'all are talking about how clear it was, like not a lot of haze today. I wonder if there's like a humidity density thing that makes that more apparent or make it appear.
I was also going to say, Das, that's a really good point, because there wasn't any sort of vapor cone as it went transonic into supersonic speeds today either. Like there wasn't even a hint of one, and that really only happens when there's a lot of moisture in the air, and they're obviously it's lovely outside right now. It's not humid whatsoever, hence the lack of haze in the imagery. Like it was so clear.
Yep.
So that probably also had something to do with it. But it just looked a lot less violent, not so much from not just from a lack of shockwave, but it seemed like the ML didn't shake as much. Maybe we just need to see some closer up angles of how the
Max.
Look at the top.
Yeah,
right.
Look in the top right.
Max, look.
That's Orion. That's Earth.
And that's her.
Oh my god!
My God.
He said the thing.
He said the
He did
thing.
the thing.
Wait, but if that's a fisheye lens, the Earth is curving the wrong way, isn't it?
Oh,
Shouldn't
don't
a
start.
fisheye make it curve the other way?
There are 25,000 people watching. Don't do this.
No, I'm telling you that if that curve was caused by a fisheye lens, it would curve the other way.
Oh, so you're saying it's real?
Yes, I'm saying it's real.
Okay.
Wait, what do you mean the Earth's round? Like, what are you talking about?
Good grief.
What do you mean the Earth's round?
Look at that, though. That's too
Dude,
cool.
what a good day it's been, huh?
Yeah.
There's
Oh,
even
they're
more
starting in
replays
6
still
minutes?
happening here.
Oh yeah, Sawyer, you gotta run.
I'm going to
out
head
there.
on up to the briefing room if they're doing it in 6 minutes. I'll be back.
Yeah.
Goodbye.
Sawyer was
Is
responding. We had a notice.
This is slow-mo. This is slow-mo.
Press
It's slow-mo.
conference. So Sawyer's going to the press conference.
is the
Yeah, so he's going to the
SRB?
press conference. I'll be hanging out for a few more minutes before I head off to camera pickup.
Wow.
No
that.
overpressure,
Dude!
but you can see the ripples there.
Oh, yeah.
Look at
from
the ripples.
Yeah.
And there go the
And you can-
baskets.
And you can tell if you look at the exhaust plume and the difference in coloration. Well, not anymore, but the difference in coloration between the white and like the brown orange, you can tell which was the RS-25 from the Deluge and the SRBs.
Oh yeah.
Oh my gosh.
That's so cool.
There is
Look at
no
the
plume of fire
waves
like
moving
two big old
downwards.
solid rocket boosters.
Like you can see waves going through the exhaust. It's like the velocity of the exhaust itself, like the smoke, and then the velocity of the energy moving through it. That's nuts.
Are we sure the baskets aren't meant to do that? To kind of protect themselves from the actual plume?
They run away
that's what
from
Alex
the
was
launch.
just saying.
I wouldn't be surprised
I don't know.
if that was planned.
Yeah.
But if that was planned, why wouldn't they do it earlier?
Yeah.
I don't know.
Maybe
Well,
that.
you never know.
Yeah.
Yeah, if they abort and they need to do an evacuation and bring out the arm again, like if they do like a T-2 minute scrub and then suddenly they have to evacuate, like they need the slide wire baskets there. I'm going to ping Sawyer and see if he can bring up that question in the press conference because
Yeah.
that's interesting.
Yeah. Because I mean, they'd have to get all the way out of the rocket and then get over to the slide baskets, and it seems
Open
I don't know,
two
we should ask-
hatches. Yeah, it's clumsy.
Yeah, we should ask for an official answer to where the basket's supposed to go. I'm sure that's what everybody wants to know. Like our pressing question about the moon mission, humanity's return to the moon is. Hey, were those
the slide baskets?
It's like I'm sure the crew is fine, but the slide wire baskets.
To be honest, I have a lot of questions about the things that we heard right in the lead up to the launch, because of course there were a few issues that they worked on, and I will be interested to know a bit more of that information. And hey, it's a post-launch press conference. That's the point to ask about those, right? Like, hey, when this happened, what was going on? Can you give us a little bit more of information? The baskets, etc. Right? Like, especially when everything is going smoothly. What else are you gonna ask?
Yeah, if those are the questions we need to ask, you can tell that it's been a good, smooth mission. Like, there's nothing big for it. It's like, hey, did you install those toilet filters or not? Like, what's going on with the toilet filters? And by the way, the baskets, we saw them slide. Was that a big deal or not? Like, if those are the questions that we have, it's been a good mission so far, right?
Yeah, 100%.
I can bring something else up on 39B. Originally, the plan for Ares, the silly rocket, was for that roller coaster
Good rocket.
emergency egress system. Yeah, the roller coaster that was pretty much like a Disney ride, and it actually had Disney engineers working on the project. That's no lie. That's a true story.
Seriously?
I've seen the PDF. Yep, it had actual
Is it?
Disney
Okay.
engineers working on it. Straight up. And it was literally one massive roller coaster that would basically hook up onto the mobile launcher once it had arrived at the pad. And it had literally roller coaster carts that would just go like a complete drop and then go along the track into the actual bunkers.
That's awesome. I've seen like the renders or whatever of that.
Yeah,
what better
NASA
place?
renders as well.
Yeah, from Florida, they take the roller coaster engineers and they have them design the emergency escape system. Hey, real quick, y'all, we are standing by for the post-launch press conference. We are going to share that with you here, and we are not going to run our mouths over it. We've done quite a bit of talking so far, but we do plan to pipe that press conference in here for you to watch. And then there may be an event afterwards as well. We should get a crew downlink that might or might not be like immediately after the press conference or part of the press conference. It's not exactly clear right now, but we're going to bring you that as well. We're not going anywhere. We're going to let you listen in to the post-launch press conference happening in just a couple of minutes here, but we are not going to be here talking while the press conference happens. We'll let the press conference speak for itself. It's a press conference. That's what they're supposed to do. So,
I was gonna say, because this is a very bad timing. They still have the Apogee race burn, and it's gonna happen during the press conference.
Mm-hmm.
Well, good.
Yeah, so you should
We'll get a
plan
live
better.
update. Yeah, we'll get a live update from the press conference.
It might not check the
Alex, you
building
should
info,
interrupt the press conference with the ooh, ooh, ooh.
Oh.
We'll probably
We're
get
all
the
very-
update while on the conference.
Yeah, we're all very excited about everything, especially the replays. But is that starting here? I hear some beeping near Sawyer, maybe.
Oh my god!
That?
Yeah, that's what I'm talking about.
Oh.
This is the footage I was talking about with D. Look at this.
What is this? Is D?
Yes. Yes.
Oh my
What?
goodness!
That's rather nice.
It's rather
Just
nice.
Yeah, it's all right. It's all right.
It's all right.
It's I guess.
It's decent, Ryan. It's decent.
Decent.
Yeah. Goodness me.
That's bonkers.
You can say that again, Chris.
You
Yeah,
never got
right?
that during
Look at
show
this.
either. I mean, they had fancy cameras for sure, but not like this.
What is this? Somebody explain this to
Wow.
me. What are we looking at?
A rocket flying sideways because it's why is it cropped this way? Actually, hang on.
Is this liftoff or was this filmed for like TikTok or something?
I think D may have mounted the camera 90 degrees offset so we could get as much of the plume as possible. I'm sure this is, knowing D, this is probably like 4K or something, so we can rotate it and crop in. But
What FPS is this though? Look how slow the exhaust is moving.
It might
I will tell you.
Yeah.
Go on, Max.
Go ahead. Oh, okay. I think D was telling me this is. I can't tell. I think this might be around 1500 frames a second. I want to say.
That's the new camera.
Okay, I'm sorry.
I was going to
400 frames a
say
second.
this footage is bonkers out of my mind. It's recorded in a file format I genuinely have never heard of before.
High speed footage for the win.
.mp3.
Nope. Oh my god. Booster burnout.
That
Give me those
was
Sidewinder motors. Yes, look at this.
a super secret NSF Skunk Labs project. Because of all support, we had upgraded some of the equipment to some new higher frame rate stuff. And D had been running some of that, so we'll get more information. But we do have like NSF Labs projects, and a lot of times we don't talk about them until we see some of the results. But that might have been some of the results right there.
I think so.
I'm happy to report that Sawyer Rosenstein has arrived at the press conference and he has the question, what happened to the slide wire baskets?
Nice.
Wonderful.
Only the most important
up against
topics.
First question. Yep.
Yeah, right up front.
Of a Marcia done.
He better be waving his hand around like crazy. Like me. It's the last slide wire baskets, please.
Baskets.
The baskets. Well, it is 8:03 p.m. I need to head off for remote camera pickup. I love y'all. I will talk to you guys later.
All right, good deal, Max. Folks, Max Evans was out there, set remote cameras, was taking shots. The flag shot that you saw, the print with the flag shot, SLS going behind the American and the Artemisian, the Artemis flag.
Pinned in chat, by the way. Pinned in chat.
It's pinned in chat. Thank you, Chris. Thank you. That was Max's shot. So to support what Max does, to support what we do, you can pick up a copy of that flag shot. You can put it on your wall. And then you can tell all your friends the Artemisian joke that I just made up on the fly because I didn't know what to call that flag. But whatever.
The really annoying thing for me right now, as we look at this beautiful image of the moon, I assume that's either over KSC or over Starbase where we have our robotic cameras. The moon, the full moon, is meant to be like center in my office window right now. It is like it's cloudy. This is England. It's cloudy. But the annoying thing is I can see the glow in the clouds, but I can't see the moon. We can see it from KSC, though.
I want to go outside and see if I can see the moon here, but I doubt that I can see the moon here. Because that's where we're going. That's where we're going. That's why it's got the moonshot, because that's where we're going, to the moon. Right, Ryan?
Yeah, I mean, we have launch pad on the left, or where it was built on the left, and destination on the right. This is I think, unlike, when we cover the International Space Station crew launches, this is the first time we're able to show the beginning and the destination at the same time with our live cameras.
It's going around the moon.
Usually we
around the moon, going around it.
Exactly. Usually we lose track of the rocket after, 3 or so minutes into flight. This time we can follow it all the way there.
Nice. We still have the live views down there in the bottom. Every now and then we get the little hiccups, but I'll take it. And we got the mission clock there with the flag raising, and then we got the moon up there, and we got the VAB. A little bit of information. It sounds like the presser is a little bit delayed here, so we'll keep hanging out with you while we wait for the presser to start. But as soon as the presser starts, we'll pipe it in and get an update on how things are going.
They're waiting for a basket expert to arrive on the panel.
They delayed the whole conference until they could adequately address the hot topic of baskets.
Of course. Be first question.
It should be.
In the room.
It's the basket in the room. Are there really still 23,000 people watching this stream? Is that a thing?
Yep.
As they should, because they're still going. If you miss this, you're missing it. The mission's still going.
Well, folks, if you haven't yet, this is what we do. If you ever want to come hang out with us, if you want to put us up on your TV or whatever, we're NSF. We're independent space nerds. You know the buttons to click, like save the channel, sub to the channel, whatever, turn on the notifications. We upload stuff multiple times a week. We cover just about every launch we can get to live. We have sort of a rule. If we can get our camera to the launch, we don't just like regurgitate the footage from SpaceX or whatever, right? We take our own cameras. We have our own commentary. We don't just like rely on the provider's footage anytime we can do that. But we cover all the Starship testing that's happening as well. If you're a fan of Starship, you want to know what's going on with that part of the Moon/Mars project that SpaceX is doing. We've got 24/7 cameras all around Starship. SpaceX Starbase is the name of the place, actually, down there. You can watch those anytime. There's a community of 1,000, 2,000 people that are in there every day just chatting about space stuff. We have 24/7 cameras here at the Cape. You can watch the boosters flight come back into port live. You can chat with other space fans there. If you want to be a part of the community, you want to hang out with us, you are welcome here anytime. Click the button to subscribe to the channel. Click the little thumbs up button if you want. Looks like 15,000 people clicked the thumbs up button. But we are NSF. We're NASAspaceflight.com. That's what we do. And we like making friends. We like having more people hanging out with us whenever we do this sort of stuff. So if you haven't yet, sub on this device, go to your other burner account, sub on that device, send it to your mom and be like, hey, this was cool to watch. Here's a replay. However you do it, if you want to join the community here, we welcome everybody to hang out with our other like-minded space nerds who see replays and go like, no way, that sort of stuff. Do things that NASA probably wouldn't be allowed to do on their stream, So had to toss that in to remind folks, this is not just one launch for us. We do lots of launches. We're always here hanging out. Did I get everything there? Did I miss anything?
Didn't we have a
You did, Daz, but also I will point out something where you mentioned we don't just regurgitate SpaceX's stream. We can even go further than that with our own content. Is that SpaceX at Starbase have our stream, Starbase Live, on monitors inside Star Factory and the Megabase. Incredible.
Like, SpaceX watches us internally. We hear from all sorts of employees. They're like, "Oh, I watch your show to keep up with what's going on because we're here covering stuff, letting y'all know what's happening with all these different exciting programs." So, McGregor, I forgot about McGregor. You want to see SpaceX test rocket engines every day? We actually designed and installed some off-grid 24/7 cameras near McGregor, so that you can watch SpaceX test 8 to 10 engines a day, because SpaceX doesn't play around. So in any event, we have a ton of fun with this, but that's what we do. Thank you for reminding me there. And the socials as well. I should say the socials. We're not just on YouTube. We're on X. We're on Facebook. We're on Instagram. We're on all the different places that you might have an account. We're probably there. We're not on OnlyFans. You can't find us there. Like an Only Rockets or something. That's one we won't be on. But in any event,
went there. You can tell we've been on air for like 12 hours, 13 hours, because he went there.
That's the sort of thing I'd say, Ryan, and then Daz would tell me off.
I'm allowed, though. I can say it. Like, I
Yeah.
can approve it. I can approve it for release. Anyways, that's the whole day. That's why we wanted to get Chris in here as well. NSF's been around for 20 plus years. Over 20
21.
years, we started the 21. We started the original like shuttle space nerd forums, right, Chris?
That's right. Yeah, a news site and a forum. We thought that'd be a good
news
idea
site
for
and forum.
a kind of like just a specialist, low kind of like membership kind of like place where people just want to talk about spaceflight can go, rather than getting distracted by all the other nonsense that tend to happen on forums which have multiple subjects because no one was doing it. And it was a NASA guy who's still on our forum to this day, and a shuttle guy who said to me on the old space.com forums, which no longer exist, you're a journalist, because I was a sports journalist already by the time, just set up a news site, we'll help you, we'll feed you some information, give you some, something to go with, because this is before return to flight with the space shuttle program. And they said, we'll get you prepared for it. And it just went from there. And the roller coaster emergency egress system was one of our biggest stories because in the early days, because it got linked by USA Today, and USA Today gave us a hard link back to our site, and it just really exploded from there.
Nice. It's literally where we came from, like creating a space, where space nerds can hang out together. That's like the idea of the original forums. Like there were folks that worked at NASA and they wanted a place to hang out and chat and share stuff. And that's sort of what it was. It just sort of grew from there, right, Chris?
Yeah, really, it's very organic. There's many forks in the road where it could have easily just like died off or not happened. L2 saved it in the first year because of that explosion of it was $25 a month to host it in the early days. $25 a month, I remember it. And as we basically got bigger and bigger, we had to scale up, and we were like, well, I can't self-fund this. So I said, well, we'll have a subscription area. That's the origins of L2. 1 year into the site's time, we started L2 and people supported it, and that's what paid for the servers, and it just went from there. And there's so many forks in the road. Everybody who's talking on the stream found us via sort of like the organic route.
Yeah,
where we've not gone out literally and sort of like put an advert in Aerospace Today or whatever it's aviation today. It's literally been organic. The team has grown from being people who have found a site and liked it and then said, well, I'm good at this, and gone from there. I could go through every single one of you, and I'd spend too much time doing it. But that is literally how it's happened, and I've been very fortunate. It's not any credit to me. It's just I've just got lucky.
I don't know that got lucky is the right thing to say, Chris. You made a place that was cool, and people that understood that it was cool. Like they found a place to hang out with people like them. That's literally what we've been doing for over 20 years.
Looks like Ryan might have just
Bandicam.
Just Bandicam, nice. Go ahead, Ryan.
I was just going to say, it looks like a Ryan to ground had a little blip there, but we can see the solar arrays moving on the spacecraft. Looks like we've got video back.
To Earth.
Nice.
This is going to be surreal when it goes around the moon.
Yeah, I mean, you can see this thing articulating.
Yeah. I mean, we'll lose the comms for the dark side of behind the moon, but just the approach to the moon.
Yeah.
The views we're going to get. The moon getting bigger in the window, the saying is. That's going to be absolutely crazy to watch live.
I'm trying to figure out where this camera is. Remember they had the selfie camera on the end of the solar array, like looking back at the spacecraft, but that's not what this is, because the solar array is moving in the foreground.
I can help you out with that one.
Yeah,
so
go ahead.
There's an adapter between the European service module and the capsule itself. And
I have all those.
It goes
here.
wide, right?
Uh-huh.
And so, yeah, it's right on that adapter. It's looking down on that adapter.
It's an adapter so that you can plug the European thing into the American thing. That's what I have on all my outlets here.
And that you see, I think that's the start of the press conference.
All right. I think we are still standing by for the press conference. As soon as we get into the meat of the press conference, we are going to pipe that in here. For now, everybody silently chant moon, moon, moon. I don't know if Jack is watching, but that's a Jack thing. from can I say from back in the day. But we will get you all that press conference as soon as it gets into the meaty parts here. And honestly, a little while ago, we stopped going through the support. The support continues to come in. People joining the membership program.
Miss 2
Prawn-
Post-Launch News Conference. I'm Bethany Stevens, Senior Advisor and Press Secretary, and I will be your moderator today. I am
Here we
joined
go.
by
Press
Administrator Jared Isaacman, Associate Administrator Amit Kshatriya, Acting Associate Administrator for the Exploration System Development Mission Directorate, Dr. Lori Glaze, and Director of Flight Operations, Norm Knight. Administrator Isaacman will give opening remarks, and then we will open the floor to questions. If you are dialing in to be with us here today, please press *1 to get in the queue. And with that, Administrator.
Thanks, Bethany. Good evening, everyone. So today, April 1st, 2026, 6:35 p.m., NASA Space Launch System rocket lifted off the pad with 8.8 million pounds of thrust, carrying the Orion spacecraft and the Artemis II crew out to Earth orbit and beginning America's grand return to the moon. Now, about 51 minutes into the flight, during a planned handover between satellites, the Orion spacecraft underwent a communications issue, leading to a temporary partial loss of comms. The uplink from Capcom to the crew was being heard by the crew, but we cannot hear their responses for a brief period of time. There were no issues with the vehicle itself. Comms with the crew have been restored. We're actively working the issue, and we'll keep you informed. The Orion spacecraft has successfully separated from the core stage, and its solar arrays have been deployed as planned. Soon, the crew will execute the apogee raise burn, placing the spacecraft into a stable, high Earth orbit as we prepare for the translunar injection and the journey to lunar space. NASA astronauts Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency mission specialist Jeremy Hansen are safe, they're secure, and they're in great spirits. We will continue to monitor their health and the status as we move into the next phase of the Artemis II mission. So after a brief 54-year intermission, NASA is back in the business of sending astronauts to the moon. We have arrived at this point through a sustained effort and national commitment and the work of thousands across the agency, our industry partners, and our international allies. I want to personally thank the ground crews, pad controllers, the entire workforce here at Kennedy Space Center. This mission belongs as much to you as it does to the crew. The crew is now in the capable hands of Mission Control Houston, the Johnson Space Center, where teams will guide Orion through each phase of the mission with the same discipline and precision that has brought us to this moment. We've certainly been here before. We know the challenges ahead. We have a lot of checkouts to get through before TLI. And when, if all goes well, everything is go, Artemis II will be moonbound. You have our commitment to keep the public as informed as possible on this historic mission. And we will celebrate when we will hold our celebration until this crew is under parachutes and splashes down off the west coast of the United States. Thank you.
So with that, we will open this up to questions, and we will see here in the room if we have any takers. We'll start right up here.
Congratulations to all of you on a successful launch so far. My name is Jim Siegel. I'm with Florida Media Now, and I'm curious about when the astronauts will have their first meal on this mission. And secondly, is somebody on the Earth back in Houston or somewhere keeping track of what they eat during this entire mission, and how do they go about doing that? Do they tell them what to eat, or do they kind of select what they want? What do you think?
Well, let's see. I'll jump in on this one. Well, what I'll tell you is they do have planned meals, okay? So they have a planned meal today. I will tell you they're very busy. So ascent day is very tough. It's tough physiologically, and it's tough from a workload issue as well. And so this timeline between now when the crew goes to sleep, so MET of about 8:30 is pretty packed. They're going to snack. They probably have some pre-positioned meals. I know they did in their flight suit. Some of the snacks that they can use if they need. But I will also tell you that flight day 1 and flight day 2, you might not feel like eating a lot, and that's just part of it. G is transitioning from a 1G environment to 0G, and it takes a little bit of adapting. So right now they're working hard. They are doing what they need to do. They sound great on the loops. That was really a good signal to us that that they're feeling well. But just know that that's part of the equation, you know, when they get on orbit. As far as the food being tracked, yes, we have a food lab, and we have folks at the Johnson Space Center tracking what they eat, the nutrition, the calories. It makes a difference. They do this on Artemis. They do it on Space Station as well. So we're well versed in that. We want to make sure that they're healthy, and we also want to make sure we know what they're doing, what they're eating, so we can also track that they don't need any supplements or anything additional.
We'll head over to Joey.
Thanks, guys, and congrats on a clean launch so far. Jared, or whoever wants to answer, how were you able to resolve the communications issue, and do you have any guesses as to what might have caused that? And was there any part of the mission so far that appeared off nominal, or is everything looking good? Just curious to hear how things are going on that. Thanks.
Well, on the comms issue, and I don't know, there may be someone here that has a little more detail than I do of having to run around quite a bit, but I think they're still looking into trying to really understand exactly what was going on there. But it's restored, which is important. I think it just
it was during handover to Tidris West.
Between
sometimes that's squirrely ground configuration. You gotta get that right. So hopefully that's what it is. But we'll chase it down. But they were able to recover. They had intermittent forward and return links, so the burns that they needed on board it was never an issue. It was unusual for it to be dropped out for a couple minutes, so that's why we're telling you. We had a controller issue with the toilet when they spun it up, so we got to work through that. That's going to take maybe a few hours to troubleshoot. So there was also a water tank valve. There's 4 water tanks on Orion. There's a crossover valve that connects the 2 gangs of tanks. It's supposed to be open to ensure maximum flow. It was closed during ascent. You know, when you shake the thing, things like that happen. So they're going to reset the valve. And then they had a recurrence of on Artemis 1, we had a latching current limiter failure on a piece of electronics, a transient failure when it gets exposed to radiation. They took 1 hit of those. We took about 24, 25 of those during Artemis 1. Again, normal, the onboard fault detection cleans that up, but we're just getting started, Joey.
Just to be clear, right, this is a flight test, and a lot of what we're doing here is exactly this, trying to test out all of the things that require the crew interaction, right? And so we anticipate to have a lot of these. Well, that's what we're here for, work through them.
Importantly, apogee rays burn. We're go. So they're going to stay in space.
Sawyer.
Thank you, Sawyer Rosenstein, NSF. I noticed that the slide wire baskets happened to deploy during launch. Was that something that was expected? And can you give any initial reports, at least what you've seen from the cameras, of how the mobile launcher is doing, given the hope to be able to quickly turn it around?
Yeah,
Do you have something on the baskets? I can talk about the turnaround.
The baskets they're supposed to get out of the way. That's part of the plan. So otherwise they take plume loads, and we don't like that.
So I can tell you on the mobile launcher, our team has already been looking at a lot of the imagery that we have that was taken both during and after and assessing that, trying to get the condition. We've got teams, I believe, going out there. They might already be out on their way to take a real look. Some of the good things that we've seen relative to Artemis 1, one of the issues we had was that the water that was supposed to be spraying down the launch pad, so that there were some issues there that didn't happen. We saw a lot of corrosion. The water was working, so things were getting washed down. We're still also going to remove some of the parts so that we can do some of that cleaning to make sure we don't have those corrosion issues. We haven't seen evidence of things like after Artemis 1, like the elevator doors were blown off. We haven't seen that. We're optimistic, but we got to get out to the pad. We got to look. We did a lot of changes after Artemis 1, trying to harden the systems so that we can turn it around faster. We do anticipate there will be some items that'll need to be replaced. It's a pretty violent environment. But we're hopeful that that's minimized, and as soon as we have more information on that, we'll definitely let you guys know where we stand and how quickly we think we can get it turned around. Thanks.
Lauren.
Lauren Gresh with Bloomberg. I just wanted to get a gut check on how we're feeling about the upcoming proximity and ops operation. Do we have any concerns with that TDRS delay, or is that not an issue for that?
I would say right now we're on for the proximity operations demo. Haven't heard anything that's keeping us from that, Norm?
No, on track, ready to go. Victor Glover's going to be flying it. Reed's going to be working the procedure with him and cross-checking, and Jeremy and Christina are going to be looking out the windows, also spotting, cross-checking, using cameras and imagery, and it should be beautiful, so we can't wait.
We'll go right over here.
Yes, Bert Dicht from Ad Astra Magazine, National Space Society. Just wondering if the astronauts reported what the ride was like to orbit. I know with the space shuttle, it was a pretty rough ride until there was SRB SEP. Was this similar?
Have you heard?
I have not heard a report yet. I know we will get a report. Again,
Yes.
when MECO happened, immediately they were getting prepped to do their perigee raise maneuver. That's critical. Otherwise, they come back to Earth, which we don't want them to. So they got that. They are working to get their spacesuits off. They're, they just got the ARB burn, which was very important. So now they're working to get their suits off. So they are very busy. Now later today, I anticipate they will call down and give us a full brief as to how the Proxox demo went, how the ride uphill went, and I personally can't wait to hear the comparison between this massive rocket and the shuttle.
Sounds great. Thank you.
Micah.
Thanks, Bethany. Micah Maidenberg, Wall Street Journal. Maybe for the administrator, I'd like to ask you, I know we're early on here, how you're thinking about success for this mission, defining success, a lot of tests ahead, and just what happens if you don't kind of meet that standard as the flight unfolds. Thanks so much.
Well, I mean, to me, success is undershoots and in the water safely after a 10-day mission duration, so no early off-ramps there. I think we're, right now we're already getting good ECLIS data. We've never flown Orion with crew on board, so that's pretty important. I mean, understanding the Orion spacecraft is, it's paramount in this one to progress on to integrated operations of Orion with a lander. Every day we're getting data. It was mentioned from the get-go. This is a test mission for sure. No crew have ever ridden this before. We'll keep gathering data over the next 10 days. We'll share updates, but we'll call success when they're in the water safely, and we'll start working on the next mission.
Jackie.
Right here. Sorry if I missed it. I just wanted to check in on the status of the perigee and apogee burns. Are those both finished at this point? And then I also wanted to check best way to explain to the audience why we're doing that apogee raise maneuver and why we go into that high Earth orbit. Thanks so much.
I mean, I can certainly say we've completed the perigee raise maneuver. That was done pretty quickly, as you heard, and the apogee raise burn should have already happened. That should have been happening while we sat here. They were getting ready as we were walking in. And then if you want to talk maybe about the rest.
So we go into a high Earth orbit. Roughly, the perigee is about 1,000 nautical miles, rough give or take, of the Earth, 25,000. So it's pretty elliptical. That's getting us, everything we do is getting us set up for the translunar injection burn. And so it's getting these burns. It's all converging down to what we call TLI. So we got to get the ECLIS system checked out. We got to make sure we have our redundancy. We got to make sure these burns go off where they should go off, and get Orion and the SM configured exactly where it needs to be. So when it comes around and it's time for the translunar injection burn, off we go, and that takes us really, that puts us outbound to the moon. That's a real big commit point, and so you'll be hearing more about that tomorrow.
You might mention it not only sends us outbound to the moon, but it also sets us up for the gravity assist that brings us back set off.
Yes.
Once we make that burn.
Go right back here.
Hi, TJ Muscara with the Epoch Times. Thank you all so much. Something that hasn't been really talked about is that the Space Launch System predates the Artemis program. It got going all the way back to 2011, so 15 years really invested in this. And just how does it feel to finally see it, launch with the human crew on board?
Yeah, I mean,
the program.
right now, like I said, we're focused on the next 10 days. But I mean, I'll tell you, I'm incredibly proud of the folks that worked on this machine for as long as they did. And one thing we didn't talk about earlier was, that one of the big objectives is getting the organization and getting our qualification standards and getting our certification rigor up to the standard for crewed flight. That's a big, even though the mission is a complicated mission, moving the entire organization to a mindset of thinking about risk in the right way to fly crew is a big deal. And making sure that the way we've gotten the machine configured to fly crew with the resilience and the reliability we care about is also a big deal. So it takes time. I mean, we got a lot in front of us, but I mean, it's for the guys that were out there, there's a big celebration in launch control for the rocket guys. The rocket guys can go out and play now, but the spacecraft guys got a lot of homework, so they're going to go work on that. But yeah, for them, I could see it on their faces.
Jeff.
Jeff House of Space News. During the countdown, we heard controllers working through a few issues, one with the flight termination system, one with the launch abort system battery, and it sounded like there was a brief telemetry dropout. Wonder if you could provide a little bit more details about those issues and how you resolved them relatively quickly.
Yeah, so Jeff, the FTS issue was we were doing an end-to-end test. We typically have to confirm that we can get a signal from the range to the machine and then back. We weren't able to close that entire end-to-end loop. But the guys at the range, they were really quick on their feet. They swapped to a different range receiver, which is a slightly different heritage, but has the same fundamental algorithms on it, and they were able to switch over to that and able to confirm a good end-to-end signal, which is really clever. We had thought about getting a receive-only box that we had in the VAB and shipping that over to Patrick quickly so they could do it, but they were able to fix it on the fly over there, so that was good. And once we knew we could confirm the end-to-end loop of that command, then we didn't need that receive. We don't need to do that test more than once. We just need to verify the commands get on board. And so once we confirmed that command was there, then that we met all of our public safety risk. For the launch abort system, we had a battery, so 2 batteries, several temperature sensors on both batteries. We had one poke out of family. We want to make sure all of them are tracking within certain limits, but we could confirm, given the locations of the temperature sensors, where they are on the battery itself, that the reading was instrumentation, because there wasn't a credible physics-based explanation for why that sensor would be that far high. It was an order of magnitude off scale high from the rest, and so we were able to quickly vote that sensor out. So that was two of the major issues. But again, the team, this is what the training is for. This is what the practice is for, is to go into those things and knock them out quickly. So they did really well.
We'll go right over here.
I noticed there was a lack of public address announcing outside, and there was a lot of going back and forth when we realized there were some issues, and we had to go back inside to find out, or we had to have our phones. Why was there no public address system available with loudspeakers outside?
I'm not sure what you're referring to. We're not sure what issue you're talking about the public address. Okay.
Available to people outdoors, and I thought that was a lacking.
We'll take a look into that.
We'll definitely look into that. I wasn't aware that happened. So thank you for that information. That's new, and we'll definitely look into it.
We'll go right back here.
Thomas Moore, Sky News. Administrator Isaacman, as a fellow astronaut, what were your feelings watching your crew rising above Pad 39B? And do you feel that extra sense of responsibility for the crew as they head further into space?
I certainly felt that it would be, just from, I guess, my perspective in it, that, I don't know, it is far less stressful to be strapped into the rocket than to be responsible for it here on Earth. So I definitely had those feelings quite a bit. But, you derive a lot of confidence from the process that leads up to this moment. I mean, literally the army of people that came together across NASA, all our contractors, all our partners to prepare for this, every step that leads up to it. This is what I, was really honestly going through my mind through it, is all the testing that goes into it, the integrated testing, the flight readiness review, everything that goes into a flight readiness review. Not to mention you have a truly exceptional crew up there that have been training for years on this. That gives you the confidence to undertake this mission, especially knowing the implications that it is part of a much bigger program. This is America and our partners' return to the moon, and we're trying to do it this time to stay. So, incredibly important mission. Certainly felt the pressure of it, but it was relieved, based on the confidence we have in the team here at NASA and everyone who contributes to it. Thank you for the question.
We'll come right up here.
Frédéric Castel with France 24. First, of course, congratulations to NASA for the grand return to the moon. Mr. Administrator, I have this question that they ask me constantly in Europe and in the States. In the 60s, NASA was using just the slide rule to go to the moon, and they could launch almost every 3 months. Of course, they had more money probably, but what happened in 50 years? Why is it so difficult to make it again? What has changed? Thank you.
Well, for sure, we knew. Look, it's a very fair question. I know a lot of people ask it, not just in your country, but here in the United States. Certainly, financial resources are part of the equation. NASA's budget, if I recall, was somewhere between 4 and 4.5% of the discretionary budget during the space race, about a quarter percentage of that today. And I mean, to be very honest with you, I think competition is a factor in this as well. It's a great way to mobilize the resources of a nation and concentrate on something extremely challenging, and that's what we did in the 1960s. And I think with absent some competition, we focused a lot on partnerships and all that we could do collectively with respect to science and discovery. But competition can be a good thing, and we certainly have competition now. I think that's why you're seeing us start to concentrate our resources back to the objective, and do it with a great coalition across the NASA workforce, our contractors, all our partners that have come together, our stakeholders in Congress and the administration who came here to witness this launch, is because they know we have competition, and this one's going to be close. And I think as a result, you're going to see a lot more progress, more so than you have in since when this was originally conceived under Constellation. We're going to get back into the business of launching rockets on a regular cadence, and we're going to bring the world along with us. So.
We're going to take a couple of phone bridge questions for just a moment. Reminder that you can join by pressing *1 to get into the queue. We're going to start with Will Robinson-Smith from Spaceflight Now.
Hi, thank you, Bethany, and congratulations, everyone, on a good mission so far. Question about the upcoming TLI burn tomorrow. At what point during the day will the team conduct a poll on readiness to proceed into the TLI, and what are the main criteria that you'll be assessing to make that final determination? Thank you.
Okay, well, the TLI burn actually happens about the time that launch happens, so it's 1 day into the mission. So tomorrow, Eastern time, would be about 6:35-ish. Obviously, those burn times can change, so check that before tomorrow. But what are the teams looking for before TLI? We're looking to make sure that the life support systems work, that the vehicle's healthy, the life support systems have been checked out, they're ready to go. We assure that those are functional, because once we commit to TLI, they have to function. And so we want to make sure. So that's why we spend a day checking out the systems. Ascent is, you shake, rattle, and roll a little bit, the vehicle. You saw that today. And you can imagine what that does to the systems. The systems, though, are performing very well. We anticipate that they continue to, but we want to get some track record on them before we do that. We also want to make sure we have redundancy in the system for comm, for environmental life support, propulsion, those type things before we embark on that TLI mission. So that's what the mission control team in Houston will be doing tomorrow. Jeff Radigan and his team, as the lead flight director, will be well into that. The teams are well versed on it. They have trained for it. They work very closely in conjunction with the engineering team, the mission evaluation, where the engineers that have the intricate knowledge of Orion come together with the operations team, and together they work with the crew to make sure that the vehicle, is doing what we want to and accomplishing the mission objectives that we need to. But it always comes down to crew safety, vehicle safety, and mission objectives in that order.
I might also mention, as those teams are checking out all of those systems, there will also be a meeting of the mission management team that's led by John Honeycutt, whom I think many of you have seen before, and they'll be meeting tomorrow afternoon to hear all of the results from what's happened over the last day, in preparation to make the decision on whether or not we proceed with the TLI burn.
We will next go right back here to Manuel.
Thank you so much. Manuel Masanti with Exploración Espacial. I understand that the CubeSats are going to be deployed like 5 hours into the flight. Is there any chance we're going to see live images of the deployment? And then when is the crew, I know they're super busy right now, but when are they going to start using the flywheel on its way to the moon, when everything is more like...
The second question was to do when they start doing the manual as far as...
Flywheel machine.
Oh, the flywheel machine.
That's
Sorry,
correct.
thank you. The exercise machine.
I guess after the TLI.
I'll do this exercise.
Yeah, I'll hand that to you. But I can answer the CubeSats. So the CubeSats are installed in the Orion stage adapter, which is actually a part of the upper stage piece, right? So once Orion separates from the upper stage, we'll do the ProxOps demonstration, right? And then Orion has cleared and we're away, then they will be deployed. So Orion won't be there to take images of them. And once they are deployed, they each of them have their own plans for being able to communicate back down to Earth to various ground stations. They have their own communication plans. So we'll start to get information back from those individual CubeSats. So that's kind of the plan and the path forward on the CubeSat deployment and what you can expect.
We're going to take one more question from the phone bridge from Christopher Mick of the Hudson Star Observer.
Thank you very much. Congratulations to all the teams thus far. I had a question from an earlier media availability with Jeremy Hansen. He made mention of if the mission launched on April 1st, they would be experiencing a lunar eclipse. And I just want to follow up on that, if that's where that would be happening in the mission timeline, and if there would be any video perchance of that happening, or is that just going to be on the astronauts' photography at the time?
So you may have to answer the question on whether or not there'll be the availability of the what kind of real time. I'm not sure what we'll have there, but the crew will get to observe the eclipse. This is pretty unique. It's kind of interesting. It actually doesn't happen when they're out of comm, so they will be having communication during that eclipse time. But during the eclipse, the moon will be blocking the sun. They will be able to see the sun's corona, which is kind of cool. So they've been having a lot of science lessons over the last couple of days to learn about that and the eventuality that we actually launched today. So they're prepared to make those solar observations. It'll be a pretty cool and unique opportunity. I'm sure we'll get some images down at some point. I just don't know if they'll be live.
Tarek.
Thank you very much. Tarek Malik with Space.com for the administrator. There have been a lot of comparisons of Artemis 2 to Apollo 8, a pioneering mission, daring, that sent astronauts on an untested crewed vehicle around the moon. And I'm very curious, given last week's ignition event and how that really laid out an audacious and ambitious plan to really explore the moon in a stepping stone approach way, where you see Artemis 2 in that plan, and basically the importance of riding on this mission before you can make that next step for next year.
So, I mean, no matter, I guess, how you slice it, it's the opening act for sure. I think there are areas where we're clearly combining, Apollo 7, Apollo 8 into a single mission. Which we should be able to do. There has been, to your question earlier, there's been substantial progress, over the last half century. We have tools. We've certainly been there before, so I would expect us to be able to get some, mission efficiencies through. But I would say that what we learn from this, for sure, will inform how we think about Artemis 3. Now, there's certainly big picture objectives in that. We'd like to get the lander together. We'd like to test that out in Earth orbit before we go to the moon with it. But if there are things that we don't see, maybe it is comm-related issues, then we're going to try and fix those. And then we're going to want to validate that on the next mission as well. So, and that should be the idea, right, as we progress forward. I suspect when Artemis 3 comes around, we're going to learn a lot about the integrated operations that we'll want to validate and ensure is rolled into the subsequent missions. But yes, this should be a philosophy that we take across all of the grand efforts that we are pursuing right now, to not necessarily jump to the ultimate desired state, but to build up to it.
I'm going to jump right up here.
Hi, Richard Hollingham, BBC Future. Related to Apollo 8 in a way, really. I just wondered what plans had gone into a new Earthrise image. A lot has gone into the aspirational nature of this mission. Have you a plan? I assume you have a plan. What is the plan?
Oh, go ahead.
I do know that the teams have been looking at what the opportunities might look like. They've looked at the different launch dates, and so I know that they're really going to try to make that happen. I can't give you a confirmation on that yet, but stay tuned.
My understanding is they have been equipped with additional camera imagery capturing, equipment. So
we're going to do everything we can to try and make that happen. It'd be awesome.
We're going to go right back here.
Thank you. I'm from a Japanese news agency, Kyodo News. My question is to the administrator. The United States and China are competing over moon development. What significance does today's launch have for the US and NASA? Thank you.
Well, it's certainly an incredibly important step. I mean, this is the first crewed mission into this environment in more than a half century on a rocket that has never flown human beings before, along with a spacecraft. So it's incredibly important because we're going to learn an awful lot from this to inform subsequent missions. So yes, this is the beginning. I can tell you, having had an opportunity to speak with the Artemis 2 crew after the State of the Union address, we talked a lot about what we wound up sharing with the world at the Ignition event about adding additional missions, accelerating production, building out a moon base. I think it was very energizing for the crew because they knew that they were, this is a risky mission for sure. Any type of new test flight mission going in this environment is going to be challenging, and they knew it was building up to something bigger. And I think that it was very helpful for them in that regard. So, and certainly it was very helpful for me to hear their feedback as well. I would suspect a point or two wound up in the Ignition event from them. So,
we're going to go back here to the white shirt.
Thanks, Denise Chow with NBC News. I think for Lori or Norm, I'm curious what you anticipate could be some of the biggest challenges over the next few days, whether that's from a spacecraft or system standpoint or crew workload.
I'll jump in. Flight day 1 from a crew workload is pretty tough. Between now and TLI, we're working the crew really hard. In fact, when they go to sleep tonight, they're woken up in the middle of their sleep to do the perigee raise burn, and so their sleep's disrupted. They're hitting on all cylinders. They may not be feeling well. On top of that, so we know that flight day 1 and flight day 2 up to TLI is really good. We know it drops off then, and so going into this, we trained for that. We did simulations for this. We put the crew in exactly that state. Now, they weren't on orbit. They probably were feeling great. But we got a good gauge, hey, are we working them too hard? And the mission control team is great because they're watching the crew constantly. They're watching their performance. And we also have a crew that's very good at saying, hey, enough's enough. And so together, we will make certain that we're doing everything in the best interest of meeting the mission objectives, making sure that we're not working the crew so hard that they make mistakes or something of that nature. And again, we work as a collective team going forward. So this is our best opportunity, and they may add more stuff to the timeline before it's all done, and they may take some stuff out if we need to. But we adjust all the time on those things. So that's leading up to TLI. That's probably one of the bigger challenges, making sure we get those done.
I'm going to go right up here.
Hi, Robert Perlman with CollectSpace.com. For the administrator, you mentioned the 53-year hiatus, and in that time, now most of the world's population wasn't alive for Apollo, like I think you and me. And I wonder if you have a sense of, if even this early in the mission, that this has captured the imagination of those people that have never seen anyone go to the moon before, on a world level, on a national level, and how important is it to NASA to capture that support from the public?
Yeah, I've said it many times. I absolutely, I think it's foundational for what we do here at NASA to inspire. It should be a component of every one of our missions. I've talked about, I think after Artemis 2, you're going to have more kids that are going to dress up as astronauts for Halloween. We want to inspire and create interest in the next generation to grow up and contribute to this endeavor. Now, how have we done so far in captivating the world's interest in America's return to the moon? I don't know. You have to tell me. We've been rather busy the last couple hours. I would say, and I felt this way going into it, that when we got down to T0, a lot of people would be paying attention. I suspect when some of the imagery starts to maybe come back from the moon, that's gonna further bring people into this story. Right, and then we bring them home safely, and we start preparing for, again, the next chapter in the story. So, I think inspiration is extremely important. I think people, despite some of the commentary up to now, how many people really know we're going around the moon? I'm willing to bet right now a lot of people do, and I think we'll only draw in their interest further as the mission proceeds.
I'm gonna go right here.
Robert Coppinger, British Interplanetary Society Spaceflight Magazine. Commander Wiseman said during the crew news conference in September last year that when they get off the planet, they may only spend 3 or 4 days going around the Earth. What sequence of events would need to happen for that to occur? I was quite surprised to hear him be so specific about such a scenario. I know you all talk about it being a test flight. So what would need to happen for the mission to be curtailed in such a fashion?
I didn't cover the question.
So I think the question had just confirmed. It's kind of hard to hear, but the question is that the commander talked about one of the alternate missions where they maybe would stay in Earth orbit for 3 or 4 or 5 days.
Yes,
that sort of thing.
What would need to happen?
So
for
one
that
of the scenarios that would have led to that is if for some reason during the launch that the SLS did not quite deliver us to where we needed to be, or the upper stage didn't deliver us to the orbit that we needed to be in. That would have been one of the scenarios. I think that's probably the main scenario that would have ended up in that one of those kind of alternate missions. Yeah, but I don't think we're going to need to worry about that, hopefully. But the other thing is, if for some reason we're able to stay, but we're not able to do the TLI burn, we would stay in Earth orbit. So there's a couple of scenarios where that could happen.
We're right back here.
Hi there, Joey Vars with the Gabber for anybody. In the weeks leading up to the launch, we were talking about some of the distance records and altitude records and speed records that would be achieved that were contingent on the specific day and time of launch. I was wondering if we had a better concept of what those might be now that we are successfully off the ground. Thank you.
Norm has that data for you.
Well, based on the predicts right now, assuming all go as planned and the timeline is executed as we think it's going to be, it'll be on flight day 6. At an MET of about, 18 hours, 18 and a half hours. And again, check that as we get closer because burn durations and things like that matter. But that's where we will exceed or beat the Apollo distance record, or at least that's where we believe that's going to happen. So that'll be an exciting day, and we'll stand by to see what transpires.
You're right here.
Hi, I'm Hanju Yang from Kookmin Daily in South Korea. And first of all, congratulations on today's successful launch. And my question is for administration layer. And this mission also carried a Korean satellite on board. From your perspective, why does a crewed lunar mission like Artemis 2 matter not just for United States, but for the global community?
I think we say often that when we undertake these type of endeavors, we never go alone. We go with our international partners. We have a Canadian Space Agency astronaut that's on board this mission. We are carrying a lot of CubeSats from our Artemis Accords partners, and we are going to continue to do this going forward. JAXA is contributing a pressurized rover, a major contribution to our efforts of having an enduring presence on the lunar surface itself. The Italian Space Agency, just a few days ago, we signed a memorandum of understanding for a habitation module on the surface of the moon, a component of the moon base. And to be honest, it was also a key component to the ignition event from last week. Half of the Artemis Accord partners were present. We spent a good portion of the second day talking together, recognizing that some of our partners can make contributions like a pressurized rover or a habitation module, and many others are going to work with their academic institutions and universities for science instruments that could wind up on the phase one component to the moon base itself. Or interesting tech demonstrations. This is something that NASA is extremely proud of, and will continue to do so as we continue to press forward under this program. So
we're going to do last question here. I'm going to go over to you in the back.
It's Paul Brinkman, Aerospace America. Can you just talk a little bit about the propellant loading this morning? Was it flawless? Were there any leaks detected? Was it a repeat of the wet dress rehearsal? Did you learn anything?
Yeah, go ahead.
I think it went extremely well. What I heard this morning, and Amit may have an update from later, but some of the leaks that we'd seen of the hydrogen, during the tanking for the hydrogen, we saw leaks below 1%, which was significantly lower. Again, the seals that we replaced seemed to perform extremely well. We did a pressure test kind of partway through, and the leak went up to about 1.4%. Still, well within the constraints, which 16% is the bound that we have. So I think it performed extremely well. We actually, I think, finished the tanking early, from what I understood. So I think it went extremely well. So again, the seals that we had replaced out at the pad after wet dress number 1, I think that was proved to be very successful.
And with that, thank you all for coming out and covering humanity's return to the moon. Stay tuned for updates on NASA's social channels, including our continuous coverage on YouTube and NASA Plus. Go Artemis.
Thank you.
I guess we're back.
That was a wonderful press conference. We got Sawyer in, number 3. I think I'm happy with that. Very interesting that the slidewire baskets are purposefully deployed at that point in flight. In flight. Well, I guess it is in flight at that point. The slidewire baskets aren't in flight. The vehicle is in flight at that point. And then, of course, some information about the current state of the mobile launcher. Laurie Glaze there saying that it looks better than after Artemis 1, and according to the data she had at that point in time, the elevator doors still standing. Alex, was there anything else that that caught your ears?
Yeah, I was gonna say, in the meantime, while that press conference was going on, the ICPS, the interim cryogenic propulsion stage, on basically the upper stage of SLS, performed the apogee race burn. It was successful, and everything looks good. Thanks to Philip Sloss, by the way. He's out there at Houston at Johnson Space Center, and he was able to report in the back channel all of those different call-outs of, like, how the burn is going and things like that. But yeah, everything was going good. I think the last thing that he relayed to us was that They were working on the camera on the docking. It's technically not a docking port because they don't have a docking port, but they do have a hatch and a window, and so they're going to be using a camera during that rendezvous proximity operations demonstration that is coming up in about a couple of hours from now, once they separate from the upper stage. So far so good. They also went back to troubleshooting the toilet. We were talking about, that potential filter issue that they had with the toilet. They're also coming back now to fix that issue as well. So all so far good. That burn happened right on the dot. And so yeah, just working out the different procedures for the next step in the process.
Not sure if there is something going wrong with Das's connection there for a minute, but I will keep going nonetheless. We have just passed 2 minutes and 2 hours. It's been a long time. 2 hours 25 minutes into flight. We can see a live view of the moon on the right hand side, and of course that live visualization of the ICPS and Orion on the left as they are continuing to coast out towards the apogee here with their elliptical orbit, which they have been inserted into. I think, if my geography is correct, we can see the coast of Africa there. So they're over the Atlantic Ocean, coasting out, pointed north with the solar arrays swept back a little bit there in the shadow. Currently, the sun is currently being blocked by the Earth there.
Hey, Ryan, can you hear me here in comms?
There we go. We've got you, Das. How you doing?
Okay, good. Yeah, I actually changed my setup so I could listen to the press conference in the room. Then I had to change it back so I could talk to you again. So I am
there
here.
We go.
I think we're still standing by for the crew downlink event. That was the press conference we just watched, but I think there's still another event coming up, isn't there?
Indeed. So
Yeah.
roughly in the schedule, I think it's going to be around 3 hours. Alex, I don't know if you have a more specific time, but that could be in half an hour or so, maybe.
Well, it's also worth remembering, right, that mission stuff usually prevails over downlink events and whatnot. So right now they're working on that docking camera, right? They're working through different procedures. One of the things as well that they were supposed to do around this point in the timeline was also removing their suits, because all of the big points all of the big events in the timeline have already occurred. So they would be free now to remove their suits and be in a shirt sleeves environment, basically, like being comfortable, basically. But yeah, they could also be troubleshooting the toilet as well. So this is like, there are a certain number of things are obviously take priority. They're preparing for that rendezvous proximity operations demonstration with that camera setting up in the hatch, in the front hatch, and of course toilet as well, shenanigans notwithstanding.
Is that the toilet shenanigans? I am wondering, this might have been a thing to ask during the press conference if we had some more questions. Alex, you got me?
Yeah.
Okay. Is the toilet...
It's apparently
the
a
question,
fan that's jammed in the toilet
A fan
system.
that's jammed. Is the toilet critical for going around the moon?
Ryan, I think that you're the expert for that.
What? Why would he be the expert?
Well, it's something I've been taking an interest in. I'll leave it at that. I am not 100% sure, so please do not quote me on this. If this is incorrect information, I do apologize. I think if the toilet is like completely offline, that would be no-go for translunar injection. But if this is something that can be repaired or worked around, then that would be optimistic. Again, don't quote me on that. I'm not 100% sure, but I definitely know that you might think, oh, it's just the toilet. But I think there is mission rules, and the astronauts they need a sanitary way to dispose of their waste. I think I'll leave it at that.
I wonder, because earlier we said that the suits could sustain them for 6 days around the moon. How could it possibly be that the toilet problem would keep them from flying around the moon? I almost can't accept that as an answer. certainly,
would you want to be in that situation for 6 days, having to, do it in an adult,
I mean,
absorption
Apollo
garment?
used bags. Like, certainly they packed some packed some backup bags or something like that. I cannot envision a world in which they do not fly around the moon because of a problem with the toilet.
I mean, hey,
Am I alone?
like I said,
am I
I might
alone
be.
in this?
I somewhat agree with you there. On the other side, I can understand if it's like written into the astronaut's employment contract, we will only go to the moon if we have a working toilet. You can't really work around that.
Well, okay, wait. Would you enforce that? You're an astronaut. You've just launched on SLS. You're in Earth orbit. Would you literally say, "Nah, I'm not doing it. I'm not gonna poop in a bag or whatever. The toilet's not working. Forget it. Cancel it. Bring me home." Is that the decision you would make?
I am not a government astronaut currently
Thinking
serving
about
NASA.
You have to think.
I know, no, in a heartbeat, I would go to the moon, like whatever it takes. But again, I'm not a professional career astronaut working for the National Aeronautics and Space Administration, right? I am not on this mission right now, so I can't speak for Reed, Victor, Christina, and Jeremy.
Oh, I mean, maybe there's some, like, the toilet is a critical subsystem that has something else to do with the support or something like that. Like, if the toilet's not working, some other part of the life supports. I don't know. I don't know that that's true for sure, but I'm very curious if that would just use a shop vac. It's fine. I imagine, and I will wait for more information on this. Right.
Yeah, I'm just going to say, I've just been reliably informed by Philip Sloss, who knows much more about this vehicle than I do, than probably the rest of everybody here at NSF combined. But he says that he thinks he heard before launch they've packed enough Apollo bags for 1 day, but he's not sure if they have more.
1 day? Does that mean they took like 3 bags?
I mean, how many times do you go a day? I mean, that's a bit of a personal question, I think.
It depends on what I ate, honestly. I think that's a pretty honest answer that chat would agree with.
I mean, if you look at my X feed right now, at my latest tweet, you probably don't want to know how many times I'll be going over the next 24 hours. But look at this awesome footage from DWise.
Let's talk about the footage real quick instead.
I mean, this is part of the NSF skunk works, which you were talking about earlier, Das. This is more frames per second than you can imagine in your head. You just look at the plume interaction between the RS-25s and the twin SRBs. I mean, that is just beautiful. The rocket is moving, by the way, but this is stabilized to track the rocket.
Good grief. Do we know what part of launch this is from?
I'm going to imagine maybe a few seconds into flight, because you can see the vehicle rolling, so it's during the roll program. I'm not 100% sure exactly at what point into flight that started, but it will be a few 20 seconds into flight maybe, or before.
Look at the bottom, like not the engines, but like right above the ceiling. There's a material there for protection, and it's burning off. Look at that. Look at those flames.
It's like a blading.
Yeah, that's the whole purpose of that material. Like, you have it there for thermal protection. You want that to burn and not the thing that it's protecting, right? That's the whole purpose.
It's almost like dark smoke coming from just in this view the right of the engine bells, right? Those RS-25 bells in the middle.
I also wonder if part of that is like from the APUs, the auxiliary power units,
Houston,
the
about
exhaust.
halfway through the eclipse, we're seeing all of our power predicts right on. Thank you for the help with the power down.
Hey, neat.
Should I mention a couple of quick updates? Not really major stuff, but there are updates. So JC, they're now changing over flight control teams. Of course, they've been on console for a long time now for Ascent, and now they're going into the Orbit 1 team. Another update as well. A little bit over, let me do the math, 20 minutes from now. They should be handing over the communications on Orion from the TDRS system, the Tracking Data Relay Satellite System, to the Deep Space Network. Now, the Deep Space Network uses much more larger antennas on the ground, and so they have quite higher data rates. So perhaps we're gonna see actual onboard views if the communication gods allow us to do that. We'll see perhaps onboard views from Orion. So, oh boy.
I'm curious, is that because of a change in the orbit, or is that just a timed handoff? Like, is it the sort of thing where you have to get far enough away before you can use those dishes? Like they're too big or something? Do you know?
It's because right now, so Orion is currently in an orbit where its furthest point out there, it's well beyond geostationary orbit. It's about 70,000 kilometers in altitude. And if you can imagine, the TDRES satellites are in that geostationary orbit. For people that might not be familiar, these are satellites that are orbiting the Earth in such a way that their period is exactly 24 hours, right? That orbit, it's about 36,000 kilometers, not exactly, but, roughly around that distance. So if you go beyond that, these satellites are pointing down and a little bit sort of sideways, right? Their antennas are pointing inwards to the Earth. So if you go beyond that, you're no longer in view of those antennas. So what do you use? The Deep Space Network is what gets you that communication. And so they're transitioning in a few minutes to that Deep Space Network, because once they go beyond geostationary orbit, they'll no longer be able to see TDRES. Perhaps once they come back, because it's an orbit, and the furthest point it's 70,000 kilometers, but then it comes back, right? We were talking about that earlier, Das, where it goes out to its furthest point, but then because of orbital mechanics, it's an orbit, ellipse shaped and everything, so it's gonna come back. And when it comes back, it'll get closer to the Earth. Perhaps at that point, they may pick up again the TDRES system. There we can see some of that data, by the way, that we're talking about. Those are probably nautical miles, 5,800 nautical miles, if I'm not mistaken, right?
Oh my god.
So yeah.
Nautical miles?
And feet per
sorry.
second. Yeah.
Oh.
We gotta get imperial here, and I say this as a Spaniard.
Yeah, I was going to say.
It's like a maritime theme.
I was going to say, Das, did you just boot up Kerbal Space Program in the middle of the stream with that nav ball? But not even KSP would have such stupid units.
Yeah, for
nautical
metric
miles.
people like me, they're about almost 11,000 kilometers in altitude.
I wonder, Alex, I was sort of thinking, the Deep Space Network dishes that sort of talk to a spacecraft, I wonder if the spacecraft is too close and therefore moving more quickly, if they can even slew fast enough to track it, right? So when they're sort of slowing down, like you were talking earlier, they get to the top of that orbit, they trade the kinetic energy for the potential energy.
Quick update on what you're seeing. This is
Control jumps down.
This display is brought up onto the front screen by the control officer here in Mission Control Houston. It's called the Ascent PFD.
They heard us.
And is available at the first phases of flight. It includes toggled settings between tanking, the ascent phase on the core stage, and now the ICPS phase.
Do you think that the computers are actually tracking all this in metric, but then they change it for display? It's like in meters per second and kilometers and stuff, but then they change it to nautical miles.
The orbit burn plan is on board.
I'd really like this though, even though we're not getting like the actual views from the capsule, right, and everything. We'll get that in a bit, but it still gives a ton of data. You can see there, for example, the orbit where it talks about the current HA. That is the height or the distance to the furthest point in this orbit. So it says there right now 38,018 nautical miles, which let me grab. According to Google, this should be around 70,409 kilometers in altitude. So Orion will go all the way out there, basically, in human terms, all the way out there. And yeah, and then the HP, which will be height of perigee, that is the lowest point in the orbit, it's currently 1 nautical mile. And I'm going to tell you, no matter what kind of unit you use, whether nautical mile, normal mile, kilometer, that's well within the atmosphere. That's basically right above the surface, right?
So what does that mean? If it's one, like explain to us, Alex.
Oh, well, that's for disposal of the ICPS. It's on purpose like that for disposing of the upper stage. Sorry, have I talked over comms? I'm being yelled in the back channel. I'm sorry. I have
Oh
two
yes, you've been
different
talking
feeds
right
going on
over
right
them.
now. I'm
Yeah,
really
the two
sorry.
different feeds is definitely
Just yell at
problematic.
me the
But
next time, like
continue.
actually on stream.
We'll be like, Alex, come on, jeez.
Because I also don't know. Like sometimes we take them, sometimes we don't. It's a mess right now.
Yeah.
It's what happens when you have like 4 or 5 different voices in your head of different feeds. But yeah,
It's
for
all good. We
disposal
appreciate
of the ICPS.
We appreciate you telling us what the voices in your head are telling you about the mission. So thank you, Alex. Jeez.
I swear it's totally normal.
Okay, so to translate, we're sort of disposing of the propulsion, the other stage, the ICPS, and it is going to go back into the atmosphere while Orion, the spacecraft, continues on its way to the moon. Is that a quick summary?
Yeah, as Philip was saying, sort of in the back channel, it's also the ICPS, the orbit burn, right? You normally, for Starlink missions. Sorry, I was another update. And so the on Starlink missions, you got the second stage, the orbit burn, right? After its mission is complete. Same thing with the ICPS. The ICPS in this burn has put Orion in that trajectory, that apogee 24-hour orbit, basically, right? Has raised the highest point in the orbit. And at the same time, it allows for the disposal of this upper stage at the same time. It's going to come back and re-enter. I don't know if this puts it back on the Pacific Ocean or the Atlantic Ocean, because they had 2 options there for disposal of the upper stage. But yeah, if you're wondering what's going to happen to Orion, though, because you may think, wait. So does that mean that when Orion comes back down, then it re-enters? Doesn't it go to the moon? So about 13 hours, into the mission, they'll do another little burn for racing that lowest point in the orbit, and Orion will not be coming back 12 hours, basically 24 hours after the mission.
Gotcha. Do we have any update on? Has there been any more information on the crew downlink? Like when we might hear from the crew again?
Well,
I don't know if Alex has heard anything, but it was scheduled for around 3 hours. But yeah,
handover was supposed to happen. Let me take a look. About 9:31 p.m. Eastern. So it should be in about 14 minutes from now, if I did my math correctly.
Gotcha. So that's still coming up here, and we hope to pipe that in.
Yeah, that's the handover. A few minutes later, we may have the downlink event. Yeah.
Gotcha. Chat, can y'all hear Alex okay? I see a couple people saying they can't hear Alex very well. Y'all can help us out there. But we're
as well.
Yeah, you honestly, Alex, you sound fine in my ear. So I don't know what the deal is. Some people say a bit low, 5x5. If I'm a 5, he's a 2. We don't have to rate it that way, Eric. Jeez.
It's also late here, to be honest. It's almost it's well past 3 a.m. in Spain.
Are you being quiet now because it's like quiet time in the house?
my brother just went to sleep. He woke up actually for the liftoff, which impressed me. I saw him during the little bit side note, during the press conference. I went out, grabbed a drink, and I was like, "You're awake?" He was like, "Yeah, I woke up for the liftoff," and I'm like, "Wow." He's not really that interested in space and things like that, but I often, every now and then I tell him, "There's a big launch coming up. You should watch it," right?
Nice.
And he got up for that.
For the docking
Here
cam,
it
we
comes.
see exposure set to 1 instead of 3. We think that'll be too dark. You can set that back to 3 on rpod.doccam, HKey L4.
Copy. Thank you.
Man, setting cam exposure. I know how that goes. Having to tell somebody, like, I don't know, is Dune Cam? Do we need to like just change the exposure on Dune Cam? Freaking pad is all blown out. Can somebody fix that? They have a little bit more mission control than we have, I guess.
I just want to, I'm still amazed by the fact that
This
it's
is Mission
launched.
Control Houston.
I guess I'll have to wait.
I guess you'll have to wait.
Okay, I'm just amazed, right? So if we rewind, I'm going to get my dates wrong because I'm tired and I've been on a live stream for 14 hours, but I think it was December 2024. Then Administrator Bill Nelson, they did a press conference and they announced, hey, look, hands up, Artemis 2 is being delayed till April 2025. A few months later, NASA said, actually, we've managed to accelerate this. April 2026. I'm getting my years wrong. You can tell I'm tired. But then a couple of months, a few months later, NASA was like, actually, we've accelerated this. We think we can make a February. We're going to give it a go for February. And they gave it a go for February. But they launched from, if we go back to the December conference where Bill Nelson said this thing's launching in April 2026, they delayed by 11 minutes and 12 seconds. SLS was 11 minutes and 12 seconds later than Bill Nelson said they were going to be in December of 2024. This is a remarkable turnaround since Artemis 1.
Oh, gosh. That's reaching back into the bag.
April 1st, for that matter, as well. April 1st.
I'm still surprised they actually went for the launch on April 1st. I guess it doesn't really matter what calendar day it is. You go for the window and the vehicle and everything that's ready, but I thought it was funny.
April Fools, we didn't have a hydrogen leak.
Yes. It's been a while. I'm reading through the chat, like I'm watching chat in sort of real time here. I'm just letting it wash across me. Do some people that got the pins and stuff like that. Again, we did run out of the initial stock of pins, but we're going to get more of those made, so you can still order those. We still have patches that will ship as soon as you place your order. I am scrolling up. Mitts Outdoors, no internal cameras on the craft this time. They do have cameras, but I think our current understanding is they need to switch to that higher bandwidth network before we can get those, and we're thinking that might be coming up in just under 10 minutes now. So we're standing by for that downlink from the crew. Of course, I'm going to give them a couple minutes here or there on making that work. The real Levi is Big Red. I've seen this, and I actually have to say something about this. Levi says, miles went to the moon, kilometers didn't. Catch up, rest of world. Well, I hate to be that guy, but the computers that controlled the spacecraft were actually all in metric, and the stubborn test pilots from America that were actually riding along in the craft wanted to see them in regular old US units, so they had to convert them. So I get your joke, yes, but it was actually metric units that were doing the calculations there, and they just converted them for display. Yeah. Kiss 2 Singer says, what if they have to make an emergency landing on the moon? This craft is nowhere near capable of doing anything like that. There's not a universe where anybody would attempt to put this craft on the surface of the moon. Right now, well, not right now, but the plan is once they do that TLI burn, the translunar injection burn, they're going to put it on a trajectory that'll have them loop around the moon, but not, they don't have to do anything else. They'll get a free return trajectory, which basically means they'll loop around the moon, and then the moon will sort of like slingshot them back towards Earth with this delicate ballet of gravity working in multiple directions. But they don't have to do anything. They just get to come back down again on that free return. Now, they haven't done that burn yet. So that is, if everything checks out, life support's looking good. I guess the toilet's looking good. All the systems, batteries, fuel, et cetera, everything's looking good. Then they can command that. But we are not quite there yet. Alex, or Ryan. Am I missing anything? I'm literally just scrolling through chat, answering some questions.
Yeah.
I don't think so. I don't know if Alex has anything. I'm just patiently waiting for this crew event, so then we can get underway with the proximity operations, which is about, if there's, again, the schedule can slip, but that's about half an hour away, the proximity operations.
Yeah. You see a lot of people coming in and sort of maybe shaking hands with other people, right? That's because they're doing that handover at the flight control room there in the Johnson Space Center in Houston. And so they're now going to orbit 2 or orbit 1? Orbit 1, yeah. And so, yeah, you might actually see one of the NASA astronauts. It's on the Capcom console. I think it's called Assistant to Capcom or something like that. Rajachari, which I think you saw him at the NBL, Das. I know, Alicia was tagging me.
Yeah. We were walking and talking after the training session there. So,
yeah, because a lot of people might be wondering, like, what do astronauts do when they're not actually in space? Well, sometimes they just support other missions, right? And this astronaut is in the
integrity.
Okay, let's listen in.
we just heard the tail end of an integrity call there.
Yeah.
Remember, integrity is the name of the spacecraft. So when they say, integrity copies or whatever, they're saying the spacecraft, the astronauts aboard the spacecraft copy.
Well, so that means in 5 minutes they're going to transition to the Deep Space Network, and those are the big antennas.
All right. Well, if we get the comms call out, we will try to immediately be quiet.
Hey, Alex, you have some national pride here because right now, Dish 54 and 56 at the Madrid DSN base is assigned to Artemis 2. It's not getting any data yet, but fingers crossed it shortly. Well, Kevin Michael Reed doing a perfect job here. Look at that.
I believe they're apogee right now, or like they're heading out, flying over Africa. I think we saw earlier some of the panels at Mission Control. So, yeah, no, that they're talking to Madrid, right? The other two will not be able to talk to Orion. Maybe later down in the mission in this orbit, they'll probably talk to Canberra in Australia. Or, hang on, the way that the Earth rotates, how does it work?
Which way are they going around the Earth?
Maybe actually to Goldstone, because once they cross GTO, right, the geostationary belt, then the rotation of the Earth actually picks up or takes over, and then you've got. Am I doing the? I'm trying to visualize this in my brain.
Alex is doing orbital mechanics in his head at 3 o'clock in the morning. This is what you're watching, boys and girls.
No, you're actually not watching it because you're not seeing myself. But I was sort of looking at the ceiling and be like,
Don't bring it. You shouldn't have said that, Alex. You shouldn't have said that.
Yeah, because now Kevin will probably pull it up. But no, don't do that. We're watching the DSN.
You're just saying, oh, we're just gonna full there. Look up at the sky. Yeah, like you're thinking. Do some calculations. Do it.
Orion's much further away from the Earth than I thought it would be by now.
Yeah, this is from Artemis 1, to be fair.
Thank you, Alex.
But yeah,
See, that's
I
why
was
I
also
turned off
going to
my lights
mention...
so they couldn't cut to me. Go ahead, mention what you were going to mention.
Yeah, you will be completely in darkness right now. There you go. See, he did the same to you.
Smart. Turned off my lights. Go ahead, Alex. Sorry.
But yeah, I mentioned before they're changing out flight controllers, right? And they're also changing the PAO, so we also are in a sort of a vacuum formation right now because they're sort of handing over one communications guy to the next, and so they're changing over that. But hopefully we'll get some kind of information.
I know it's an animation, but just look how high above the Earth they are right now. They're 9,500 miles.
It's like, how far is 9,500 miles? It's tough to even understand the scale of things.
Well, I'll convert that to kilometers. That's 15,200 kilometers. That is 38 times. Oh yes, I use statute
Nautical
miles.
miles?
Sorry, nautical
Okay.
miles.
No,
nautical
no, no.
miles.
Those are statute miles. So
Oh.
this is the wonder of
So
the
they're
imperial
showing
system.
statute and nautical miles at the same time.
Yes. Yes.
Okay,
Yes.
so this is 15,200 kilometers. Divide that by 400. They are 38 times further away from the Earth right now than the International Space Station.
I was also gonna mention because I'm seeing I'm able to, well, no longer, it's no longer showing it, but of all of the different antennas that they could use for the DSN in Madrid, they're using one of the smallest ones. You see there?
Could that be for like
correctly?
inertia, so they can turn it quicker?
And also, it's closer. You
Ooh.
don't really need the big one.
That
It's
would
still
make
big,
sense.
to be fair, right? Because it's still quite a huge a set of antennas. But if you don't really need to use the bigger one it's talking to Voyager, by the way, I think, if I'm not mistaken. Kevin's scrolling by, but yeah.
Ryan,
Look at
that
the
that would
difference.
make sense. Like the slew rate of a smaller dish that's less massive and has a smaller lever arm might be better than the big
Yeah.
dishes used to talk like way out there. Like if you're talking to Voyager, it's talking way out there right now.
Yeah, Voyager 1 is on the big dish because, I mean, Voyager 1 itself, like, it has limited...
What?
What?
We have
All right,
connection.
I'm awake. Is everybody awake?
Connection to Artemis 2 on the DSN.
Is that
But yeah,
downlink?
Voyager 1... Downlink, yes. Voyager 1 has limited electricity, right? So its signal itself will be fainter.
Oh, we're blowing down the ICBS.
That is awesome. That is just so cool to see human... That there'll be like human bio data coming down that. Oh, and we've got uplink as well happening now from Dish 54.
There we go.
Nice.
Two-way communication.
This is a website, by the way. Some people might not know about a DSN Now, but this DSN Deep Space Network website, you can actually go there and it'll tell you what the different dishes at the different sites around the world are talking to. You can click on one and you'll get more information about that mission. Sometimes you see them talking to Mars orbiters and that sort of stuff. Sometimes they're talking to the ones that are way out there, the deep space probes.
Juno
on
the
spacecraft. Oh, we have Juno? Nice.
Yeah, the one at Goldstone, the one that is sort of doing the two-way. I can see there it says JNO. That's Juno.
Yep.
Out in Jupiter.
But this is it's just a public website. Like if you go and you just type DSN Now into a browser, it should come up and show you the right website. But it's just available for anybody to go and check out. So you might be able to.
Can we scroll on the information to the right? Because this is also very very interesting on the DSN website. Because you can actually scroll and it gets you information. My preview is too small resolution. Hang
So
on,
is mine.
hang
I
on.
can't read it.
Yeah, I'm actually watching it on YouTube. I'm sorry. Yeah, so it tells you things like about the antenna, like the azimuth, the elevation, and everything. The wind speed, even 6 kilometers per hour. But it also tells you like the distance, the round trip, light time. Of course, as Orion goes further out. Thank you, Kevin.
Enhance.
Very understandable.
Integrity, Houston, voice check on DSN.
Hey.
There we go.
I hope Houston heard them.
Has you loud and clear on DSN.
They just have some
And we
comms
have
delay.
you loud and clear as well, and while we were handing over, ICPS was in blowdown.
Nice. Part of the safing of the upper stage.
And we can see here in this zoomed in view, the gentleman at the
Copy
top.
all,
That's
and we have 2 GNC cautions on the board for right RHC. Let us know if you see them.
Copy, Christina. We're seeing the same. We think we might have a channel failure. We are taking a look.
the gentleman you can see at the top is Jeff Radigan, lead flight director, and the gentleman at the bottom is Roger Chari, who's Capcom.
Assistant to the Capcom.
assistant to the regional manager.
You got the joke. Yeah, it's the woman. I forgot her last name. Her name is Amy. I'm really sorry, Amy, for not remembering your last name. But yeah, she's the Capcom. Raja is sort of assistant to the Capcom.
Is there a so the call we just heard? There were 2 warning lights or warning indicators, and they were confirming that they were also receiving those on the ground. Did I hear that correctly?
I defer to Alex. I'm sorry.
Yeah, I'm gonna be honest. Some of these things are too technical for me, right? Also because I'm not too familiar with the Orion systems. It's not like they are out there, right? And so I didn't fully understand some of the acronyms that they actually used there. They were talking about some failures or something like that they saw or whatever. I really can't remember right down the specifics, but I know that as it was being relayed, I did not understand much of it, to be honest.
Gotcha. Okay.
Cannot know everything.
And we're still standing by to see, now that they are on the DSN, are we going to get a crew downlink? And we are very curious to see...
Integrity Houston for camera streaming.
Aha!
Ooh.
That specifically!
Go
Here we
ahead.
go.
Camera stream.
All right, we are ready to join you on board if you're ready for us.
Yes!
Let's go.
Yeah, we're also ready here, NSF.
NSF is go.
Let's go. Go ahead for camera downlink.
Let's go on board Orion Integrity.
Chat,
Chat
now
also
you know
saying we are ready.
you know what you've gotten yourself into
We
if
are
you're
ready
still
for you
watching.
to come on board.
Let's go.
Copy. We'll let you know when we join you.
That's a usual thing. Like you'll sometimes hear the mission control ask for permission to come on board, like to bring the cameras up. I don't think we're going to show it publicly. I think it's like a privacy readiness notification sort of thing. But you'll hear them say,
Here we
come
go.
on board. What do we have here?
Oh?
We should have
I
sent
see
them
a
a light.
tablet.
For the first time since
Does
they
someone have a
arrived
torch?
in space, you're looking at a live view of the Artemis 2 crew in the Orion spacecraft.
Am I now?
Turn on the lights.
Do a shadow puppet in front of the tablet or something. Was this that exposure setting on the camera? Do they think that exposure setting was going to be too dark? I concur.
In Contact, they said they should have sent a poet. I think they should have sent an electrician.
They should have sent him a light.
Flashlight.
They need to turn on the flashlight on the tablet and hold it up to their face.
I will just say very briefly that they've just passed 10,800 miles, and that means you could fit between Earth and Orion. You could fit an entire planet Earth with 1,200 miles of margin each side to spare.
Can you fit
And room
also
for
the
that
moon
tablet.
and Earth?
The crew inside Orion is continuing to configure the cabin and prepare for the upcoming proximity operations demonstration, which...
You know what? Maybe that's why the lights are dark.
Like,
They need
by
to look
configure
out
the
the
cabinet,
window.
they mean look for the light switch? No, Alex, seriously. So with the proximity operations, is that really a thing? Like, are they going to look out the window?
Yeah. They'll have a rangefinder. So both Christina and Jeremy, they'll be looking out the camera. And they'll have a rangefinder for this, actually. Yeah.
All right. The rangefinder is to find the distance back to the ICPS that they had disconnected from, right?
Yeah, because they're going to be pointed at the ICPS, right? At some point in the proximity, in the rendezvous proximity operations demonstration, the RPod.
Another tablet has appeared.
Yeah.
So we didn't talk to. Oh!
Here we go.
Finally.
I just want a quick comm check. Can you hear this transmission?
Loud and clear, Reed.
All right, Amy, welcome on board the Integrity Spacecraft. We got, right now, myself and Christina are in seats 1 and 2, getting ready for rendezvous and prox ops demonstration. Victor's just finishing up getting out of suits and getting suit drying going, and Jeremy is hard at work in cabin configuration. It was an amazing ride uphill. The views, we've got 2 moon rises that we've had so far, and the views of planet Earth. We've circled it completely, and we forgot how beautiful it is to look down on Earth.
Nice.
Wonderful, Reed. It's spectacular to see you all, and so far so good with the day.
Okay, this is cool. All jokes about
the welcoming the world on board Integrity, and we're looking forward to a good rendezvous and prox operations here in a few minutes.
And on that note, Reed, we have the prox ops pad whenever you're ready to copy.
Nice. All joking aside about the lights, getting a live feed.
We'll be ready to copy.
Nice.
Standing by.
Getting a live feed from the spacecraft like this is very cool. Now they have the bandwidth on the DSN, and they're sending us this live video feed. Sort of looking back over the shoulders in the seats here. You can see their tablets and stuff.
I mean, I'll just say one thing. We had this view during the countdown. It was like 5 FPS. This thing's 30 frames, silky smooth, and they're 11,000 miles away from Earth. The feed is better than it was on the launch pad. This is crazy.
Yeah, actually, I remember back before the launch, we were talking about, Reed is the commander, Victor is the pilot, Christina and Jeremy, they're the mission specialists. And somebody mentioned in the chat that actually there's not a pilot because this thing is automated, basically. And I don't think they know that this actually is going to be manual.
Welcome to the Artemis flight control room.
Hi, Leah.
Oh, hi.
So Victor Glover will actually be piloting this. He's going to be at the controls of the capsule during the rendezvous proximity and operations demonstration, RPOD. Now I know why they use the acronyms. Because it's a lot easier to say RPOD.
Look, sometimes we accidentally talk over comms, but we don't break into the live feed from the spacecraft full screen with ourselves, at least.
Yeah. And we can see now that Victor has floated up to
Integrity, all times MET. ICPS maneuver to SEP attitude. 3 hours, 18 minutes, 34 seconds. ICPS SEP. 3 hours, 22 minutes, 24 seconds. ICPS thermal turn. 4 hours, 03 minutes, 34 seconds. Depart no later than 4 hours, 30 minutes, 37 seconds. USS 2 TIG.
Just 1 second.
Depart no later than 4 hours, 30 minutes, 37 seconds. USS 2 TIG, 4 hours, 50 minutes, 07 seconds. Mandatory burn. ICPS disposal burn, 5 hours, 00
Okay,
minutes,
Amy, we copy all, and we are hopping
second.
over to
How copy?
13.1.100 Prox Ops FTO, and confirm you hear this transmitter loud and clear.
Confirmed loud and clear.
All right, did we jot all those down?
I was.
I think
I was actually.
Yeah.
Yeah.
Can you share it with me so I can put my spreadsheet,
exactly.
Alex?
Yeah. I was actually updating my spreadsheet. Yeah, I have a spreadsheet here of the timeline.
Has their own
updating.
spreadsheet.
Yeah.
I
So, yeah,
found the depart no later than, like they're going to do the prox ops and then they have to get out of Dodge? Like they're going to need to do the next burn, Alex, or what?
Yeah, so after the RPod ends, there is a separation burn that that is going to happen, as they said, 4 hours, 50 minutes, and 07 seconds into the mission. That will be, if you're
Mission
keeping track,
Control,
at
Houston, just hold
11:25
go for the
p.m. time and 19 seconds, if you like, all the
And
way
the crew
down
aboard
to
Orion is
that.
Yeah, it sounds like they just pulled go for the ProxOps demo. I think that's what we heard.
Yeah.
But the
Sorry.
other things, go ahead.
I was going to say, in my attempt to try to jot down all of these numbers, I actually rewound the live stream. So I
post-BFS engage actions open on step 2.1, but we are taking no actions in that procedure. Moving on.
Copy, and I have a story on the right RHC when you're ready to hear it.
We'll call you in 2 minutes.
Standing by.
Is it me, or are the comms from the spacecraft clearer than the comms from the ground? Is it the other way around?
The comms and the video are better, and they're 11,000 miles away. Can you believe it?
They're still going up, aren't they? Like they're 11,000, but it's still climbing?
Ooh.
Oh, yeah, 100%.
Thank you.
Wait, is that the moon? Or is that debris peas there?
I can't tell.
A little flashy
Like
pixel?
ice.
Oh, no, it's
Maybe
ice.
ice.
Look at that.
Yeah.
This view coming live from Orion, now just 3 hours and 10 minutes since liftoff today from Kennedy Space Center.
All right, well, just I think there's just little particles floating away. I don't think we would be properly exposed to see stars in the background there with those bright, sort of blown out parts of the spacecraft in the foreground. But a couple different things in the timings there. You heard him say the ICPS SEP, because right now they're still connected, but as part of getting ready to go here, they are going to disconnect from the ICPS, and that's when they start the ProxOps, because that's what the ops are in Prox 2, right? Like it's proximity operations, but
Absolutely.
It's because the spacecraft Orion is still in proximity to the ICPS, and they're going to sort of like fly around the ICPS, almost like flying in formation with each other after they separate. They've like given themselves a little maneuvering target, right?
They're basically going to pretend ICPS is a lunar lander and pretend to dock with it. They won't touch it, obviously.
No
but
booping.
This is to no booping, not like you can in KSP. But this is essentially for Victor Glover, who will be at the controls of Orion, hand flying this spacecraft. This is so he can report back to the ground how Orion handles, and that experience will drive the future Artemis missions, Artemis 3, which will be rendezvousing with one or both of the lunar landers from SpaceX and Blue Origin, Artemis 4, which will have to dock with one of those lunar landers to conduct a landing, and beyond, when we're going to be docking in with lunar landers. Not docking with the Gateway space station anymore, at least not for many years, because it's quote-unquote paused, and assets are being quote-unquote reallocated, but still useful for the lunar landers.
That we've said ProxOps so many times, and I don't think we really explained what the ProxOps were.
I'm sure at some point.
Checking.
We're checking something.
Yeah.
Again, we'll start.
But those are what the ProxOps are, the proximity operations. It's almost like taking Orion for a test drive, like taking it for a spin, making sure all the controls are doing what they expect.
Yeah.
Maybe we should say integrity
As we get closer to the
Orion.
ICPS conducting these maneuvers, the target that they will be reading back switches to the docking targets that are on the interim cryogenic propulsion stage.
Yeah, I was listening to that.
I was listening to that.
No, but yeah, it's basically what Ryan said, right? They have targets on the ICPS on that upper stage. So once they separate, they'll burn a little bit to sort of separate in the forward direction, right? Because they separate from the front of the upper stage. There's one
Reed,
target
for the right RHC, it looks like it was a single event upset. We are now seeing all good channels. We did command a fitter reset from the ground. We do have a quick checkout that you could perform if you feel that you have time.
We are showing on right-hand controller, RHC pitch, channel 3, deselected.
You can see the solar arrays turning to point at the sun.
And we expect that. For the checkout, you're going to confirm CSS is not selected and then do a full deflection positive pitch, then negative pitch.
Okay, so the right RHC is powered on, control stick steering is not selected, and you want a full negative pitch and a full positive pitch.
Affirm.
Just talking through the commands they'll send.
Here is a full. Here is a full negative pitch. It is now 0, and here comes a full positive.
Copy, we're following.
Are they sending commands without firing?
Yeah, Alex, I think that's what was going on.
Copy, that's a good checkout, and we'll do the reselection of the channel from the ground, and you are go for Orion 180 pitch, ATP, and Prox Ops FTO after set.
Let's go.
Yeah.
It sounded like they were checking out the joystick.
Yeah, like a quick test drive of the test drive.
Well, making sure that they were seeing, it sounded like the ground was making sure they were seeing the control inputs from the joystick without actually connecting it to the thrusters, if I had to sort of translate.
I guess that's to follow on your comparison with the test drive. It's like getting in the car and sort of wiggling the steering wheel, right?
Yeah.
Sort of checking out how it works.
And this isn't something that only happens on Spacecraft, because this is really nerdy, and I apologize if we lose all of our viewership here. But for example, on Airbus aircraft, if you move the side stick while you are on the ground, on the flight display, on the instruments, it will show the joystick moving. So I assume this is going to be something similar.
Yeah.
Nice.
I got you there. I know you also like aviation stuff.
See, I'm older, so it's not exactly the same, but it's like if you drive a manual car, like a stick, and you want to make sure you're in neutral, so you waggle it around, and you're like, yeah, all right, it's in neutral. It moved around without commanding anything.
Yeah, when it's neutral, you're like, yep, it's there. Should be under 6 minutes now for that separation of Orion from the ICPS.
Yeah.
Yeah.
ICPS from the.
Listening in.
We might get some. Yeah,
Once that thermal turn is complete.
Okay.
Who's doing the sipping thing for Kevin?
But as Alex was usefully taking those notes earlier, if you missed it, the time for separation is 3 hours, 22 minutes, and 24 seconds. So obviously there'll be a delay, I imagine, to the video feed, but keep an eye at the clock in the top left. 3 hours, 22 minutes, and 24 seconds. That's separation.
I wonder if we'll see anything. Like, when it separates, will we see solar arrays flex or anything like that?
If it's anything like Artemis 1, I believe so. I believe on Artemis 1 there was a bit of a jolt when Orion separated away from the ICPS.
Yeah, because they do. You want them to actually separate. They don't just disconnect and then like stay there touching each other.
Yeah.
You do want them to move away, right? So we might see a little boing on the solar array, or a little bit of a vibration or something like that. It'll be really interesting. Go ahead.
I was going to say, I hope we get the same views that we got from Artemis 1 when they separated from the ICPS. We got a view from the solar array wing camera, the selfie cams. The same one that it's my background we were showing before, right?
Yeah.
And you can see... Go ahead, Ryan.
I was going to say they had cameras literally at the end of the solar arrays, and they were using the solar arrays as selfie sticks, and that was awesome. So fingers crossed those return for Artemis 2.
I guess we'll find out.
The plan is to keep it installed during the crew sleep period, but they will remove it during crew wake since it keeps the crew from observation and photography out of that window.
What, the selfie stick? Was she answering us?
I wonder if they're talking about a shade. Look at this solar arrays!
Wow.
Look at that!
All of the wiring.
Wow. That's beautiful engineering.
Ryan, did that... Was the solar array moving and caught the sun all of a sudden, or did the sun come out from behind something there? I just saw it appear
I think
all
the
of a sudden.
spacecraft could be rotating, because you can see the shadow moving on the spacecraft.
You can! Yeah, you can see the shadow moving. If you're wondering what we're looking at, this is a camera that's...
One on the Peltor headset.
Loud and clear.
Okay, I have you the same. Calls requesting a response will be prefaced with Houston. All other comm, no response required. Houston, how do you copy that?
We copy. We're ready.
We are ready. Just some words on my configuration. I'm wearing my ox suit boots, and they're clipped in to the seat 1 foot pan to give me some stability. I've got the shoulder straps of the harness on tightened, holding me down to the seat pan, so I feel really stable for actuating the rotational and translational hand control.
Nice.
I do just have one thing to note. I
Glover
don't
letting
want to
the
step on
teams here on
comms.
the ground know that he doesn't expect a response from them.
We're currently ICPS. Next phase 245. Our next action is in about 2 minutes.
Does everybody understand what he just said there? He was describing how he was strapped into the spacecraft. And why is that important? Because when he starts commanding motion, if he's not attached to the spacecraft's going to move around him. Like is a little bit, imagine like you're driving in your car and you didn't have your seatbelt on. You shouldn't do that, by the way. But you slammed on the brakes, you'd go forwards, right? You'd feel like you're going forwards. The spacecraft is the same thing, but it can move in 3 dimensions. So if he told it to back up, he would start to float forward in the spacecraft and like bump into the controls. If he told it to go or if he told it to go backwards, forwards, I think I said that backwards. But if he told it to go forwards, then it would sort of push him into the seat. So in order to maintain control,
start timers.
Christina Cook is floating to Victor's left. She's in charge of the timing and procedural discipline. Jeremy Hansen.
Solar array cam.
Yes.
Hansen is floating to Reed's right, watching the ICPS, ready to call a back away if need be.
Expecto.
Standing by for separation.
To back you up, Daz, real quick, Victor will be very talkative during this procedure because he needs to relay the feedback.
Yep.
Yeah. Victor's mic is going to be hot micing. He's on voice activation. He won't be on push to talk proximity operations.
Makes sense. He just has to be strapped in so the spacecraft doesn't float away from him and he like loses the controls, or even you pull on a control stick trying to stay in position. You don't want to do that because then you would send a command to the spacecraft. It's like the footage of the motorcycle where you're trying to stop, but you grab the throttle and the motorcycle goes more because you grabbed the throttle. You know, you're not supposed to do that. Same sort of.
There we go.
Yeah. Look at that.
That was so cool.
Confirmation, separation from the interim cryogenic propulsion stage.
Good motion. Go for 180 pitch. Confirmed. Separation confirmed.
Shadow.
Houston, copy.
Come on.
All right, here comes the pitch rate.
Is that the docking camera?
Flip off. Oh, look at that.
Wow.
So they're going to do a 180 degree, meaning they're going to flip all the way around, like turn around.
I have no stop stream option.
Inside.
Ooh.
There's Victor on the left-hand side. He's hand-flying the spacecraft.
Nice. That was a fair amount of impulse that they... I didn't expect it to be that much of a buoyant.
They're being lit up by the sun.
And they're looking at it. Like
I see the moon in the camera, and now I see ICPS in the docking camera field of view. Okay, waiting for 550. I'm on the THC. There's 550 starting the 19 and
Donkey camera.
This is the view from.
Look at that.
This is the view arrow. The docking camera is showing the crew inside Orion.
In the future,
XMRC
this will be.
enables. Caution, prop, SM, RCS, manifold 3, aux P health.
Oh.
Much quieter. Got a little rumble
Checking.
like we're driving on a rocky road, but much quieter than in the sim. I'm showing about 3 degrees wide on ICPS. And it's holding right near the center.
Integrity, no action for you on that enable prop caution.
No action.
No action. No big deal, they said.
All right, still waiting on the 19 inch to burn out. Thrusters are still fine. We've got a little rumble. It's like driving on a rocky road. All right, burned out.
So cool.
Okay, I see about 2.6 degrees wide on ICPS. All right, zooming in. There's 3x. 2.7 degrees wide. Here goes 6x zoom.
Enhance.
Enhance.
To me, like we might
Enhance.
have even slight closure. I definitely don't think we're opening.
He's talking about moving towards it or away from it.
Okay, 2.6.
I believe the degrees he's calling out are how much.
2.6 degrees.
Copy.
Do y'all think that's the width
Look
that
at
the
exposure
ICPS is
difference between
taking
2
up?
and 3. That's 3. It's quite washed out. When I go to 2, I can see the docking target. I'm going to leave it at 2 for now.
There it is. The docking target.
The degrees
They've
Glover is
actually had.
reporting.
3 outpulses.
Whoa!
One,
I didn't realise there'd be an
2,
actual target on the
3.
stage.
And it again is that rumble, a little bit of a rumble from the service module. I hear them still burning. It looks like they just burned out. And I'm seeing opening. We definitely have opening. 1, 2, 3, 4 impulses. And so far, what I can tell you about this is it's much tighter than the sim. There's not a lot of lateral movement, not a lot of rotational movement as these are burning out. ICPS is nice and stable in the camera field of view. It is 2.5 degrees wide, and we should have a slight closing rate.
Tighter than the sim.
Yeah.
There's a
And
half
2.5
degree
degrees.
below the center of the docking cam. It is 2.5 degrees wide.
2.5 degrees wide. You could tell how if you know how big something is and you know how many degrees of your
it's quite nice and very responsive. And the camera
degrees
is also better than what we were flying in the sim. I'm getting very slight movements, so it's making it easier to assess opening and closing. This camera is much better than the sim. We will be less than 4 degrees. I'm going to start left since it's just to the left. So here comes 2 left. 1, 2, left. Good motion. Looking for 1 full degree, so I'll start at the center. Hack. ICPS is centered, waiting
There it
for
is.
1
It's
degree
moving.
to the right. Now I'm going to give it 1 down, if that's okay.
Yeah, center it. Nice.
All right, we still got good motion. Giving it 1 down for correcting ICPS towards the center.
Like he's listening to me.
All right, and then when I get 1 degree of motion, copy. There's 1 degree hack. 1, 2, 3, 4 rights. 2 lefts to center. Copy. Again, very responsive. Authority
Look
tab
at
is quite responsive. It's very intuitive. I got about 1/4 of a degree, maybe even less than that, of overshoot by starting at 1 degree of movement. And I've got good motion, 1/2 degree back toward the center line, and I will capture it with 2 lefts. I'm going to lead that by about 1/4 of a degree. Here comes the first 1, 2, and I'm going to give it, I'm going to let those down slowly correct themselves. So, all right. Again, that little rumble, it's like a very slight rumble, like just driving over a little slightly rocky road, and the 2 lefts are in. We've stopped on the center line laterally and vertically, waiting for it to correct back to the center. Here comes 2 downs.
Folks.
1, 2. Start counting at the center.
This is a human being manually driving a spacecraft.
Houston, Ike keeps talking about the rumble, and I think from the previous spacecraft that we have flown, Soyuz and the SpaceX Dragon, we're used to a more distinct popping sound out of the thrusters, and this is just more of a gravelly road, kind of very calm. There's not a lot of dynamics on board. Very smooth vehicle.
1 degree of motion. Here comes 1.
Copy
2,
observation.
3, 4, up. Okay, there's a 1/4 of a degree overshoot, maybe 1/3 of a degree, and we've got.
I'm so jealous of Victor.
Stopped.
Compared to the other spacecraft we've flown.
This one is taking a little longer. Motion is tracking back the other direction now. We'll go 2 downs to center. We also had an up correction going in, so I think I didn't take that out before we started this. That may have contributed to it overshooting a little bit more than the previous.
Do you think it has SAS turned on?
Yeah, we started with a little bit of Z motion due to that correction earlier.
Mech jab.
Mech jab.
Yeah.
You can do this in Kerbal. Like
all right, half a degree to go, and then we'll go 2 downs to stop it in the center.
Seeing the target move around the screen like this.
We'll probably only need 1 down to stop this. Okay, gonna put that in now. There's 1 down, and we are centered.
This is exactly what you do to line up to dock.
Houston, integrity translation checkout complete. Moving to step 7.
2.5.
Copy.
Like if you were connecting your Orion to the top of a starship.
Equal.
This is exactly what you do to line it up. This is too cool.
It's giving me chills because all I can imagine is, next year, hopefully,
back to that step.
Starship or Blue Moon instead of ICPS in this view.
Yep.
Okay, I'm good.
The target that we see, this isn't a...
ICPS diameter. We do have the opportunity to do 1 in pulse, but we are going to hang here for now.
Copy, concur.
That's the stage that launched with them. This isn't a separate launch on a separate day or anything like that, like we did with the Gemini back in the day.
All right, control stick steering. Engaged. Hold inertial. Diaphragm is ref. One degree on the rate scale set. Just trying to get that docking target background. So I'm going down exposure 1 now. I can see the docking target clear.
Yeah.
Ready.
That is the ICPS, y'all. This was connected to the bottom of their spacecraft, and they separated the two.
Right, coming in. 1, 2, 3.
And
Good motion. 2 for 17.
Start to drift a little bit.
5 degrees for 17.
Yeah.
See the roll?
Yeah.
Right, no cross coupling, no rate in other axes. 10 degrees for 17. Good motion. See ICPS center docking target 12 for 17.
The degrees you hear Glover reporting are the amount the ICPS is taking up on the docking camera, which you see in the left side of your screen.
All right.
Yeah, we said that like 2 minutes ago.
Is at 0.
At some point, they're going to be going over to the side of the ICPS. There's another target there.
Yeah, yeah.
This one is the easiest because you just have to turn around.
Yep.
But then you have to translate. That's another step
Give
forward,
me
right?
Down, one left.
More work.
You're going to have to circle strafe around it 90 degrees.
Little gravel road.
Copy.
Can I say something?
And we got another momentary enabled caution prop SM RCS manifold 6 OX P.
No impacts to ProxOps demo. Good to continue.
All right.
Can I say this is cooler than the launch was?
Point 2. Set.
Is that a bad opinion? Like, I really do think that this part here for me...
ICPS and get stable. I'm going to go up. I'm going to go Wait.
Is cooler than the launch.
Okay. Roll right and hold. All right, roll right. It's coming in. Roll good motion, no cross coupling. It's only roll rate. I see
Kekis in chat
ICPS
and he agrees.
2 for 5.
Yeah. Like we see lots of launches. You don't see this. This
slow,
is very
easy to anticipate.
Rare.
And stopping at 5. Was able to stop right at 5.
For those keeping track of the timing, we still have about 50 more minutes of this demonstration underway.
Oh, sorry. Okay, going left. Good motion. It's all roll.
Oh.
Was that 55-0, Alex?
And pitch or yaw. 2.
Or 1-5.
Yeah, 50 minutes. 5-0.
50, gotcha.
Roll,
until about
released, it's 0.
4 hours, 30 minutes.
Back to the center. Roll is slow, but nice and predictable. Easy to anticipate and stop with precision.
Yeah. Lance Anthony, this is a computer screen. It's a camera that they're seeing. Victor Glover manually piloting Spacecraft, but that is a camera, and it is something that they can see.
Ready. Going edge key. Pitch is in pulse. It's just greater than half a degree low.
Yeah.
3x. Pitching up 1 pulse. For 1 degree. Pitch up. Nice and snappy. And there's 1. Anticipated. Stopped it right on that 1.5 degree line. Okay. And returning it to the pitch down. Stop just greater than half a degree low. Stop. Very nice.
Look at that.
Pitch was very tight, very responsive. I was able to stop it right where I started it.
That's so crisp. Now, again, they're not actually going to make contact. What Victor's doing is feeling out the controls of the spacecraft. Just making sure it responds the way he expects.
Pitch up and hold. All right, pitch up.
And look at that.
And very responsive, also and discreet. Pitch down and hold. Back to initial vertical position. Stop. Captured. Very nice.
He's even saying when he's commanding it, like starting it, stopping it. Yaw, it's going to go side to side now. Watch.
This is incredible.
This is too cool.
A good motion.
We are.
Yes. All right, and yaw.
Oh my God.
Pulse and stopped it right at 1 degree. Very responsive in yaw as well.
I feel like I'm sitting in the seat next to Victor as he's calling out these movements. The amount of detail we're getting from his communications.
1 pulse, good motion, no cross coupling, and 1 degree. Stopped, overshot about 1/8 of a degree. Back to original position.
He's giving it these little pulse commands. He says pulse, right? Pulse. Over and over again. You don't hold the controller to the side. You would keep accelerating. You turn faster and faster. So what he's doing is just like
right and hold 1 degree. Good motion, no cross coupling. 1/2 degree. There's 1 degree stopped and overshot about 1/8 of a degree. But nice capture.
He's just doing little pulses, and then you let it drift.
Not sure. It's most likely from us, the camera, or this vehicle wobbling in yaw. So ICPS is moving. It's wobbling left and right slightly in the camera view. It did stop at the 1 degree of motion quite precisely, but we got this bobble just now, going back to initial position by yawing left and holding. While it's yawing, it is solid. There's no bobble. Stop. Released. See if that bobble comes back. There is a slight bobble, maybe dead banding or just the camera or the vehicle fluctuating. Are you guys seeing that, Houston? Are you seeing the bobble in the docking cam video?
Victor, we are not, but it might be because it's low rate for us.
Like a bandwidth issue or something.
A little bit of a lateral oscillation there.
Houston, authority, DAP checkout complete, ready for step 12.
Copy, go to continue, and also, once you get there, you are go for forward target approach to 10 meters.
So they're going to approach.
Integrity.
They're going to close. They're going to get closer to it. They've been a little bit further away. I think this was in 3x. If I'm not mistaken, there's a little bit wider camera view. And if I remember correctly, they've zoomed in a little bit here. And then there was another wider one.
It is showing course. 16 in, starting now. 1, 2, 3, 4,
It's going to get bigger. Watch.
When he says 1, 2, 3, 4, 5, you can see him pressing the joystick on the left
15,
of the picture-in-picture.
Houston approach was initiated from approximately 2.7 degrees.
All right, I'm going to give it 1
Copy,
down.
2.7.
Everything
we're coming
here
up on 3 degrees wide. Stand by for 3
slow
degrees.
and steady.
Hack 3 degrees wide.
Getting bigger.
Yeah, getting bigger. It's
Gave
how
it
many
1
degrees?
Down. It doesn't seem to be tracking down, though. I'm going to give it 1 more down in course.
Of the field of view it takes up. So it went from 2.5, 2.6 to 3. It got bigger.
1 left in course as well. Good corrections. Good. Are you okay?
This view live inside Orion.
Field of view, do you need any lighting adjustments in the cabin?
Cab camera looks good to us. Thanks.
Integrity.
Hack will be at 0.5 degrees wide. Stand by. Hack 3.5 degrees wide at 1823.
Yeah, the bobble
The
is
crew
a technical
received to
term.
go
Max.
to move in towards 10 meters away from the interim cryogenic propulsion stage.
Yeah, sure.
Look at that. They're just coasting towards it.
Again, pilot Victor Glover flying the Orion spacecraft right now.
Hack will be at 4 minutes. I'm sorry, 4 degrees wide.
This is all to teach us about how Orion flies manually in space and prepares us for future missions when we'll need to dock with a lunar lander.
Yes, yes.
Stand by for 4 degrees wide. Hack.
It's getting even
4
bigger.
degrees wide at 19.
It's gone from 3 degrees to 4 degrees. On his screen, he must have
And here comes 10 outs. 2.
some markers or something like that he can see that we're not seeing. It's like we're getting the raw camera feed, and he's got some additional markers that he's able to measure.
ICPS is still stable. That little wobble, lateral, a little yaw induced. Again, can't tell if that's the camera or the vehicle, but overall it's pretty stable. Very, very minor oscillation.
Houston, 75-meter braking is complete. Going into dock cam exposure check.
Copy.
Copy. You got it.
It's not just the camera either. Jeremy Hansen is actually looking out the window right now,
out the window.
keeping an eye on the stage with his human eyes. He's doing analog calculations.
1950.
The old Mark 1 eyeball. Do you think he's got any grease paint on the glass so he can measure things?
Good old Apollo days.
Uh-huh. Look at him changing the exposure there.
All right, coming up on 5
No
degrees
way.
wide.
5 degrees. It's just getting bigger.
5 degrees wide, 2020. Okay, next action is when the center docking target is 1 degree wide. It is about half a degree wide right now.
It may seem
6 hack, 24, 6 degrees wide.
may seem silly, but
Fine,
it's
I'm gonna
true
go
that
up. 8.
sometimes eyeballing it can be good in a manual situation, right? Like your autonomous docking system fails,
Copy, going course
and you
want to
dock.
out. Your course,
Your eyeballs do
1
that.
out.
The amazing Kevin Michael Reed has given me telestrator access, boys and girls. I'm gonna,
Up. Stand
if I
by for
circle
6.5
this,
degrees
That's the joystick Victor is using right now.
Excuse me. I may have skipped on you. 5.5. Heck, that's 5.5 degrees wide. That may have been the reason we thought I skipped one on you. I skipped 5. One up, one right. Okay. All right, course.
Nice.
We did a mistake in slowdown, so going back course and one in. Not as far ahead as we thought we were.
When he says course, he means bigger control movements.
All right, coming
As
up on
opposed
6.5. Back. 6.5 degrees wide. Fine. You're fine. Going up. Up. 2 ups. And 6. Good grief.
I think they're listening into the stream now, so I think they're listening in.
They're listening in. Good grief.
Hey, feedback is feedback, okay?
Yeah. Again, they are not.
I'll give you 7.
They're not going to dock. They're not going to intentionally make contact here. They're just giving it the old test drive. If they tell it to go forward, make sure it does that. Target gets bigger. They tell it to stop.
7 degrees wide. ICPS is 7 degrees wide. Hack. 2245. All right,
tell it to
ICPS,
stop.
the center docking target is about 0.7 degrees wide.
Nice. It stops getting bigger. They tell it to go left. It goes left.
5, correct?
Look at that.
All right, 7.5. Hack.
Right on the money. You can see the center target.
Right.
Oh,
Pretty much
yeah.
center of the screen.
Right about
That is
7.5 degrees wide on the center docking target.
some fantastically fine control here.
Left and fine. 8 degrees. Hack. 2322.
Again, this is hand flown. Victor is
All right, I'm
hand
gonna transition
flying this
to
approach.
Center docking target.
Yeah.
0.8 degrees wide. The next action will be course and 6 outs when it's 1 degree wide.
6 outs, I believe,
There's
would
something
slow
floating to
down.
the right of ICPS. Did you see that float off the screen on camera view? 0.8 degrees wide. Quite large. All right, I'm going to course.
Big control movement.
9 degrees.
Target's getting
1
bigger.
degree wide. Here comes 6 outs. 1, 2, 3, 6 outs.
Houston, 30-meter braking complete.
Copy.
This view from Orion's docking camera looking at the interim cryogenic propulsion stage. They have completed their 30-meter braking and are flying in towards 10 meters away.
It's already
Look at that.
out of the field of view of the camera.
Copy.
Yeah.
Looking for 2.5 plus or minus a quarter of a degree.
So he set the spacecraft to coast towards the target, and then he went out. He told it to slow down.
It's about 1.2, 1.1.
This is why he's the pilot. He knows how
Yeah.
to fly this thing.
I want to do this.
Me too.
I feel like I've done this enough in Kerbal that I could do it here. It's all the other things like,
This
run
view from
15
the
miles
docking
without
camera
stopping.
is a zoomed-in view at this time.
Couldn't do
Again,
that.
we are coming in. We were at.
There's some other physical tests I'd have to go through, but I feel like I could control this and do this.
You know how
Docking
SpaceX made the
today.
SpaceX made the Dragon docking to the ISS simulator? NASA needs to make one of these, but for ICPS operations.
Yeah. I see a PS Proxops. I like it. Can you do this? You have to do this in order to be an astronaut pilot.
Reed found that funny.
I would apply. And they'd be like, yeah, you're
We have
hell.
1.5 degrees
so
wide
great.
on the center docking target. Nice and smooth. It is actually holding quite close to the center, so I haven't had to make many corrections. Nice and stable so far. We are at manual exposure 1, which is interesting. I don't know what the sun angle is right now, but that seems to be the best view.
Look at that.
You can see the target view, the vertical sort of thing, right? The grid that they use on the right panel there at the bottom of that right panel.
The bottom right,
and so they have that view, and they know exactly how center or how off center that target is. And so when he says it's bang on, it's like it is. You can see there. The big circle is sort of the adapter, right? The smaller circle is where that adapter is. Excuse me, the target is. But yeah.
This is the camera view.
2.5 plus or minus quarter of a degree to be, of course, 4 outs.
Of course, 4 outs is slowing down again. They slowed their drift earlier with the 6 outs, and he's going to slow down even more.
Put up to the window and see it out in front of us.
You're jealous, Victor? Really?
You're getting to fly the spacecraft, dude. I'll take over if you need me to. It'll take me a little while to get there, but
yeah, get me up there.
Coming up on 1.75 degrees wide.
This view inside Orion as the crew is using their iPhones to take pictures out of the window of the
1.75 degrees wide at 2740.
You weren't supposed to identify the phones.
They're able to see the interim cryogenic propulsion stage outside the windows.
10-meter arrival. So once we get to 2.25 degrees wide, we're in the window to start braking. Course and 4 outs. Coming up on 2 degrees wide.
So that view is inside the spacecraft.
Wide.
On the left-hand side there, Victor Glover using the controls you can see.
Back 2820. Center docking target is 2 degrees wide.
Standing by for Orion to arrive 10 meters away from the ICPS.
Copy. I'm going to go ahead and go to course now. And I see we're at about 2.25 degrees wide. I think we're in the window to start braking. Let's start the outs. 1, 2, 3, 4 outs. That did not induce a lot of rotation, so not a lot of cross-controlling there and waiting for closure to stabilize. I'm showing us at about 2.
When he says cross-control?
Fine. Just to center us up, we're in fine. Going right.
Houston, 10-meter arrival confirmed.
Copy, Reed. Nice. You are go to execute forward target handling qualities test.
When Victor's
2.3 degrees wide, we're in the window.
Yeah, fine control, or sorry.
Is now moving into some precision translation.
Copy. We are within 2 degrees, definitely. I could do 1 or 2 things, but
this is fascinating. I like want to explain what's going on, but I also don't want to.
Okay, yep, I'm going to center it up, so I'm going to go down. I'm going to translate down.
Talk over them.
Just a little bit. I mean, we're talking about a fraction of a degree. Going to 6x, and I'm waiting for that cross to get centered, and then I will pitch up.
Cross-control explanation, probably too much.
Right there. Stop
to fit in here.
Now I'm going to pitch up, center it.
Glover is using the docking camera on Orion, looking at the ICPS that you see in the left of your screen.
That was very easy to do, and I show us as a flyout complete.
Look at that.
Copy.
That looks pretty aligned to me.
Houston, angular alignment complete, ready to begin fine handling qualities test.
Copy.
Copy. Affirm.
Yeah, you're right. We could almost do a video explaining all this.
3x zoom coming.
This is a zoom view from the docking camera on Orion.
Fine.
We are about 10 meters away from the interim cryogenic propulsion stage.
Y-axis ready.
Need ISOs of both these feeds. We could talk about all the things that he's explaining.
We're out and fine. Okay. Copy, a little opening. Back to center laterally. Okay. Yep, 2.75. Yeah, I see opening. Okay. So we're centered. 1, 2, 3, left pulses. Good motion. Look
at it drift.
All right, there's a half a degree, good motion, a little bit of down or up in on ICPS, and there comes 1, 2, 3 to null, about a tenth of a degree overshoot. We're looking pretty stable right now. We did have some upward motion on ICPS. I'm going to correct that out as well.
That might have been that cross control. You command it to do one thing and you get a little motion in another direction you didn't ask for.
I'll give one more out and fine. Okay, and 3 right. Here comes 3 right. 1, 2, 3 right. Center, good motion.
Yep, it'll drift the other way. We'll see that in a
Picking
second.
up a little bit of upward motion. 2.7 stable on the range, copy. And going to
That might be that cross control again.
1, 2, 3. You're centered. Do you feel that? Okay, a little rumble. Felt something here just a second ago.
When he says capture, he's
all right, and we're going to go
arresting the motion.
Up. I'll start measuring from the center. 1, 2, 3, up.
Show me the docking target cam again.
There's center, and we'll null 1 degree low. Overall, the control is very responsive. Not sure if it's the dead banding half a degree good motion, but I am doing a little bit more lateral correcting to keep it centered. And there's 1, 2, about a tenth of a degree overshoot. We got some lateral motion built up in there. I'll go left to correct that. All right, 3 downs to bring it back to center. 1, 2. Range is good. We had to do some opening half a degree. Good motion. Starting to take out the 1, 2, 3 downs, and we are centered. And so like that, it does seem to move a little bit more, but it's very responsive in the corrections, and so I was able to stop it right on the center. Holding at 2.6, 6x zoom going in. Ready. All right, half inner circle for 60 seconds.
Every time I see that docking target by itself, it looks like the full moon. Which is somewhat fitting. Whoa, that's a little more zoomed in. I am trying to see, does this docking target have a 3D component to it?
Copy. Minute.
I can't tell right now if this is flat or if this actually has a 3D component.
15 seconds until center on center.
Like sometimes they'll have a part that sticks up in the middle, and if you can see that part, it means that you are not exactly flat.
All right, going
like your
on and
orientation.
on. A higher gain there, definitely requiring some control, some more frequent control inputs.
Has like a relative angle
Stable
to
there,
it, so
now
that
trying to minimize inputs and see if I can hold that stable.
it does look like there's a shadow there on the bottom. Maybe.
Okay, time's good.
Houston, translation test complete. Would you like us to go to step 16 or 18?
I would like you to go to step 16 or 18.
Perform step 16.
Good, yes, 16.
I want the step where they actually... Oh!
That threw the phone across.
Holding at 2.5.
I want the step. I want the step where they go around and sort of
1 degree, good
go to
motion,
the
no
other
cross
target.
coupling, half a degree, and waiting for 1 full degree of motion. Stop. Wow, stop right on the line. No cross coupling, good motion. There's half a degree going back to the
I'm
center.
kind of surprised.
When he's talking about overshoot or
That's
stopping
very
right on the
close.
line, he's trying to get it to stop in a specific place and then saying how close he was able to get it to that exact spot.
Half a degree.
But now we're not translating,
And
we're
stop
yawing.
right on the vertical grid line. We had a little bit of a translation. Going back, yawing right, good motion, cross coupling, half a degree. Back to the center line, stop. Very, very nice control in the rotations.
Look at that. He was translating before. He was floating left and right and up and down without turning the spacecraft, and now he's turning the spacecraft without trying to translate.
Copy that, Dana. Thank you. Going back to center. Dana said looking out the window, she was able to perceive the motion of all the alignment tests that we just did.
Houston, we're in step 18, ready for back away.
Concur.
It looks super controlled.
That is course, showing course. 6 outs, starting now. 1, 2, 3.
You're hearing the voice of pilot Victor Glover. He is backing away from the interim cryogenic propulsion stage, having completed this portion of the proximity operations demonstration.
There you can see the photo on the right. Do you see the docking target in the middle of that photo? And then you see the cross sticking up from the middle. That's what I was talking about. You have that 3D element to let you know if you're not only sort of looking at it directly, but whether or not you're angled relative to the spacecraft. And that is too cool.
Glover is also able to control the brightness of the screen and of the docking camera that you see.
Now I would expect the degrees to get smaller. If that docking target was taking up 7 degrees of the field of view, as they back away, it should start to go down. It should go to 6 and 5 and 4. Just like if you're driving and you have a car in front of you, right? You get closer to the car, the taillights are bigger. They're wider in your vision. They're wider in your windshield. And then if you get further away, you can look at it. And they're smaller, right? They take up less of your windshield. You can sort of gauge the human eye and the way that your mind is sort of like mapped. Just has this processing to make this make sense to you. You sort of know, oh, that car's about this big, and am I getting closer? Am I getting smaller? Is it getting bigger in my view? Is it getting smaller? And you just automatically process that, knowing whether you're getting closer or further away. It's also why I complain about Jeeps, because their taillights are closer together, so it's harder. You think that the Jeep is further away than it actually is. Anyways, personal pet peeve.
Confirmation the crew has completed backing away from the ICPS.
We're holding right at 1.5.
Expecting that thermal turn to happen in about 1 minute and 20 seconds.
All right, I'm zoom 1x to watch the thermal turn.
Glover is also able to choose the zoom on the docking target.
Okay, there's a little bit less comms chatter now.
I think they're preparing also for the turn. I think it's. I was mistaken earlier, I think, where I said, oh, it's going to translate. I think it's actually the ICPS, the one that rotates.
Is the ICPS going to turn and they're going to stay in position?
I think so. And then there's another target on the side of the stage. I don't know if maybe the back channel can help us also with pulling up a picture of that. But there's a picture of it out there, and it shows the target that is on the side. So there's one on the front, and then There's another one on
stage
the stage.
to do a thermal turn.
8 pulses down. But I see motion.
Yeah,
I see pitch on ICPS.
ICPS thermal turn start.
Oh.
Thermal
Here
turn.
comes down.
There it goes.
Course.
Look at that.
1, 2.
Yes.
Wow.
8 down pulses.
No way.
Great view of the ICPS that powered Orion during the perigee raise maneuver and apogee raise burn.
I agree. Yeah, that's a
Here
great
comes
view.
the target, I think.
Look at
I can
that.
see the side docking
There
target.
it is. Haha, Victorioso seeing it.
That is a good looking American flag.
Okay, this is too cool.
The American flag.
Copy.
It reminds me of the pitch maneuver of the shuttle when you arrive to the
Again, this view coming from the docking
station.
camera on Orion.
Yes, the docking camera. It reminds me of KSP. Like when you tell something to, you go and you give it a little coast and it just really slowly rotates like that. That's exactly what it looks like.
Copy that, Amy. We'll start working our way down.
Reminder, we are not docking today. This is a test of how it feels for
Thanks
pilot
for the
Victor
reminder.
Glover to manually fly the spacecraft.
You never know who might not know all the
He's
details.
using the
Oh,
zoom
wow,
feature
look
on the
at-
docking
speaking
camera
of details,
to get
Look at
exactly the
this.
view he wants as he
I could
prepares
read
to
some
move
of those
in.
letters.
And
Look at this.
See, you can see some of those.
I mean, the spacecraft turned, not the spacecraft, the ICPS, the used old part of the spacecraft they don't need anymore, except for these operations, turned itself 90 degrees and then stopped. And now they're lining up with another docking target.
You can see the bolts, the individual bolts there as well. That's so cool.
It's very riveting. Yes, Grumpy Australian, this is very riveting. You can see every rivet in there.
And I definitely want to lose this in the data, Amy. The separation was way back when we separated from ICPS. It was very aggressive.
Integrity, you are go for approach to side target to 15 meters and to execute handling quality test.
There we go.
All right. So we're going to approach again. We'll probably hear some call-outs about the
Picking it up in step 20. I'll copy.
We copy.
degrees.
Oh, it's almost 2 degrees wide.
There you go, 2 degrees wide.
And you know why this is important too? Because for Blue Origin, the Blue Moon lander has the docking target on the side. The docking
Almost
port is
at
on
2
the
degrees
side.
wide, and here comes 4 outs. 1, 2, 4.
4 outs. He's telling it to slow down.
Yeah.
The rate of close with the target there.
All right, 2 plus or minus a quarter. We are
Houston 15-meter hold is confirmed.
Copy.
Well, that was fast.
Orion is now 15 meters away from the interim cryogenic propulsion stage.
Yeah, that's a target. It's a target on the side of the ICPS that they're looking at. There's that live view from inside the spacecraft.
good motion.
You can really see the controller there now.
A lateral, we might have a tad bit of closure and coming right to 2. All right.
Tell it to stop, capture the motion here.
Yeah, about a quarter of a degree, less than a quarter of a degree up to 3 rights, 2.1 degrees wide. Good
There
motion.
it goes. He said 3 rights, so now we're going to drift this way. Listen for him to capture it again.
All right, here come the lefts to stop it. 1, 2, 3.
Tell us how close.
3 downs. 2, 3. Start measuring from the center. There's center. Good motion.
And Houston, with this sun angle, the white paint on the ICPS is so illuminated.
Half a degree.
It's hard to look out with the naked eye.
1.
Houston copies.
2. 3. And we picked up a little bit of motion to the left
Yeah.
in ICPS.
A little bit of a drift.
Okay, stopping that, directing it back up. 1, 2, 3 to bring it back to center.
He was telling it, from this perspective, the target's going up, but it's because Orion is going down, because Integrity was drifting down relative to the ICPS. So in the screen, the target looked like it was going up. And when he did that, he got a little left motion that he didn't command. It sort of drifted a little bit to the left, but look how under control it is.
Proximity operations demonstration.
This is too cool.
All right. 2.1 degrees wide.
The degrees you hear pilot Victor Glover reporting are the amount of space that the docking target is taking up in his view that you're seeing here on the docking camera.
Is good for 21.3.
Ah, the cockpit is so illuminated now.
Yeah, yeah.
Good range. Good time.
6x zoom is good.
Starting the lateral alignment test.
This is just fascinating. I'm so glad they could have done all this and not showed it to us, right? They could have just gone up there and then we could have had audio only comms or something. But getting these live views back, especially two camera feeds,
inside 15 meters.
The forward camera and the internal camera.
It's not doing a whole lot of commanding. It's holding quite steady. When I'm not doing anything, it's holding nice and steady. The camera and the vehicle are holding steady. It's almost at the center. I will get set up for center on center. Cross over docking hatch cross. All right, we're starting precision. A higher gain, higher frequency of inputs. It's very responsive. I just have to make inputs because it does seem to pick up lateral motion. Commanding.
Interesting.
I'm able to hold the magenta cross within the width of the black cross on the side without, I was talking, it went out, but overall, able to keep it centered, less moderate or less effort. Okay, complete.
Houston, translation and test complete.
Very precise control. That you
Copy, and you are go for the multi-axis test, and Reed, you are coming in much lower volume than Victor.
Hey, we know how that goes. It's because he's tired. His brother just went to sleep.
At least he's not talking while muted, you know. It could be worse.
Again, pilot Victor Glover on the left side of your screen is manually piloting the spacecraft, executing the 6 degrees of freedom, translating forward, backward, left, right, up, and down, and rotating the pitch, yaw, and roll of Orion in relation to the interim cryogenic propulsion stage.
Well, when you say it that way.
Course selected.
Again, that camera view.
Right on THC. Ready?
With the target on it. Used to be connected to their spacecraft. And they separated the two things. That's the ICPS.
The yaw out to 2 degrees. It's there.
The interim cryogenic propulsion stage.
Decided to.
That they are dancing with right now.
Integrity Houston, no action on the caution warning messages.
Gave it some ends.
We copy that, Amy.
All right, lateral motion is held. Okay, 355 for 355.
Somebody needs to edit this with a Kerbal that flies by.
All right, nice and stable, focusing on range. Out, got a little opening, some ends to correct.
Jeb drifting by.
Got some dynamics there at the beginning, going yaw, then translation, yaw, and translation, but caught up, was able to correct it out without many problems, moderate or less workload. Now it's very stable, just focusing on range. 50 for 345, and at 345 we go left. $50 for 345.
I hope we get to see all of those amazing pictures that they're taking with their iPhones.
Yeah. You mean with their undisclosed camera phones? Their undisclosed personal devices?
Range is good.
Are totally not iPhone 17s.
48 for 3.5, nice and stable, so we're in a good position to go course.
Also, I just want to say, this crew has been awake since at or before L-8 hours, so they've been going for over 12 hours at this point, and he's hand-piloting a spacecraft.
Degree of freedom yaw test.
7 for 3.
Me too, though. But I'm not piloting a spacecraft.
Yeah, I mean, I've been on air for longer than that, but I'm not piloting a spacecraft right now, and I don't exactly have to make my words make that much sense. I mean, I think we're all in the same boat here.
Planet or whatever.
I'm 0 miles from the planet.
You know, like on the second story or anything? Or I guess the
dropped
first
off
story?
a bit. I put it back in.
To the nearest mile, it rounds to 0, Das.
It rounds to 0, nice.
$342.
Oh, you can see there sort of the change in perspective from that yaw.
Uh-huh.
Yaw is left and right, basically.
Yeah. I just want that screen, like full screen. Zoom in again. This is just fascinating to watch. It's very cool.
Of course. Stand by.
To hear him say something and like understand what he's planning to do and then see it happen.
Get out of course and just go fine to try to know a little bit. Oscillating around centered. Okay, I'm ready. Pick that. All right, got a good yaw rate. I'll watch the yaw rate closer this time. Fine. And, okay. Too many. I did that in before to fine. Back to, all right, going out.
This feels like more of a qualitative sort of thing. Like he's
out,
not doing the exact commands and tasks in a very specific order.
Everybody concur? All right, thank you. I'm going to go back to fine. All right, that yaw rate is slightly dropping off. I'm 348.
Somebody in chat made actually a very good point that these two vehicles are orbiting Earth.
355 going to
Many kilometers out there and at incredible speeds. And they're holding steady.
Yep. The relative speeds are almost nil. The only relative speeds they really get are from a very small difference in orbits, and then the speeds that Victor's commanding. Like he's telling the spacecraft to change.
54. Yeah. All right, there's pick course.
And remember, this telemetry, this video, is coming down via the Deep Space Network. I mean, that's crazy.
Yeah.
Again, a little dynamic at the beginning, but to stabilize all the motion and correct it. Going up on 0.
Yep. If you're still watching, they are manually testing the controls of Integrity, the Orion spacecraft that will take them around the moon.
Coating on the fabric on the behind the docking target moving as we. All right. We're stabilized. About 1.75.
Houston, y'all multi-axis test complete.
Copy.
I do.
Change some exposure there, look like.
And in terms of timing, we still have a little bit over 10 minutes to go in this demonstration of the manual capabilities of Orion.
Is that where they get to the freestyle portion of the event?
Okay. I think we've stopped the opening.
Where he gets to really show off?
After that, the proximity operations demonstration ends, and then there's going to be what is called upper stage separation burn at T plus 4 hours, 50 minutes. Half an hour from now.
Copy. Yeah, hey Cassie, this is Cassia. Actually, this is real.
Yep.
Read ready for you to go to instruction 169. You are go for the multi-axis maneuver biased tail to sun.
And they're still in orbit around the Earth. Still not
Yep.
TLI.
Yeah,
That'll
they
be
are not
tomorrow.
on the way to the moon yet. I'm not sure right now exactly what their altitude
Coming up on
was.
1 hour since separation from the
Was
separation from the
coasting.
interim cryogenic propulsion stage, again, almost an hour ago, and now 4 hours and 20 minutes since liftoff. We are getting closer to the tail end of the ProxOps demonstration.
They've got about 10 minutes, human being, left in this portion, but 10
Again,
days.
during this demonstration, Victor Glover, the pilot aboard Orion, was manually piloting the spacecraft in relation to the interim cryogenic propulsion stage. You can see that ICPS on the left side of your screen, and that ICPS visible through the docking camera.
356
We keep-
to 353. Copy.
You keep hearing docking camera. They're not docking
to
with
on
anything.
the Artemis 2 mission, but this test helps us understand how Orion flies manually and helps us prepare for future missions when we'll need to dock to a lunar lander.
Is she reading our chat? Like,
If you got any questions, Leah is answering them, basically.
Leah is there
It's
to answer your questions. I'll pass them on to her. She'll
already
answer.
ahead of the game.
Throw another yaw in there to keep it at point 2. Yeah. Overall, guys, this flies very nicely. Copy. 347 for pulse.
NASA Comms is watching our stream, so they know what they need to explain.
Yeah, lots of questions in chat, of course. Some people
What
are
Glover
very
is
well
using
aware
to
of what's
command
going
the
on.
spacecraft,
Some others
the
don't.
translational and rotational hand controllers.
Very precise.
Just keep listening and you'll...
3x.
Don't worry.
Yeah.
It's the 3
Well, they're coming up
pitch down, going in.
on
Orion
the
is
end of
using
this
the
portion.
24 reaction control system thrusters on the European service module.
358 set. All right, going back to center. So course, then getting the docking count, target back to center.
Yeah.
Focus on being stable.
Jake,
Yeah, the thruster firings are a lot less aggressive than I thought it would sound or feel, like driving on a gravelly road. The response is quite immediate. Not all the X's are even. Roll is very slow, but pitch and yaw are very snappy and responsive. And when you have the zoom set right, you can see very small motions, and so translations are all quite tight and very nicely balanced.
Nice.
See that comment about the Deep Space Network? It's evolved a lot since Apollo, I can tell you.
Yeah.
I see you in chat.
Yeah, you can call ICPS the booster. I mean, it kind of boosted them away. It's not the big core stage booster, the big orange booster, but technically it gave them a little bit of a boost.
Yeah, and the TLI burn should be tomorrow.
Auto inertial.
Around the T plus 25 hour mark.
Just going for stable. We're stable.
Step 25.
Currently, Orion is about 15 meters away from the interim cryogenic propulsion stage. At the conclusion of the proximity operations demonstration,
Minus 26.
For the DAP 18 authority DAP.
Less than 10 minutes left in this, right, Alex?
And Reed, please repeat.
Holding on instruction 185, just want to make sure you are ready for DAP 18 and go for departure.
Go for DAP 18 and go for departure.
There we go. Go for departure. They're going to
Nice.
separate away.
Copy, Houston. That's in word.
Capcom Amy Dill calling to the crew. They are go for departure from the interim cryogenic propulsion stage.
3 outs.
I'm still amazed by that view in the bottom right.
Houston,
Like, imagine if we
integrity
had that
departure
perspective for
initiated.
Apollo missions.
Yeah, right.
Orion is now backing away from the interim cryogenic propulsion stage. The proximity operations demonstration is complete. Coming up next, we will have the upper stage separation burn, providing distance between Orion and the ICPS.
Oh, wow. Look at that.
Let's go.
What? What are we looking at?
Victor, describe it.
Copy. Go
Tell
on.
us there's
Looking up
still...
out the
Great flying with you,
window.
Houston. Nice vehicle.
Oh, he did? Did he finally
Great
get a
job,
chance to look
Victor,
out the
and
window?
The entire crew, and we enjoyed
Yeah.
your excitement at seeing ICPS out the window.
Nice.
Yeah, you can see it's now kind of strapping back in. He unbuckled and floated up to the window.
I am bringing the exposure control down to 1 so that we get some video. Let us know if you want that higher for your bearing test.
Setting of 1 is good for us.
He was
Well,
done.
you can sit.
He was done flying the spacecraft, so he could unbuckle, so he could float up and use the old Mark 1 eyeballs out the window. Because the other astronauts were looking out the window, and he was like locked into those screens in front of him. But before
This
they
is a live
lose
view
that
from
target,
the vehicle ascent and launch operations room. This is Valor, the ULA launch team support room.
Oh.
They are responsible for observing any program issues that may require their experience to correctly detect and assess. They've been monitoring the health of the ICPS prior to launch.
Houston, no action on the cautions.
Yeah, ULA.
They've been monitoring ICPS since before launch, through launch, and obviously during the proximity operations until the ICPS end of mission.
ULA is the one that made the ICPS. So,
hey,
Of
good
course.
job, ICPS.
indeed.
Okay, all right, good. I was like,
inside
is that all the
Orion,
views
we are
we have from inside of Orion? But apparently not. if they were just going to show the ULA desk, I was going to be done. I was like, all right, hey, good stream, y'all. Thanks for watching. But we're back inside the spacecraft. So, oh, look at that.
There we go. You can see the engine
S4V.
nozzle.
S4B vibes right here. S4B vibes.
Look at that. That's that nozzle extension that went in.
That selection
Yes!
of shots.
Yes. Who did this? This is good.
Kevin, probably.
The moon and the ICPS. Now that stage is done. That stage up there that you see is going to enter the atmosphere and be disposed of.
Well,
But
actually,
we're
first it's
seeing
going to
it.
conduct a disposal burn at 5 hours and 11 seconds exactly. It's going to be performing a burn to ensure it plops itself into the Atlantic if it doesn't burn up before it gets there.
Right. That's too cool, though. Now, oh, they're changing the exposure. Nice. We've talked because this is enthralling now that we're sort of at the end of the prox ops and they're backing away from that. They're not going to be anywhere near it whenever it does its disposal burn. Can y'all tell that we're enthralled by this? Like, we are very interested in this entire mission, in all the minutia. Like, we are going bananas over joystick inputs. Which is a little bit ridiculous, but that's also where we are, like what we sort of do. But we are not done covering this mission, because we have set up a stream that will go for 10 days. The entire mission, we are going to be live for the next 10 days. Now, I'm not going to be talking for 10 days straight. Are you, Ryan?
I think I've got a little bit of energy left in me. Not 10 days worth. I'm going to look forward to a little bit of a sleep before waking up tomorrow, way ahead of the TLI burn.
I think the crew too.
But we are going to do marathon coverage of this, and every time there's a big event like the TLI burn, about 24 hours after liftoff, we'll be there doing more commentary. And whatever views we get, whatever telemetry we get, we're going to be covering the whole shooting match for you. So Alex has linked up that 24/7. It's actually technically, Alex, it's 24/10, not 24/7.
Okay, sure.
Because it's 10 days, not 7 days.
Yeah, but I'm basically spamming it in chat. So if you're
spamming that in chat, that's fine. Yeah. So we're going to be checking in there. We're going to be giving some commentary during big events. We'll check in if there's big updates and keep y'all informed. But we're going to be doing it our way, right? Y'all know us. We sit here and we wig out about this stuff that we think is ridiculously cool. If you've had fun hanging out with us, you think this is interesting, you've learned something, maybe, I don't know, maybe you have, you can check in with that 24/7 stream. You can even put it up on a TV, like use a smart TV app and use YouTube. Install YouTube on your and just put that up and just leave it in the background. You walk by, you're cooking dinner, you're getting a snack or whatever, just check in on it. You'll be able to see, because we'll be running that the entire time. And if you come in every now and then and we explain what's going on, we hang out with y'all just a little bit. So,
can I say something?
Any event, of course you can, yes.
That stream will be running 24/10, I guess. You corrected me, right?
Thank you, Alex. Thank you.
But we will have dedicated coverage for the big items, the big events, right? We will be giving, as you said, little updates here and there every now and then. I'm not going to promise a certain periodicity, I guess. But we'll shoot it for a rather regular update cadence there. But for the dedicated streams, you know already the next one is already up there as well in our channel. It's, of course, a TLI burn. We'll be covering dedicated the TLI burn tomorrow. So just saying, if you go to our channel, you go to the live page, and there'll be already that TLI burn stream there for you to reminder and everything.
Are we getting played out? They just turn on the music and tell us to stop commentating? We're going to the moon! Come on! Couch! Good grief, do you think the astronauts get to go home? No, they're going to be in integrity, doing their thing, and you're going to go home and go to sleep? Seriously? Folks, they're just going to keep turning up the music until we stop talking. So we appreciate y'all hanging out with us here. You know how to get back to, actually I could just turn this down so I don't have to listen to it and just keep talking. You know how to get back to the stream. You know how to find the other streams that are going to be happening here on the channel. Also, all the stuff, there's so much support that came in today, and there's no way that we could have read it all. Literally hundreds, if not 1,000 messages in the support queue. We couldn't have made the entire stream just reading this. I don't know, Ryan.
You're going to make me run through all that entire support queue?
Messages? I was just doing the whole disclaimer about how there's no way we could read everything. Ryan, you don't have to. No, you're good.
It's 10 hours. It goes back 10 hours. If I read through that queue, we'll still be live by the time of re-entry.
You have until TLI to finish the support queue. Go.
Yeah, still have 20 hours or so go ahead.
No, y'all have absolutely killed it with the support today. Also, the shop, like I said, we sold out of pins, the commemorative pins. We're getting more of those made. We'll get them expedited so that y'all can get those as soon as we can. Patches, we still have patches that are ready to ship if you want to pick up one of those patches. The pin mounts, the shirts, the little baby covering if you need to cover a baby, whatever. Y'all have absolutely killed it with the support. All the good questions in chat and that sort of stuff. I want to start by saying thank y'all in chat for
Somebody in
watching
chat
us.
Said
What?
to do it on the 2410 live stream.
Just switch to the
we put
2410
Ryan there,
stream.
and he just spends like 2 hours reading the super chat.
Yeah.
We're gonna need like AI Ryan voice. We need to train a language model in Ryan's voice and inflection and have it read the super chats. We're not gonna do that. Anyways, viewers, thank you for supporting what we do. Quick round the horn here with the team as well. Ryan Caton, fantastic job.
Thank you. That was fun. I was, I'm not sure shocked is the right word. Shocked is not the right word, but it's the best word I can think of right now, because I felt the same thing with Artemis 1, and the thing with this vehicle is they can pause and stand down for the day at every single moment of this 49-hour countdown until they light those boosters. Once those boosters lit, they're going. They're going somewhere.
It went,
you know,
actually.
Even when the RS-25s ignite, there's always a voice in the back of your head going, they're going to stand down. They're not going to go. And then suddenly the boosters light, and it's like, okay, we're going back to the moon. We're on the way. Yeah. I'm so excited. I mean, we have been waiting for this for years, and finally, the Artemis program is no longer a figment of our imagination, years in the distance, on the horizon, that feels constantly just out of arm's reach. It has arrived. It is now. It is today. And all going well with translunar injection, we're going back to the moon as soon as... Let me put up the timeline here. When's lunar closest approach? Lunar closest approach is 5 days, 1 hour, and 23 minutes after launch. In 5 days!
That's too cool.
Oh boy.
So get some rest, Ryan. We still have a lot of coverage to do, don't we?
I've still got a video to get out.
Wait,
Yeah,
is the
breaking
sun
space.
coming up here? Oh my gosh, it's getting bright outside.
Is it?
Huh. It is in Norway, Alex.
Yeah.
How is it where you are?
Yeah, I think sunrise. I'm actually looking it up. Yeah, it's not for another 3 hours here in Seville.
I have some extreme latitude right now. That was Ryan Caton. Also, the voice you've been hearing quite a bit here is Alejandro Alcantara Romero. Thank you for joining us, dude.
Yeah, it's a pleasure. My heart was really racing. I was looking at my BPMs and everything during that final moments of the count. I had to go out and I took a what's it called? I forgot the name in English. I'm sorry. It's one of these herbal teas or whatever for relaxing or whatever. Chamomile. There we go. I grabbed one of those because I also had, with the jitters and everything, I was not feeling too well. But hey, it worked because it got me fired up for Ascent. It's been so cool so far, and it's just the beginning. There's still many more hours in the mission, many more days. Tomorrow we've got that TLI burn. Even before that, there's a Perigee race burn that Ryan will do around 13 minutes into the mission. You can watch that on the 2410 live stream, of course. And tomorrow we'll be out there, of course, with a dedicated TLI burn stream. So, yeah, lots of things to still look forward to in this mission.
Good deal. A quick rundown of some folks we don't have on comms anymore out in the field. We had quite a few people. Max Evans was out there. You heard from Sawyer Rosenstein with those interviews quite a few times. Jerry Pike never got on the stream, but was running around plugging in cameras and helping out with network stuff on that side. Julia Bergeron was out there in the field. Gage Telez was out there as well. D Wise with the slow motion footage, that ridiculous slow motion that D caught. I guarantee you're going to see that all over the place, social media, shorts, whatever. We are going to go all over the map with that.